respiratory problems, and even premature deaths. Hence, it's not just a matter of environmental concern alone, but also a matter of public health and social justice. To achieve clean air, we must harness the power of science and technology to transform our energy systems, transportation methods, and industrial processes. We need innovative solutions that reduce emissions at the source, which also efficiently monitor air quality and provide timely data for informed decision-making. However, these breakthroughs truly make an impact when they are embraced by the society. Hence, cleaner air and healthier communities can be achieved by scientific methods, technological advancements, advocating for policy changes, and inspiring collective action. For today's session, you can look forward to the discussions on environmental justice, sustainable urban planning, air quality measurement and control approaches, and public awareness and sensitization. We really look forward to your active participation for the day. And before we move to our first session, I would like to provide a brief overview of the logistical details. Today's schedule has 8 informative sessions, and we have a 45-minute lunch break at around 1:15 and a tea break at 3:45. I kindly request you all to adhere to the time slots allocated, which will ensure the smooth flow of our event. Speakers who haven't yet submitted their presentations are kindly requested to send it to Dr. Piyush Bhardwaj. Dr. Piyush Bhardwaj, can you please identify yourself again for the speakers who are attending the conference for the first time today? Thank you. And lastly, I would like to invite you all to share your thoughts and learning from the conference on your preferred social media platforms with hashtag ICAS 2023 and tagging CSTEP, which will help us track all the conversations around ICAS. So now, without further ado, let's start the welcome address. And now, I have the privilege to invite on stage Shri Ishwar Khandre, the Honorable Minister of Forest, Ecology and Environment, and Dr. B. Sen Gupta, former Member Secretary of CPCB. May I kindly request you to please take the dais, sir. Shri Gaurav Gupta, IAS, sir, was also part of the panel, but I would like to mention that we definitely face challenges when the senior bureaucrats are part of our sessions. We regret to inform you that he will not be joining us today as he has been called by the CM. So we can start with the welcome address now. And I request Dr. Pratima to come on stage and felicitate Shri Ishwar Khandre and Dr. B. Sen Gupta. Shri Ishwar Khandre is the Forest, Ecology and Environment Minister of Karnataka since May 2023. Sir plays an important role as the chairman of Shanti Vardak Education Society. Previously, he was also inducted to the position of Minister of Municipal Administration and Public Enterprises of Karnataka, and he was also the minister in charge of the Bidir district. Sir, I request you to please come and share your thoughts with all of us.
Good morning, everybody. ಎಲ್ಲರಿಗೆ ನಮಸ್ಕಾರಗಳು. respected dignitary on the dais, of the dais, respected delegates, organizers of this program, Dr. Jay Ashundi, Pratima Singh, and dear friends. Thanks to the organizers of Indian Clean Air Summit 2023 for having me with you this morning. First of all, I would like to begin by congratulating the Center for Study of Science, Technology and Policy for hosting this important event on air pollution in our country in the city of Bangalore. As I was going through the brochure of the event, I was pleasantly surprised with the fact that so many sponsors had come forward to help sponsor this key initiative. It is quite heartening to learn that so many private concerns are now coming together for a cause that affects all of us. And frankly, it augurs very well for society, for the city also, and our country as a whole. We all live in fortunate times, you and me. But these fortunate times might not last. Today, our collective survival is at stake, thanks to one of the biggest threats to our continued existence and sustenance on Earth, that is climate change. In these times of great uncertainty, we have a collective duty towards protecting whatever is available. We have built this far for our future generations. In fact, in the year 1987, the United Nations Brundtland Commission had defined sustainability as the ability to meet the needs of the present without compromising the ability of the future generations to meet their own needs. But are we really giving them a fair chance at survival? We have to introspect. This is the most pertinent and important question perturbing the global scientific community, policymakers, intergovernmental bodies and all other stakeholders, all of whom are working to the best of their abilities to arrive at a pathway, the very pathway which can be a key to our continued survival. Human beings as a species have always aspired for betterment. It is this quest that has ushered in this wonderful technological revolution where pretty much everything is in the realm of the possible. But to be able to achieve this level of finesse, we have severely compromised our environment, degraded it and are polluting at a large scale, making us vulnerable and pushing us all at the verge of serious climatic events that threaten the very survival of life on this planet. That brings us to a very pertinent question: development for whose sake and at what cost? When I was sworn in as the Minister of Forest, Ecology and Environment for the state of Karnataka, I made a commitment to myself that I will make it a point to contain environmental degradation, try to reverse it, control pollution, and help usher in the concept of sustainable development in our state. But for me to be able to do that, I will need the cooperation and support of all of you. The path ahead won't be easy, but we have to strive towards it to be able to make a difference. Rapid urbanization is a boon as also a bane. Boon as it has helped our economy grow multifold, helping bring in more populace into the workforce, helping alleviate poverty. Bane, it has also led to an increase in demand for more livable areas in the urban locales along with an entire industrial ecosystem to support it. This support ecosystem, which includes rapid industrialization, mass construction, logistical support, energy production, etc., which have their own spatial and material requirements, is one of the main causes of degradation and subsequent pollution. While the pollution can be broadly classified in 4 different categories, let me highlight the one that is headlining this event: air pollution. At no time in the collective human history has this issue been more acute and central to our sustenance as it is now, more so after the calamitous times we witnessed during COVID-19 outbreak. According to multiple reports from reputed organizations, more people became susceptible to the infection due to the lack of resilience courtesy of the lung ailments caused by prolonged exposure to polluted air. Yet still, this problem might not be addressing with the kind of alarm and seriousness that it deserves. In fact, I would specifically like to point out the case of New Delhi over here. Every year in the winter session, the megapolis that is New Delhi turns into a gas chamber thanks to the very bad quality of air and thin haze descends upon the city and sticks continually, making breathing a laborious task for its residents. There are many reasons that are attributed for this terrible scenario. The chief amongst them being stubble burning in the vicinity of the Delhi NCR by the farmers who are there after collecting the harvest. Years of neglect and no planning by the governments has led to the air quality deteriorating across many cities in our country. The situation in the industrial towns and the ones close to major mines isn't good either. Bengaluru, our hometown, can also go down that path, before which we have to effectively arrest the downward spiral and reverse the trend. I would like to highlight some of the key initiatives our government is working on to help improve the quality of air across the state. As green cover acts as a major carbon sink, we have taken up the task of afforestation in a very big way with a target of planting 5 crore trees annually in our state. Until today, we have planted nearly more than 3 crore saplings in just 2.5 months. We are in the process of regulating the highly polluting industries in the state, especially the ones from the red category, which have a propensity to contribute towards the further deterioration of existing conditions. We are in the process of identifying such places in our state which are very badly affected so as to be able to find effective and efficient solutions to help better the situation over there using out-of-the-box solutions, including but not limited to the latest technologies being adopted by the developed countries. We are an emerging economy, and our reliance on fossil fuels to keep up with the upward trajectory of growth is quite justified. More so as we don't have very viable and inexpensive green options that can be deployed en masse. Not just yet, but we are working towards it. Transitioning into a carbon neutral economy can be the best possible solution to help contain pollution and to fight the vagaries of climate change simultaneously. But it will take a lot of effort from all of us stakeholders to reach there collectively. We can, but we will have to work effectively towards it. Mission Life program by our central government is a positive step towards that new tomorrow that we are all keen on achieving. Although not perfect, it is still an important initiative that was long overdue and is helping bring about a change in perception and augurs well for our country. Lastly, as your minister, I will strive to make the urban locales of Karnataka, especially the beautiful city of Bangalore, more sustainable, the air in these areas more breathable, and to try and reverse the environmental degradation as much as I can with your support. Thank you. Thank you very much.
Thank you so much, sir, for that impactful speech and addressing the challenges around air pollution and also highlighting the plausible solutions. Thank you. Moving forward to our next speaker, Dr. B. Sen Gupta is an environmental professional. He worked in Central Pollution Control Board, Ministry of Environment and Forests, Government of India for about 30 years. He served as Member Secretary of CPCB for about 10 years. He has vast experience in the field of air and water quality management, industrial pollution control, standard development, environmental impact assessment studies, and many more. Sir, I would like to call you now and request you to share a few words with us.
Most respected Honorable Minister for Environment and Forest, Government of Karnataka, the participants here, very senior colleagues of mine has also came from the Delhi, so I have seen many. Dr. Pratima Singh from CSTEP, and I'm thankful to her for inviting me to this very important technical session and giving me the opportunity to give my thoughts on air pollution control. What are the science behind this? What are the technology requirement for air pollution control in coming years? A lot of efforts are being made. And I also fully agree with Dr. Pratima Singh that science and technology should be part of all the air pollution study and all the air pollution program. Yesterday, I have a very detailed discussion in the Karnataka State Pollution Control Board as well as the Regional Directorate of the Central Pollution Control Board. I know that good work is happening in the Karnataka state for air pollution control. But overall, I think a lot of new areas and major thrust areas are there, which I will briefly highlight in my presentation so that these things can come in your agenda. So I will start with the air quality monitoring, which most of the state and the Center Pollution Control Board are doing. Presently, we have 500 online continuous ambient air quality monitoring stations, 1,500 manual air quality monitoring stations. But unfortunately, these monitoring stations, instruments are not calibrated properly. So sometimes the data quality is not very, very good to use that data for any policy formulation. So my humble request to all the experts here to throw some more concern, some more energy on the area of the calibration of the equipment. So that's number first, because unless the data is good, your modeling, air quality modeling, your source apportionment study will be not very useful because the basic data are not up to the mark. I will give an example. Because all this air quality data through the CPCB and SPCB server are going to the website of the various agencies. So now the data, if you analyze the last 1 year data, suddenly we have seen that the Begusarai and Gaya, where in the Bihar state, where there is no more major industries are there, no major air polluting industries are there. Vehicles numbers are very low. If you compare with the Delhi, maybe it is 1 by 100 number. But the air quality becomes so high and it becomes the world most polluted city, and the WHO has reported suddenly. So this type of data quality, I think require more attention. Second one, again in data things, are the continuous emission monitoring system, which as per the CPCB requirement, all the major industry, red category industry, they have to install. But again, if you see the quality of those data, and if you check the data with the manual monitoring, you can see the vast variation. I remember the CPCB recently filed affidavit in Honorable NGT about the variation of this data, where the online monitoring SEMS data and the CPCB's manual monitoring data, the variation is as high as 70 to 80%. So it is very difficult to believe in all the continuous emission monitoring system which the industries have installed, because most of the time if you see the server of the CPCB and SPCB, industries are complying with whatever the notified standards are there. So there are again a strong requirement that we should properly calibrate as per the CPCB protocol so that the quality data is generated. That is my first point I want to mention. Second one is we have identified CPCB and MOEF along with the State Pollution Control Board 43 critically polluted areas based upon the SEPI index. And there are 44 severely polluted areas. And Karnataka, sir, in the Karnataka also there are about 7 or 8 critically polluted areas. Now we have to prepare a good action plan. Now what is happening, the many states are following the CPCB protocol for preparing the action plan. CPCB protocol cannot be adopted by states because the conditions are different in the states. So I think the action plan, a very sound action plan to be prepared for the critically polluted areas, and that should be implemented. This should be based upon the proper inventory, proper source apportionment study, proper air quality modeling, proper information about the health, what is the population's health, how it is affecting the health of the people. These are all should be considered while preparing a very good, sound, technical action plan, which will then, if it is properly implemented, it will give the correct results. Third point I want to mention is the major 17 categories. CPCB and MOEF has identified 17 categories of highly polluting industry. Thermal power plant, iron and steel plant, refineries, petrochemical, fertilizer, distilleries, cement plant are those 17 categories. And most of these categories of industries exist in state of Karnataka. Now, for every sector, I think we have to relook whatever we are doing so far, and considering our responsibility of the climate change issues, like we have to reduce the greenhouse gas emission. So our action plan to control the emissions from these 17 categories of highly polluting industries needs to be remodified. For example, the thermal power plant, we have to see that as per our commitment to the climate change convention, we have to phase down the old thermal power station. In that place, we have to put more non-conventional based energy sector like solar power, wind power, etc., to get our energy needs. And the existing coal-based power station which will remain there, we have to put very additional control equipment for sulfur dioxide, oxide of nitrogen, by putting the FGD and the DNOx system so that the SO2 and NOx can be controlled. So far, barring few power plants in our country, none of the power plants have installed the flue gas desulfurization. Same thing happening in the Karnataka also. So I think if you uncontrolled SO2 will create more problem, because if you see that the major sources of SO2 are coming from the coal-based power station, where the SO2, whatever sulfur present in the coal is coming as a sulfur dioxide, converted to sulfate and become part of the PM 2.5 and PM 10. So we have to, very important that thing, we should install the flue gas desulfurization in thermal power plants. Now the particulate matter emission control, so far we are relying on the ESP, but then now time has come, we should have the hybrid system, ESP plus backfilter together. So although the industries, thermal power stations have installed the ESP, but their emissions they are not complying, because if there's a smoke, visible smoke is from the chimney, that means they are not complying with the standard. Unfortunately, the same data shows that they are complying with the standard. So this type of ambiguity is there. So we have to relook into, and this hybrid system, which is very successful in some of the industries in our country. NTPC had set up the backfilter and ESP together in series to control the particulate matter emission less than 50 milligram per normal meter cube. That should be adopted, because the time has come that we should have the stringent emission control thing. I will take another example of steel plant. Steel plant, is a highly polluting industry. So there is a lot of changes have to be made in steel plants. For example, we should go for the direct reduction of the ore. We have to, coke oven and sinter plant, we have to just phase out. And that is possible. In the international scenario, there is technologies are there, we can go for like in major steel plant in the country are located in Karnataka. So I think I urge the Honorable Minister to kindly consider that the new technology which has come for the steel plant, like the direct reduction, omitting the coke oven, which is the highly polluting, then the use of the green hydrogen. So I think Japanese and European steel plants are using partially the green hydrogen in their blast furnace. So that type of technology should come. Then the coke oven plants, whatever is there, are discharging cyanide-bearing effluent. And so far, I think not much has been done, and this cyanide is going to the environment. So we have to check it. And there are technologies are there, we can go for the cyanide control from the effluent, especially the coke oven byproduct plant, blast furnace plant, which is generating the cyanide-bearing effluent, and the thiocyanide are there. Next one is the cement plant. I think cement plant, again, Karnataka, there are a large number of cement plants are there. Cement plant is one of the very important thing is that cement plant can take care of polluted waste from the other industry. That is, we call the co-processing of the waste in the cement plant. As the policy of the Karnataka government and the government of India is that we have to go for zero landfill by, say, 2030 or 35, cement plant can play a very important role. Many industries waste, like the pharma industries waste, pesticide, refinery, oily sludge, everything can go for the cement plant for co-processing. And that will not only reduce the greenhouse gas emission, but also help us to achieve our zero landfill target, which Government of India has set up. Similarly for refinery, because we have the very large refinery located in Karnataka, where we can go for the use of clean fuel. In place of the furnace oil and other highly polluting fuel, we can go for the clean fuel in their heater, in the boiler, furnace, etc. We can increase the SRU efficiency. And one of the important things which I discussed yesterday is the VOC, volatile emission control, regulation and implementation of the standard in the refinery. I think none of the refinery, we have the 16 refinery, barring one refinery, none of the refineries are doing much on the VOC emission control that is required. So these are the things which are required to technology. Technology play a very important role for pollution control. I want to emphasize that only pollution monitoring will not sufficient. Pollution monitoring and then analyzing the data will not sufficient unless we do a proper pollution control, well-planned pollution control regime we will start. Because if you see the Air Pollution Control Act and the Environmental Protection Act, everyone says that we have to control the pollution at source, and for that, new technology is very important to achieve. Pollution monitoring, pollution modeling, etc. are a secondary thing. That is to give you the idea about how much pollution is reduced. But first objective for the Pollution Control Board and the government should to reduce the pollution from the various sources. Second things which I want to mention is the small-scale industry. In our country, there are 3 lakhs, more than 3 lakhs small-scale industries are located which are highly air polluting. Take an example, brick kiln, lime kiln, stone crushers, riverability furnaces, etc. For every this sector, there's a good technologies is now available. For example, for brick kiln, there is zigzag technology, which can be adopted, the emission can be reduced. These type of things can come. Waste recovery boiler in sponge iron plant. You know the Bellary, sir, you have large number of sponge iron plant, and very few sponge iron plant, they have installed the waste heat recovery boiler. So they are wasting the energy, wasting the very valuable carbon monoxide which is emitting in the environment without any waste heat recovery boiler. These type of things should be considered for pollution control in the industry sector. Now the next one is the use of clean fuel. Now this is very important. We have a large number of clean fuels are available. For example, PNG. In Delhi NCR, we are very successful through our CAQM, that is authority commissioned by the Honorable Supreme Court, that the Commission on Air Quality, they have put a restriction on any coal or petroleum coke or any furnace oil used in the industry, small-scale industry. So PNG, the pipe natural gas supply, is now mandatory in all the industry. If they are not using, the industries are being closed. So this type of approach are very good. I think we should consider in the state, city like Bangalore and suburban Bangalore, the PNG is a very right fuel. Similarly, the CNG, the biofuel, and in future the hydrogen, these are the important fuel which should come. In this connection, I would like to draw attention of the government that there is a provision in the Air Pollution Control Act to declare as approved fuel. So there is a list of approved fuel to be declared by the state government, not by the State Pollution Control Board, as a list of the approved fuel which can be used. Many states have done now. So I urge the Honorable Minister to kindly consider the declaration of the approved fuel in the state of Karnataka, where he can put the clean fuel only can be used for transportation as well as the industrial use. Next one is the vehicular pollution control, which is very important. Unfortunately, the Pollution Control Board are neglecting this area. If you don't control the vehicular emission, you're not going to achieve your ambient air quality standard. And most of the state, because I am working with many state pollution control board, I found that it is totally neglected area. It is given to this responsibility is handed over to the transport department, who are the polluting agency. So there are a lot of things can be done. One is that the promotion of the electric vehicles. I am very happy that government of Karnataka has made a policy on the EV, and they are moving towards. Government of Delhi has also done a good work. They are targeting that the 30% of the fleets by 2030 will be electric vehicles. So that is very, very important thing. But one thing we should take a precaution that all the batteries of the electric vehicles should be charged with the non-conventional energy. If you charge with the coal-based power plant, the energy, then carbon emission will going to increase, and that will not sufficient. So we should have the EV battery charger should be of non-conventional energy. And there is a very good opportunity now. There is a national grid. And anywhere the industry can set up their solar plant or the wind energy plant, and then give this energy to the grid, national grid. And there is a grid controller is there appointed by the government, so they can allocate how much energy you are putting in the grid, and here you can get that much of power or electricity from that grid. So grid controller role will be very important. Then we have so far developed the BS6 standard. That is long ago. During my time, it was fixed. But now the time has come that we should move forward. What about BS7 or BS8 standard for fuel quality has to come? Because still our petrol and diesel have lot of sulfur, lot of benzene, which are present. For example, benzene is still in 1%. And benzene is highly carcinogenic. And you can see that in our petrol pump, there is no vapor recovery system. So what has happened, when you take the petrol in your petrol station, this vapor is coming which consists of benzene. So people are inhaling. Second one, in our vehicles, there is no vapor recovery systems. So during the summer months, there is a volatile gases are coming out in our petrol tank, and that is partially the VOC, and which consists mostly the benzene. So we have two things we have to do. We have to reduce benzene further from 1% to below. And also we have put the compulsory, all the petrol stations in our country, they should have the vapor recovery system. That is must. Otherwise the benzene, is a highly carcinogen. And you can see the air quality data with respect to benzene in ambient air, which is neglected. Most of the state boards, they don't monitor that one. And whatever the limited data we have found that everywhere it is exceeded. It is more than 5 microgram per meter cube. That means we are inhaling, we are mostly concentrating on particulate matter. But all the toxic pollutants like benzene or VOC, etc., are neglected in our country. So my submission is that the technology is there. We should bring the focus on the benzene and other pollutants also. Next one is the inspection and maintenance program of the vehicles. Vehicles which are on road, there is no care. We have a PUC type of system which is totally inadequate. We should have an integrated inspection and maintenance program. This PUC type of system is not giving anything because the measurement is wrong. People are not trained for the measurement. They are taking a carbon monoxide and hydrocarbon values. Instruments are not calibrated. So there are huge problem in inspection and maintenance program, which presently we are running, and that is leading nowhere. So we should have an integrated inspection and maintenance program for which the recommendations are already given. I want to highlight the micrometeorology plays a very important role in air pollution control. Honorable Minister in his speech has mentioned that Delhi during winter become gas chamber. Why? So there is a reason for that. The ventilation coefficient in the Ganga basin during the winter months become very low. What is ventilation coefficient? Is the mixing height multiplied by the wind speed. Wind speed become calm in winter in northern states, as well as the mixing height become very low. And therefore the ventilation coefficient becomes very low. Pollutants which are generated are not dispersed at all and all accumulated in one layer, that is the boundary layer. So that is very important. We should understand this thing. And very simple measurement. None of the state pollution control board are doing the measurement of the mixing height. Only CPCB, barring CPCB is doing some measurement, otherwise none of the state boards are doing. It is very simple. We should have a SODAR system which is developed by the NPL, National Physical Laboratory, costing not more than 1 lakh, but the mixing height measurement should be part of the air quality monitoring thing. Next point I want to highlight is the municipal solid waste dump sites. Again, every city this is a problem, including Karnataka, many places I have seen that municipal dump site, because the methane gas is formed, all the plastic, etc. burnt, and then lot of problems are there. But if you make little discipline in the MSW measurement, which many states are now doing, then the problem can be solved. One is that you segregate the waste, wet waste and dry waste. Wet waste is the biodegradable waste. You can make the compost or do the bio-CNG. There are more than 100 bio-CNG plants are there in our country. And the rest of the waste, which are the dry waste, remove the moisture, remove the inert, then this can be used as a partial fuel in the cement plant or can go to the waste-to-energy plant. But waste-to-energy plant will not be very successful. We have to understand the calorific value of this waste, the dry waste, after the removal of the inert and the moisture is as low as 1200 to 1300 kilocalorie per kg. None of the power plant can run with this so low calorific value. So we have to give a lot of oil support. So waste to energy plant where the government is spending 1,50,000 crores, I think we should review it, whether this is a correct approach or not. Then we have to, finally, I will tell that government is now responsible for the decarbonization of the industry. And the Pollution Control Board, they have to play a very important role on that. Development of the green hydrogen, use of the green hydrogen in industry, then phase out and to shift the use of the waste in the cement plant, increasing their TSR rate, then use of electric vehicles, CCUS, carbon capture and utilization, I think is a very important area we have to develop, because if you want to meet the net zero emission by 2070, only decarbonization will not be able to complete that one. We have to go in the CCUS system where the technology is not viable, technology is not available with us also. So we have to throw many research and development work is required in CCUS in large scale. So that is very important one we should do. Next one is the bioethanol. So 20 to 30% of the bioethanol produced from our agriculture waste, our biomass, etc., should be produced. Like in Panipat refinery, we have already started this work. So refinery should set up this bioethanol plant, and then this bioethanol can be mixed with the petrol so that the greenhouse gas emission can be reduced. And there are so many other things which I mentioned. The decarbonization, I think, is a thrust area. None of the state pollution control board, unfortunately, are working on this area, but we have to do, and the pollution control board has to play a very important role. So these are some of my thoughts on the technology side for the pollution control, which I feel very strongly that technology will lead us for the improvement in the air quality. And whatever the monitoring, measurement, etc. we are doing, we should do a proper calibration. The quality of data is very important. If you see the website of the State Pollution Control Board and Central Pollution Control Board, and if you see the CEMS data, 90% of the industries are complying with the standard. Doesn't mean that that much of pollution we have controlled. No. Because still there is a pollution in the air, the health of the people are affected. That means there is the data reporting, data generation, data reporting has some gap is there. And that should be plugged. And who will do it? It is mainly the responsibility of the Pollution Control Board, but also from the organization like CSTEP, etc. They can put a lot of pressure on the Pollution Control Board to generate correct data. Otherwise, what will happen? The posterity will blame us. They will say that whatever data you have given to us are not reliable at all. Because in this time, if the 90% of the industries are complying with the standard, which is actually not correct, then you can't say this thing. So that is my only submission to all of you, that technology and science-based approach should be followed, especially in the preparation of action plan. the science play a very important role. Inventory, monitoring, modeling, source apportionment study are all important based upon the science, and the action plan should be prepared purely on the scientific basis. So science will play a very important role. Science and technology together will achieve us to meet our ambient air quality goals. Thank you very much, sir.
Thank you so much, sir, for giving us the detailed insights on pollution control technologies and also highlighting the challenges around data, which I'm sure most of us resonate with. Thank you. I would like to thank our dignitaries for taking out their precious time and sharing their invaluable thoughts with us. And yeah, thank you, sir. Yeah. Please give them a huge round of applause. Moving forward, we'll start with the next session. The topic of the next session is inter- and intra-generational justice in the Anthropocene. As it's a well-known fact that air pollution is a worldwide concern, but its impact is not evenly distributed among populations. So, in this session, the discussions will be around the issue of socio-economic disparity in exposure to air pollution, and the session will take us through how the policies and institutions can be cognizant of these issues when promoting sustainable development. For this session, I would like to invite on stage Session Chair, Ms. Swagata De, Technical Advisor, EDF, and our panelists, Ms. Bhavreen Kandari, founder of Warrior Moms, Professor Debolina Kundu, Professor at National Institute of Urban Affairs, Ms. Shibani Ghosh, who will be joining us virtually, Advocate on Record, Supreme Court of India, and Mr. Tejas Singh Kapoor, Program Officer, WWF. The session chair, Ms. Swagata De, is a New Delhi-based researcher with a decade of experience in the domains of atmospheric chemistry, air pollution, and climate change. Currently, she works on emission inventory, monitoring using sensors, and air quality modeling. She leads the hyperlocal hotspot identification work for EDF in India. Previously, she was the Deputy Program Manager at Center for Science and Environment and was involved in developing Clean Air Action Plan and Graded Response Action Plans for cities under NCAP. Swagata, over to you.
Good morning, Honorable Minister, Sir, Dr. Sengupta, and all the delegates and panelists. Thank you all for joining us. So, the fundamental principle of environmental justice, as we know it today, is to be able to reverse the damages that may have been caused intentionally or unintentionally to certain communities or individuals and prevent the same going forward. I will paraphrase a famous environmentalist and a woman of color, Heather McTeer Toney, who says that in these times of environmental uncertainty, it's cliche to say that in a climate crisis, we are all in the same boat. The reality is, while the storm is same for all of us, some of us have a yacht, while rest of us have to make do with a makeshift raft. So today we will examine these very questions through an air pollution lens, for which I have a very, very august panel right here. We have with us Professor Debolina Kundu, ma'am, professor at the National Institute of Urban Affairs. At NIUA, she is currently the country investigator for India for the GCRF Center for Sustainable and Healthy Living Communities and Neighborhoods, supported by the UK Research and Innovation Foundation, and she's leading several projects supported by UNICEF. She's a member of various committees formed by the central and state governments, including the 5th Delhi Finance Commission. She is the co-chair of the Task Force on Life, Resilience and Values for Well-being under the G20 think tank. Virtually, we are joined by Ms. Shivani Ghosh, who is now an advocate on record for the Supreme Court of India. Shivani specializes in environmental access and information laws and practices before the Supreme Court and the National Green Tribunal. Formerly, she was associated with the Center for Policy and Research as a fellow, where she researched on issues relating to domestic environmental laws and regulation. Ms. Ghosh has also been a Sustainability Science Fellow at the Harvard Kennedy School and a visiting faculty at Terry University, New Delhi. I'm also delighted to welcome Ms. Bhavreen Kandhari. She is a citizen and a concerned parent working towards clean air for more than 2 decades. And she's spearheading several public movements in Delhi and India to bring the desperate attention that is needed for call on environmental justice issues. She has facilitated the rise and management of social movement campaigns over the years, the most recent one being Warrior Moms, where mothers all over the country have joined together to bring clean air for our citizens. She has recently accomplished the Climate Parent Fellowship, and she's building the Parents for Global Future to support a parent-led, intergenerational and family-centered climate engagement work. And finally, amongst these very august ladies, we have Mr. Tejas Kapoor, an environmental lawyer working as the program officer for Center for Environment Law and project coordinator with WWF India. Tejas holds an LLM in Environment Law, Energy and Climate Change offered by WWF in India in collaboration with Jindal Global Law School. Welcome to all of you. So I'd like to start with Professor Kundu, and I'm going to pose the first question to you, and we'll get opening remarks and go forward. As somebody who's very deeply involved in urban affairs, do you first see that are the disproportionate impacts of climate change and air pollution even acknowledged? And if yes, what initiatives have been taken in terms of policy and planning at the urban level? Ma'am.
Thank you for your question. I would like to take this opportunity to thank the organizers for this invitation to this very important subject of air pollution, and I think urban has a very strong bearing. Before I answer your question, I would also like to highlight a few details with regard to the urban landscape. Most of you are aware that we are urbanizing. I won't say at a very fast rate, that is a misnomer. We are urbanizing, that is a fact, and by 2047 we will be 50% urban. And one major aspect of urbanization is not many people from rural areas are coming to urban areas. It's basically existing rural areas turning into urban landscapes. And these rural areas which are becoming urban are termed as census towns. So these census towns, although urban by characteristics, are not essentially acknowledged by the state governments. So although they are part of the urban, but they are not acknowledged as urban. So this is one area where I would like to draw the attention of the August gathering. Number two, we are around 10,000 urban centers. We do not have the 2021 census data with us just now, but in the 2011 census, we were 7,933, and even by conservative estimates, I suppose we have data from the Ministry of Housing and Urban Affairs where it's around 4,900 statutory towns, and the remaining census towns would be around 5,000. So these urban centers should be the focus of our interventions. But sadly, there are around 122 cities, or at the max 200 cities, which are the focus of climate interventions. Whether it is the NCAP or the 15th Finance Commission interventions, although it's a good start, but I think we need to increase the canvas of our operations. Another thing which I would like to throw light on is that these census towns, as well as the 5,000 statutory towns, all of them do not have master plans. So, as per a Niti Aayog report, 65% of our towns and cities do not have master plans. So, in the absence of master plans, the interventions are piecemeal. There are haphazard constructions taking place. Urban sprawls are seen everywhere, and environmental pollution is also one of the outcome. Another feature of urbanization is that the big cities are not growing within the municipal boundaries. So when any municipal corporation tries to look at the urban space, it's basically within the municipal boundaries. But what we find is there is a lot of population and urban sprawl development outside the municipal boundaries. So this is also one area of concern, because the peri-urban areas where many of the polluting industries are also coming up, there's a lot of housing development there. So who will take the onus? I think this is one of the major policy concerns coming up. Now, going directly to your question, like who bears the impact? I think air pollution does impact the rich and the poor, all of us, but the poor, because they are basically working in the construction industry, in factories which emit a lot of polluted air, like brick kilns, and those who are also working on the streets in unhygienic environment, they are also adversely affected. And most of them are immunologically and also nutritionally compromised. So I think this section of the population does need a lot of attention in this regard. Do I have some more time?
Please take a minute.
Yeah. So in conclusion, I would like to say that, and also one point I would like to make here is that there are various interventions, even with our ministry, Ministry of Housing and Urban Affairs, where we are looking at the climate assessment framework. Air pollution is one of the indicators which are being monitored across 122 cities, 100 smart cities, and the remaining are the million+ cities. The indicators are clean technology in transport, shared vehicles, whether the city has the facilities for shared vehicles, whether public transport is available, whether there is non-motorized transport available, what is the level of air pollution, and whether the city has a clean action plan. But I would urge that there should be more of outcome-based indicators. Same is with the Sustainable Development Goals. I think Sustainable Development Goals, they cut across. All of the 17 goals does have a bearing on air pollution. But what we need is more of outcome-based interventions. We, as Dr. Sengupta rightly mentioned, we need to strengthen our data systems. Until and unless we do that, I think most of the analysis and interventions will be misdirected. And because the space of intervention will be more and more urban, we need to strengthen the urban governance, look at rural and urban, try to diffuse the rural and urban binary, and try to have some integrated policy planning. And with regard to public transport, last mile connectivity is very important. And lastly, we need to imbibe life the mission life in most of our interventions. Thank you so much.
Thank you, ma'am. Is Shibani online?
Am I audible?
Yes, you are, and now you're visible as well. Hi, good morning.
Good.
So Shibani, I'll move over to you. So you've been working in this space for so many years, and you've been studying how policies have been designed from an air pollution lens and others. So could you maybe highlight how inclusive actually is the approach while designing these urban policies, and do they actually subscribe to the principle of equity in any way? And if there are any positive case studies. Over to you.
Right. Thank you, Swagata, and thank you so much to the organizers for adjusting my request to appear virtually. I know it doesn't make for a great discussion, but I'll try my best. Swagata, to your question about whether, and I'm not just going to talk about urban policies, but environmental policies more generally with a focus on air quality, whether those are inclusive and equitable. I think the short answer is not quite. And there is immense scope for improvement, increasing kind of components that are more equitable, more inclusive, more participatory. And if I could just step back and wonder why this happens, in particular in the environmental sector. And I think the answer perhaps lies in part that contestations and conflicts over natural resources are increasing rapidly over time. There's scarcity of access to natural resources. There are competing interests in natural resources. And by natural resources, of course, I mean, say, clean air, water, forests, access to forest produce, access to clean water, and of course, there's an increase in consumption. So if conflicts of this kind are going to continue to increase, how do we make sure that our policy making, our governance, and our decision making around these kind of conflicted areas or points of contestations are either reduced or are improved? So if we have to improve our quality of governance and our quality of decision making and policy making, of course there are many ways to do that, but what I would suggest, one of the key ways of doing that is to make our processes and the institutions involved in these decision making processes more robust, more competent, and adequately capable to make those kind of decisions. And how do we do that? One way, as Swagata, you indicated in your preliminary observations, is to make these processes more inclusive, more participatory. But also, two other ways that I would suggest, and of course there are many more, but two others that I would focus on is something that Dr. Kundu mentioned as well, Dr. Sen Gupta in his opening remarks, is about the quality of information. What is the and to reduce information asymmetry across stakeholders, and also to make our decision making based on expertise, technical know-how, for persons who are involved in these processes to have access to kind of cutting edge expertise, technology, research. So all of that together needs to happen for our processes to become more robust, more participatory and inclusive. And I'll take a few examples to explain why I say this. Some of the work that was done at Center for Policy Research, and we at that point looked at across 10 pollution control boards situated in the Indo-Gangetic Plain, looking at how the state pollution control boards were involved in, which are of course our frontline regulators when we look at air quality, look at the kind of expertise they have. Some of our research showed that according to law, the boards are supposed to have at least 2 members with specialized expertise or knowledge in air quality. And across these 10 boards, all of which situated in states in the Indo-Gangetic Plain, they were really hard-pressed to show which of their members of the board have expertise in air quality. And they are supposed to be making decisions and policies on air quality. The second thing, look at the number of vacancies in these boards and in the officials, in the offices that support these boards. It's an average of over 40%. And just the membership of the boards, our research showed that over 50% of members of these boards are persons who are actually associated with people who are potentially the polluters. So we're looking at industry associations, Department of Industries. So all of these persons who are part of the decision-making process, we need to kind of question ourselves. It's nice to have stakeholder representation, but it seems a rather askew representation if, on the other hand, they want medical practitioners, they want people with understanding of public health, academics. Where are they? Why are they not finding a seat at these tables which are involved in policy making, right? So that's one example of where I think that, we could become more inclusive in our policymaking. And I'm only looking at air quality as an example. Of course, this is perhaps applicable across environment.
You might want to switch off your camera if you're frozen.
Kind of approach of airshed level management of air quality. So much of our air quality planning till date is focused on city level. Our action plans are city action plans. Most of our monitors are based in specific cities. We are constantly talking about Delhi, Bombay, Bangalore. It's always city level, but so many studies have come out. Research shows that whether we are looking at exposure, whether we're looking at significant polluters, they are spread across urban, rural, peri-urban areas. There is no divide that our urban areas are significantly more polluted or are significantly facing more exposure to poor air quality than persons living in rural areas. So why are we, in that sense, not including rural areas and persons living in those rural areas and people who are in charge or in some ways responsible for administering those rural areas? Why are they not on the seat of decision making with regard to air quality? Moving on to kind of participation and making where are these avenues to participate? If you just look at taking the example of air quality, if you look at the Air Act of 1981 and the Water Act of 1974, one of the main ways of regulating point sources of pollution in these two laws is to issue consents, and pollution control boards are routinely issuing consents. It's very much part of their work, very much part of the source of revenue for them. But there is no public participation when it comes to whether a particular industry or a point source should be granted a consent at a particular area or not. We have heard of public hearings, public consultation being taken care of, being undertaken when an environmental clearance application goes through. But not when someone wants a consent under the Air Act or the Water Act. There is no public consultation. So there is very little participation, even by design, in the law. So that has to change as well. So, looking at institutions, looking at law, and looking at the way, of course, policy making. For instance, many of us, when the NCAP was issued, before that there was a draft NCAP, and many of us, those of you in the room as well, must have sent your comments to the ministry at that point, picking on points in the NCAP and suggesting how it could be improved. We don't really know what happened to all of that, right? And that's true for most of them. And at least in NCAP, we had a draft that we looked at and responded to. Many times, policies that affect our environmental governance, we have absolutely no idea how they were designed and how they are being implemented. Very little public participation. Now, I know I'm running out of time, Swagata, so I just want to end with something about the role of courts, and maybe Tejas will come to that in his opening remarks. Very often, we think environmental governance needs to be run by the courts, or rather we expect our courts to run environment governance, and I think that's a really bad idea. And that has, in fact, in part been responsible for very poor quality regulation by the frontline regulators in the country, because they are constantly looking at the courts to tell them what to do. Courts have to be our final port of call. Courts have to ensure there's no backsliding. Courts have to ensure that there is perfect compliance. Courts cannot be setting standards. Courts cannot be telling us that Delhi's pollution can be resolved by setting up a smoke tower in Connaught Place, right? Courts cannot be setting up timelines, which honestly, given the state we are in, we cannot meet. So that's the problem that we reach when we're talking about justice and looking at kind of courts as part of the regulatory ecosystem, which I think they need to be. They'll ensure more participation. They'll push regulators to make the system more inclusive and participatory. But honestly, that's where their role should end and can end. So I'll stop here, Swagata, and I look forward to the question and answer session.
Thank you, Shibani. And you've half done my job, and I think you've already put Tejas in a spot. So I want to ask you, Tejas, as a young trained lawyer, Why don't you tell us a little bit about the inter and intra-generational equity and how the Indian judiciary and jurisprudence fares in, though, as Shivani said, there shouldn't be setting standards, but there must be some positive stories that have come out. So, over to you.
Yeah, thank you so much. So, good morning, everyone, and thank you, Shivani, for setting the stage. So, there is an interesting report that I wanted to first point out, that is the Climate Change Litigation Report, which is released by the UNEP every single year. So in that, it discusses how climate change has fared globally and as well as in India. And it states that India has 11 climate change litigation cases. And I was a little confused because, I feel that the judiciary does a lot more when it comes to climate litigation in the country. So I looked into what exactly they mean by climate litigation, and I realized that those 11 cases that they referred to are just cases in which they specifically mention the words climate change, or they talk about how climate change should be dealt with. And then I realized that there's a lot more, and the judiciary in our country has stepped in various situations, where we talk about forest fires, they talk about forest fire management, they talk about protecting the forest, they talk about air pollution when it comes to vehicular standards, etc. And as Shabani pointed out, that they have stepped in a plethora of situations. But what I wanted to do in this stage is raise, three concerns that I have about the future and how the courts can, or how the courts may not be able to achieve intergenerational justice or climate justice. And I use these interchangeably in the sense that, to achieve climate justice, we do need to achieve intergenerational justice, and the other way around as well. So the first concern that I have are, there have been a lot of recent amendments to various legislations in our country. So environmental legislations, we have the amendment to the Air Act, to the Environment Protection Act, to the Biological Diversity Act, Forest Conservation Act, as well as the Wildlife Protection Act. Now, the first three that I mentioned have a potential impact on how the judiciaries may function in the future. So the amendments to the Forest Conservation Act, the Air Act, Environment Protection Act, and Biological Diversity. So these provisions, the provisions under these acts have been decriminalized in the sense that, any violations under these acts would not entail any sort of imprisonment. And there is going to be a penalty instead, and these penalties have, of course, been enhanced under these amendments. But the person responsible for ensuring, for deciding how much the penalty is going to be, right, has been changed to an adjudicating officer who is going to be appointed by the central government. So this adjudicating officer may or may not actually have any expertise when it comes to the judicial's point of view, or from the point of view, or any sort of technical expertise. But they would be responsible for deciding what are the violations and how much penalty should be given for such violations under these three acts. So this is actually a very unique change that I would say, because I have not seen any sort of act which provides for a non-judicial officer, or rather an executive person, an official from the executive who would be responsible for adjudicating offenses under an act. And that is A. And the second issue is on separation of powers. So for this, I would have to go into a little basics of the Indian Constitution, where we have the three different pillars: the executive, legislature, and the judiciary. And they have clear demarcation of separation of powers. But there is a concept of checks and balances, where each pillar keeps the checks and balance on the other. So similarly, for judiciary, they have the power of judicial review over certain actions of the legislature and the executive. But there is one limiting factor when it comes to the judicial review, when it comes to for the executive, is that they cannot look into the policy action of the executive, right? So here where the issue is that majority of climate action, and which includes renewable energy in India, is through policy. And therefore, these are situations where the judicial review cannot be undertaken. And in fact, I'm going to read out an excerpt from a judgment of the NGT in Ridhima Pandey versus Union of India. So here, this 11 to 12-year-old girl at that point, she used the principle of intergenerational equity, sustainable development, to state that the government's policies are not enough to achieve the targets that have been set under the Paris Agreement to reach the 1.5 degrees Celsius. to limit to 1.5 degrees Celsius. And what the court simply said while dismissing the matter was, there is no reason to presume that the Paris Agreement and other international protocols are not reflected in the policies of the government of India. So it is as simple as that. The judicial review does not extend to the policy decisions of the executive. And the third that I wanted to raise, and I'm hoping that, I can have a discussion with somebody here regarding, is the issue of attribution. What I mean by that is, for example, if there is a community that has been harmed by some sort of disaster, climate change-induced disaster, such as a flood, right? And they have incurred some sort of loss of life or property. Now they approach the court stating that, I have incurred a loss of property, or somebody in my family has lost their life. I require some sort of compensation, some sort of justice. And so what can the court do in such a situation? Do they approach the specific industries that have contributed to the issue of climate change? But how do you attribute it to individual industries, right? And the second, or do they attribute it to the governments who have failed to ensure that, who have failed to mitigate climate change, or have failed to ensure adaptation to the issues there? And so this is an issue of attribution, which is going to create some sort of barrier when it comes to achieving said intergenerational justice or climate justice. And these are three concerns that I wanted to raise.
Beautifully articulated, Tejas. Thank you. I do have some questions, but we'll come back. But moving over to Bhavreen. So as a mother and as somebody who's been working with so many mothers, and we just heard about intergenerational equity and justice, can you tell us what are the lasting consequences that you've seen on bad air on our children? And what should we do? We want to start with something positive now. I know it's already late, but better late than never, so that we ensure a better future, collectively as a community today and as individuals.
Thank you, Swagata, and thank you, CSTEP and all the organizers for bringing ordinary voices as citizens, as ourselves and mothers to the forum. So, everybody said everything, actually. I mean, there's nothing more to be said except for that, if I see the years that I was growing up in maybe 80s in Delhi, we were told that get up in the morning, go play, it's important to play sports. And to the, last decade, when my girls were growing up and they were in the school, and I had to stop them from playing in the mornings because the air is so bad, and I am studying and I'm learning more about it. I'm trying to convince the school that they should, change the timings, but it doesn't work out. So I have to tell them to withdraw from the junior nationals. Children who have played all their life, practiced, but now I'm not allowing them to play because it just affects their lungs. We've been told in 2019 by Lung Care Foundation that every third child has damaged lungs already. So this is the intergenerational, justice that we all seek. What decisions, what policy, what was really happening in those decades is what, we are actually now. It's what you've sowed, you're reaping now, and just taking this forward. Exactly now, what's happening? How many waste-to-energy plants will we be facing in our residential colonies? Or like Dr. Kundu just mentioned about the master plans. There is, we're not experts, but yeah, we see those things happening. In the colony where I live, they covered a stormwater drain, which is about 13, 14 years ago, and now it's just covered. We have a whole lot of methane and the emissions that we are facing it, and this is not even an equity issue because it's one of the poshest colonies in Delhi. So what is going to happen, 2 decades from now, all those residents and the children who are growing up there, what more and worse will it get from them? I mean, this is just a small example because you mentioned that and it just came to my mind, and I thought it's better that I speak to, in case studies, because the experts have all spoken what needs to be said. In Warrior Moms, we are, actually, rightfully, my co-warrior mom, who's also a brick kiln worker, and she was supposed to be here, but we just couldn't, work out the logistics, and so I'm speaking for her as well. Her two generations, her grandparents were in some, not really fishing community, but they were working, to sell fish. And there was, because of some coastal erosion problems in West Bengal, they had moved to construction, being construction workers. And she is now, because of all these pollution holidays and, recent events that we were facing, that they had to also move away from being construction worker, and went back now into something new called, where they were brick kiln workers. They're being trained for that. So again, the three generations, how they changed from, that was the original work, was fishing, and because of the coastal erosion, all the climate change effects that they reached there, from there they moved. So the moving means that their children are not studying probably. They are all the time, whatever little bit of assets that they make, they lose them every time they move. The last time, now when they moved from Delhi, I'm not even in touch now. So they've even lost the phone number contact. So this is how, on ground, the realities that the real people have to face. And so I just want to say, Swagata, you asked for solutions. It has to be a holistic approach from all the stakeholders, like everybody has said that. But a sound policy, a policy that really means business, not a policy to be in the paper. It should be implemented. It should be very, very aggressive. Why is it that I'm living in one of the most polluted cities of the world, but I see single-driven cars all the time, or we are still working, we cannot implement the solid waste management bylaws, or, it's okay for citizens to, of course, act, and, like Shibani also mentioned, it's fine that, we're all happy and we want to do that, but the governments, the authorities will have to lead that. They will have to come forward, they will have to, and of course we are very, very happy and excited being part of LIFE. But we also, ask the major stakeholders, that's our government, our authorities, to take on these policies. There's a lot already there, and there's a lot that needs to be done, because that is what is going to really help us see, whether the youth or like my girls, when they are in their 40s and 50s, how are they going to be living? If we cannot have any number of trillion economy without a healthy youth. And that's what I can say. Thanks.
Thank you, Bhavreen, for that very, very poignant remarks. So in the interest of time, I had questions, but I want to open this up to the audience first. So do you have questions for any of our panelists? Yes, Digvijay, I saw you. And I have questions. And please tell us your name and your organization and who is the question addressed to.
Thanks. Okay, I'll stand in the interest of respecting all the panelists. Thank you, everyone. I think the discussion was very fruitful, and I'm very glad that this happened. So coming to the points that was made by Tejas, I think they were pretty relevant. Tejas, thank you for pointing out that particular part in the UNEP report. I'll take it back to my colleagues and make sure that there is much more in the climate change, what do you call, the sort of cases that they have filed as compared to what they have currently, okay? The one point I think for both my lawyer and advocate friends here, you spoke about the part where you said the judicial review is not there. And I think it's a very important point where the dilution of the penal code has happened, where the criminal liability is actually taken out and it's only the civil liability which is given in. So do you think it is the right time now that we have the bills going to the Parliamentary Standing Committee, that maybe there can be a recommendation sent to them from eminent people like yourself to actually include this as part of the current bills, to add some sort of a provision there so that it actually comes back, and also maybe lead to an amendment to the current Air Act to make the criminal, section on the criminal code reintroduced in a more stringent manner. Because what I also draw from is the first time, or one of the rare times, that when the styrene gas leak happened, there was actually a name which was given at the time when the judgment was passed, of the specific VPs and the senior members actually responsible for that industry. where the criminal case was filed against them. So I think this is something which we need to see more. And I'm talking as a citizen of the country and somebody who actually believes in the criminal nature of these particular aspects being highlighted in the environment field. So your comments. Thanks.
Yeah. Tejas, and then I think I'd also like Shivani to respond, both of you. Yeah.
Yeah, so unfortunately, all of these bills that have already gone to standing committees or joint parliamentary committees and have already been passed by both the houses. So I don't think it is possible to now retain the criminal provisions of these different acts. But yes, I do agree with you. There is a potential of, that the decriminalizing of these provisions may be harmful in the sense that it is not going to prevent, violations. But it is also a sort of, we have to wait and see how these provisions, there's a potential that instead of polluter pays principle, we are going to make it a pay and pollute principle where, industries are able to violate and make the payment for the penalties and continue polluting. There is a potential, but I think that is something that we have to just wait and see.
Shivani, would you like to respond to that? And I know Bhavrin also. And I saw another hand, Anuma, just 1 second, yeah? Shivani, please.
Yeah, very quickly. So I think the criminal provisions in the EPA and the Water Act still remain, to the best of my knowledge. I mean, I'll come back to that. But I think there has been a long drawn debate on whether criminalizing environmental offenses is the way to go or not. And perhaps that's what the person who's asking the question was referring to. And I'm someone has held this belief for a while that for egregious repeat offenders in India, we need to have some form of a stick in the form of a criminal penalty for egregious violations and repeat offenders. However, we need to have a graded penalty mechanism, which is like a pyramid. So the people on the top, who, as I said, are the egregious ones, need to, it has to come down hard on them. But all the way up till then, given the lack of resources and the human resources as well as the time in the courts and all, I think we need to develop a civil penalty system. But to have a robust civil penalty system, and Tejas referred to some of this in his presentation, we have to have officials who we can trust, who are accountable for doing their job properly and who are competent to do it. So if you are going to have revenue officials doing assessment of environmental damage so that they can decide the penalty, let's have a way of actually empowering them to do these kind of environmental damage assessment. And that's just one small example I wanted to give. So I'm all for keeping some bit of the criminalization of the offenses bit, but we really need to work on accountability of officials who are responsible in bringing the rest of the offenses to book. I'll stop there.
Thank you. Bhavri, yeah? Okay. So thank you, both of you. I saw another hand, Dr. Anubha.
Morning, everybody, and it's a wonderful discussion and wonderful presentations, and great to see the panelists over there. I just have one small question, and I think it's for Dr. Kundu primarily. You mentioned that there should be sort of an integrated approach to be handling the air pollution or the, let's just say, the pollution issues between the cities or towns and the rural areas. So are you hinting at bringing in the concept of an airshed, as was talked about yesterday, and then having a planned approach to be how to be handling the air quality, let's say, in that area a lot better? But then that will, to me, I think that will bring in the aspect of the legislative or administrative things as well. So what do you think would be a good idea to go forward on that front? Thank you.
Thank you for the question. I think the concept of airshed, as you rightly pointed out, would bring in legislations, but to start with, we could always empower the existing DPCs, the district planning committees or the metropolitan planning committees, because they have a greater area and encompassing both rural and urban. They could initiate the responsibility, and then there could be some progress towards this. And going to the previous question, the chair, I would like to mention that a few cities have already started having climate officers, like Surat, like Ahmedabad. I think this also needs to happen across the board, in small towns and in big cities. Until and unless there is at least one officer in the city who takes charge of climate action, nothing will happen. We don't even know what is the scale of our problems. And I think big cities do have the wherewithal, at least for the sake of understanding, but what happens to the small towns? I think there we need to focus, and also the peri-urban areas where it's no man's land. Like the urban says it's beyond our boundaries, but whatever nuisance we find, it's all across the boundaries. There, I think there should be some agency who takes up the onus of handling the crisis.
Yeah, someone, my earlier mentor, Dr. Anumita, would say that you have to pay toll to go from Delhi to Gurgaon. Bad air doesn't need to, it just travels. So I think that was a very, very beautiful discussion. I just have a concluding question to Dr. Kundu, and maybe Shibani can also jump in. You said that 65% don't have master plans, so that means 35% do. I come from Delhi, and one of the better planned towns, but we saw floods for the first time, at least in my living memory. So are these the ones that existing have so-called beautiful master plans? And last year I remember Bangalore had floods, and I was telling Pratima saying, thank God your event got over, and look, the flood started. It was literally 27th of August, and 25th we wrapped up ICAS last year. Are they climate resilient, even the existing ones?
Thank you for this question. Even the planned cities, it's not 100% planned. For Delhi, it's 25% of the entire city we call it planned. Why? Because it's under the government housing schemes. We have the RWAs who takes care of the local governance. We forget about the ward committees who are constitutionally there to take care of the local governance issues. But as you rightly pointed out, the floods, the city resilience, these are issues which need to be discussed for the city at large, for the master plan, with the master plan, the planners, but these things still need to happen. Even the big cities like Delhi or Mumbai or Bangalore, forget about the small towns. So even the cities which do have master plans, it's basically land use plans. The master plans do not take a holistic view, and it is also not backed by financial plans. So until and unless you have finance backing your plans, nothing actually happens. And we are talking about blue-green infrastructure in Delhi master plans, but how do we go about? We need to have a roadmap for that. I think those are the areas which are areas of concern, and a lot needs to be done in this regard. Thank you.
Thank you. Are we on time? Yeah. Okay, so I think that was a very, very rich discussion. I expected, when I first heard of my panelists, I expected no less. So thank you all. We heard some comments, but primarily that while we are on the path to thinking about our future with people like Bhavrin fighting for our children, there is a lot to be done. Courts shouldn't have to step into, do everyday things. There have to be layers of accountability. There has to be capacity building and training. You cannot have a revenue officer deciding fine or, who does not have idea of the law or the technology. So common themes that we've discussed, and that's a wrap from here. Thank you, all of you, and thank you, Shibani, for joining us online, and thank you, CSTEP, for organizing.
Thank you, Ms. Swagata, and all the panelists for the interactive panel session. Now I would like to call Deepthi to offer token of appreciation to all the panelists and Ms. Swagata. Once again, thank you, everyone. Thank you. With this, we come to an end of this session, and we'll move forward to the next session, which is student poster competition. As yesterday it was announced that in student poster competition, 5 students have been selected to present their research work for 10 minutes. I would announce their names one by one and I request them to take their position on the stage. Their names are Shushovan, Praful, Sarita, Akanksha, and Neha. I would like to tell you all a few rules about the presentation. You will be given 10 minutes time to present your research work. After 8 minutes, we will be giving you the first warning through the bell. And you have to try to sum up your presentation within 2 minutes after that. And during presentation, whichever point you want to talk about or whichever section of the poster you want to talk about, you kindly just tell to the operator and they will highlight it for you. Thank you and all the best. We can start with Shushovan.
Hello everyone, I'm Sushovan Ghosh, PMRF Fellow at Center for Atmospheric Sciences, IIT Delhi. I'm working under the joint supervision of Professor Sagnik Dey and Professor Dilip Ganguly. So the title of my research is Cleaner Air Would Accelerate India's Transition Towards Solar Renewable. To start with, aerosols are the tiny solid or liquid particle suspended in the air. But how do we know that it affects the solar renewable energy generation? So we found 2 pathways. First one is the atmospheric attenuation, where the aerosol particle either scatter or absorb the incoming solar radiation reaching to the solar panel. And the second one is the soiling effect. So in a polluted environment, these aerosol particle sometimes get deposited over the solar panel and reduces the panel material efficiency. So if you look into the global aerosol loading, we found that India is one of the aerosol hotspots. But at the same time, to tackle climate change and air pollution, we have a lot of options. Among them, the solar renewable energy is expanding rapidly across the globe. And in fact, India ranked 4th in overall global capacity building. Kindly to section 3, please. So with this background, we decided our research question could be, what is the influence of aerosol burden on solar resources in India? And aligning with this year Clean Air Summit, we are also interested to find out how do policies for clean air will accelerate the progress towards the clean energy goal. To do that, we use the solar radiation from satellite remote sensing and other meteorological variable from the global MERA2 reanalysis. And using the existing literature, we are calculating the aerosol attenuation effect and the soiling effect. So here we are highlighting 4 key results. Kindly section 5 for my result section. So the first one is the aerosol impact on the solar resources. So when we plot the solar radiation over the Indian region, we found that the 60% of the Indian region is actually suitable for solar photovoltaic generation, meaning they are getting 5 kilowatt hour per meter square per day of radiation. But avoiding the last 18 years of attenuation, we found that the 88% region are suitable for the solar photovoltaic. And avoiding the total aerosol effect, combining the attenuation and the soiling, we found that the 89% region is actually suitable for solar photovoltaic generation. So we further extend our analysis to different solar panel setting. 5.2, please. And what we found that as we move from the fixed tilt to single axis tracker or the dual axis tracker, the losses due to aerosol is increasing. And it is prominent over the most part of the Indo-Gangetic, combining the eastern and the northwestern part of the India. So the question is, how do we get rid of these aerosol-induced losses? One option could be the effective usage of already existing policies, or designing new policy scenarios. So here we are considering the PMUI and NCAP. So please, section 5.3. So when we plot the simple economic assessment, the left-hand side bar plot is showing the losses due to aerosol, and that is 12% to 41% losses, and translating $245 million to $835 million losses of solar energy generation. But the right-hand side is the gain due to implementation of different policies. So combining PMUI and NCAP leads to 16% to 42% excess solar energy generation, translating $325 million to $845 million. And I would like to mention that these costs are equivalent to the cost or the budget allocated to the PMUI or the NCAP. So going to the WHO AQJ, we found that $505 million to $1,425 million possibilities of solar energy generation. So please kindly 5.4. So here we are also would like to mention and one more point that the solar energy generation industry is right now facing, that the scarcity of the land availability. So as we all know, that Government of India has taken an initiative for the 100 gigawatt target. So the left-hand side plot is in fact showing that in India, the solar renewable energy capacity is expanding exponentially. And the right-hand side is showing in that the relationship between the capacity and also the generation. So we found that with this projection, when we found that the 100 gigawatt will India achieve, at that time, India could have a possibility to generate 143 terawatt hour. But I would like to highlight few statistics. So kindly 5.4, the below figure C and D, please highlight that. So when we found that the 76 gigawatt of capacity India will have, at that time 108 terawatt hour of generation India can be able to produce. But if we can avoid the aerosol impact, then that can lead to 136 terawatt hour of production. But if we combine the PMUI and NCAP with the successful implementation, that can lead to 140 terawatt hour, which is 98% of what we can get from 100 gigawatt of capacity building. So kindly section 6. So I would like to summarize my talk. That is, we found that the solar energy goal can be realized in time if the current installation trend can be followed along with the air pollution mitigation plan. And as we all know, that the clean air brings a lot of benefits for the human health, but our studies also found that there is a possibility to get a huge gain in the solar renewable energy industry. So this opens a new co-benefit opportunity. Here I would like to mention some of our assumptions, and that leads to future scope of study. First of all, we would like to mention that we only consider the direct effect of aerosol. So there is a possibility of huge gain, and if we consider the aerosol-induced cloud would effect also. And the economic analysis, what we did is a simple first-hand type. So there is a possibility to consider other allied cost also. And the mapping for the solar soiling effect can be done on a better way, and the future analysis should consider the land availability criteria. So we actually communicated this research through a peer-reviewed publication, section 8, please. And it has been highlighted by many media and newspaper. So these are my references. And finally, I would like to acknowledge IIT Delhi, HPC for computing facility, Ministry of Education for my PMRA fellowship, NASA CERES team for their data and allied clarification, and finally, the India Clean Air Summit for the platform to share my research. I'll be happy to answer any clarification. Thank you.
We will be taking all the questions from the audience at the end of the session. Next, I request Praful to give presentation on his research.
Good afternoon, everyone. My name is Praful Yadav. I am working in Indian Institute of Tropical Meteorology with my PhD topic of chemical data assimilation for improving the air quality forecast. Today I am going to present the development which we have made in the last 3 years in the air quality early warning system and decision support system for effective management of pollution in Delhi. First section, introduction. So I am talking about the National Capital Region in Delhi, which is mostly populated city, capital city in the world, which estimates around more than 1.8 million, and which has developed urbanization, industrialization, which can be the cause of more pollution. And today, the presentation of development and high-resolution air quality forecasting system, which gives more insightful approach for mitigation of air pollution over 400-meter resolution using by 400-meter resolution air quality forecasting system. The air quality early warning system provides its forecast for 72 hours forecast, which includes the state-of-art system, state-of-art chemical data assimilation. We have used numerical weather prediction model, which is helpful for predicting the surface PM 2.5 aerosols and other gas phases. So moving to the architecture, data and methodology. Firstly, we are giving forecast for all over India. The India domain covers most of the cities, and which includes the Delhi as major, which we have downscaled around 400 meter. The Delhi region includes 41 stations of CPCB. We have assimilated surface data of 41 stations, and we have seen that this surface assimilation gives the large improvement in predicting the air quality. So also for improving the air quality forecast, we have used real-time fire count data and the satellite Modi's aerosol optical depth, plus the IITM GFS initial condition and emission inventory at 400 meter resolution. The higher resolution 400 emission inventory gives which provides the more dominant phases of aerosols, which are contributing in the pollution, which have air quality index more than 300. So next section. So then additionally, we have developed the decision support system for air quality management in Delhi, which includes the preprocessors of anthropogenic emissions, chemistry boundary conditions, which we have taken from the CAMChem data. Then we have used biomass burning emissions plus Modi's active fire. Then fire climatology, which we have modified the fire climatology plus with VIRS data of active fire count. Then we have assimilated CPCB stations all over the India. There are more than 300 stations which are taking part in the assimilation. Then we have assimilated the satellite aerosol optical depth for improvement in the PM 2.5 forecast. Then this assimilation and preprocessor going into the WAF-KM model, which helps in predicting the forecast for next 72 hours. Then we are disseminating that air quality forecast on our website. The decision support system helps in predicting the contribution of all other sectors to the Delhi pollution of PM 2.5 loading. Result section. So in October 2019 year, the peak pollution episodes of Diwali and biomass burning emissions, we were able to capture the peaks and heat rates of Delhi pollution. Our forecasting system was able to capture the main event which occurred over Delhi, and we were able to give the forecast on time, and we have seen that the major role was played by the assimilation system, which have given the difference of around 96 microgram per meter cube. So the large improvement is due to our state-of-art chemical data assimilation. Moving to the next section. So we have seen that air quality forecast evaluation, the performance diagram show that the the frequency of hit rate and the probability of detection was maximum, and around 93%, around 93, we were able to reach that our forecasting system were able to capture the critical air quality index, which is more than 400 and above, and where the mean bias and normalized mean bias and normalized mean fraction bias were less, and for first day forecast it was 1.2, and then 5.3 and minus 8.3. This forecast was able to give you the correct estimation for 10 kilometer and 400 meter. So we were lying about in the excellent category of forecasting evaluation. Moving to the DSS, we have developed the decision support system for managing the air quality over Delhi. We have modified the WAF-KEM model according to the emission criteria, and we have added 470 stressors, which includes the emission from different boundaries of Delhi, boundary districts of Delhi. So we have seen that around 30% of PM 2.5 contribution coming from the all other NCR districts, which contributes the maximum PM 2.5 loading over Delhi. Other districts like Meerut, Ghaziabad, Jhajjar, which are the districts of Delhi border, which contributes around 31%, plus Delhi itself contributes around 33%. And then we have checked like other sectors, like in Delhi, transport, industries, and energy waste burning sectors, how much they are contributing for the pollution. Then we have done the source apportionment study for PM 2.5 in Delhi, and we have seen that, and the scenario tracers of reducing in 20% and 40%, what will be the situation in Delhi. So moving to the next section of result. The performance of DSS for first day and second day gives 80% accuracy with 20% false alarm rate, and the detection was done during post-monsoon and winter season, where the peak pollution episodes occurs, and where we say that meteorological condition is a stable boundary condition with low wind speed. We were able to capture those peak events. And last year, Commission for Air Quality Management has taken the decision for graded action response plan and formed the air quality early warning system and DSS. So moving to the conclusion section, the model evaluation shows that our forecasting system reliable predicts the unhealthy and very unhealthy category AQI. Also, DSS effectively particularly in very poor condition, reliably simulate the AQI with minimal false rate of 20%. Then, acknowledgement. Moving to the acknowledgement, we have also published our papers in this current science scientific report, and right now its DSS paper is under review in GMD, and I would like to thank Director IITM CPCB for providing the data, HPC facility, DPCC for their data support, and the ICAS team for providing the stage for presenting my work. Thank you very much.
A very good morning to all. Myself, Sarita Bamotra. I am a PhD scholar working under joint supervision of Dr. Shweta Yadav and Dr. Ankit Tandon. So, as we all know that air pollution has become a significant environmental concern in various regions worldwide, including Jammu. Jammu has been included in the list of non-attainment cities, particularly in terms of fine particulate matter that are characterized by its small size and has the ability to penetrate deep into the lungs, respiratory system, and pose significant health risk to human health. Therefore, the aim of this study was to identify water-soluble trace elements in PM 2.5 fraction and identify its toxic potential, basically to human health, for two age groups, that is adults and children. So can we move to methodology section? Yes. So this was the sampling site where we did a 1 year continuous sampling for collecting PM 2.5 samples, and then we analyzed them for 9 water-soluble trace elements using inductively coupled plasma optical emission spectroscopy. Results. Yes. So these are the main results which we got. First, graph, box and whisker plots for PM 2.5 concentration. As we can see that we were getting higher concentration of PM 2.5 during September, October, November, and winter months of December, January, February. And as we proceed towards the summer season, the concentration goes on decreasing. But the annual average concentration was breaching the national standards set by NACS. Then if we see the annual mean concentration of 9 trace elements, zinc was the highest in concentration, which was found in Jammu city, followed by other metals. And in monthly, if we see the monthly variations in the concentration of 9 water-soluble trace elements, we found that zinc was the was found to be highest in concentration during different months, followed by other elements. And we also calculated the contamination levels of due to these 9 elements. And for calculating the contamination levels, we calculated enrichment ratios of different trace elements, geoaccumulation index, and also pollution load index. And we found that for enrichment ratios, most of the elements showed enrichment ratios higher than the background concentration, which is coming from crustal. So they were highly enriched, and we can say that the crustal emissions are not emitting these 9 elements, but the anthropogenic sources are the major reason. Like they are coming from anthropogenic sources, as they are found to be higher in concentration as compared to the background levels. Geoaccumulation index showed more than 50 values, which for different elements, it was more than 50 geoaccumulation index, which indicates that the site is heavily contaminated with these trace elements. Seasonal variation, when we saw the seasonal variation in different elements, we saw that during autumn season, most of the elements were showing higher concentration, followed by other seasons. But for few elements like iron, barium, and cobalt, they were showing a higher concentration during summer and spring seasons. We can say that the summer and spring season in Jammu city, we there is a notable influx of tourists who are visiting holy shrines of Amarnath and Vaishno Devi, due to which there is influx of vehicles. So these 3 elements are used as tracers for vehicular emissions. So during spring and summer season, zinc was mainly found higher in concentration, followed by iron and barium. Can we go to the discussion section? Yes. Discussion section, we found that higher elevated levels of PM 2.5 and associated elements in Jammu, the higher mass fraction was observed, and lower mass concentration during the spring and summer season suggests that the source activity was maximum during spring and summer season, which leads to the means that during spring and summer season, the source activity increased, but their concentration was lower, which means that the dispersal was there due to higher wind speed and more planetary boundary layer. When we calculated the health risk in terms of total carcinogenic risk and non-carcinogenic risk, we found that there was no effect due to non-carcinogenic effect on for both the age groups, that is children and adults. But in terms of total carcinogenic risk, the values were surpassing the standards set by US EPA, and we found that adults are more susceptible to the cancer risk due to major carcinogenic elements that are lead, nickel, cobalt, and cadmium, which are potential carcinogens. And we found that ingestion or oral route was the major exposure pathway, which was leading to health problems. And because adults were more prone to the health risk, the carcinogenic risk, because they are more exposed to the outer environment like PM2.5 concentration as compared to children. So they were more susceptible to the cancer-causing agents. We also calculated the incremental lifetime cancer risk, and we found that the incremental lifetime cancer risk reported that 23 additional cases of cancer through ingestion, 88 cases through inhalation, and 36 cases through dermal contact are possible because of exposure to 4 elements, that is nickel, lead, cobalt, and cadmium. So these potential cases are associated with lifetime exposure to pollutants at the current concentration. We also did principal component analysis to identify the major sources of these elements, and we found that industrial emissions, combustion of fossil fuels, and non-exhaust emissions like tire wear, brake wear, and resuspension of road dust are the major contributing agents of these elements in PM2.5 fraction. So if we go to the conclusion section, we can say that the hazard quotient values for the 3 exposure routes, namely ingestion, inhalation, and dermal contact, were generally found to be below 1, suggesting that low likelihood of non-carcinogenic risk, but in case of carcinogenic risk, it was breaching the standard set by US EPA. So overall, the understanding the environmental composition of PM2.5 aerosols is essential for developing new effective strategies to reduce air pollution and protect public health in Jammu city. It requires multidisciplinary approach that combines expertise from atmospheric science, environmental chemistry, public health, and other fields. So thank you. That's all.
Good morning, everyone. My name is Akanksha. I am currently pursuing my PhD in IIT Kanpur under Dr. S.N. Tripathi. So my topic for the poster presentation is the comparative analysis of composite PM2.5 real-time source apportionment in Kanpur and Delhi. As we all know, PM2.5, which is the particulate matter having size less than 2.5 micrometer, is hazardous to human beings. Especially they can move to our lungs, and even our blood streams can cause the cancer and other respiratory problems such as asthma. And we already know that Indo-Gangetic plains are highly significantly affected by PM2.5. And so my sampling sites are 2. Number first is Delhi, which is lie in the northern part of IGP region, whereas Kanpur, it is lie in the central part of IGP region. For this, what I have done, can you please move to the methodology side? I have did the air sampling by using the real-time instruments. Number first is the HRT of AMS. It is the high resolution time of flight aerosol mass spectrometer. It is basically used to measure the non-refractive part of PM2.5. Non-refractive means whatever which evaporates below the 600 degrees Celsius. So it basically measures organics and some of the secondary inorganics like nitrate, sulfate, chloride, and ammonium. And for the refractive part, it may contain some of the black carbon or metal oxides. but I have measured the black carbon using micro-8 for Kanpur region, and for the Delhi, I have used the ethylmeter. One more thing I want to explain, I have been calculating the CPM 2.5. It is basically a composition-based PM 2.5, as I am only including the non-refractive PM 2.5 and black carbon in it, though PM 2.5 also contains some of the metal oxides and crustal materials. Next, what I have done, I have go to the high resolution analysis. After high resolution analysis, can we move to the result part? What I have observed that the organics and inorganics both are high in the Kanpur region, whereas the black carbon is high in the Delhi region. The main reason behind this, as the Kanpur site is mainly surrounded by the power plants and some of the villages which are using the coals as for their cooking purposes and heating purposes in winter season. Whereas for the black carbon is very high in the Delhi region, as it's been contributing around 20% for the whole CPM 2.5. This is because of the presence of the surrounding national highways which are using heavy duty vehicles and have very high traffic density. For the inorganic parts, due to the power plant which using the coal and which causes the emission of SO2 and the NOx, which releases the nitrate and sulfate in the air, can cause the increase of inorganics in the atmosphere. Can we go to the methodology part again? After that, I have done the source apportionment using the PMF. PMF is basically a positive matrix factorization. I have used the multilinear 2 engine. What's the difference between two is the PMF doesn't require any type of the prior information, but ME2 engine uses the prior information, due to which we are getting the unique solution. Though PMF is mathematically accurate, but PMF can get the mixed solution. But with the help of the ME2 engine, we are getting the unique solution. After using the PMF, I have get the 5-factor solution. Can we go to the result part? So these 5-factor solution for both Delhi and Kanpur. Number first, I want to explain about the HOA. HOA is basically the hydrocarbon organic aerosol. It is basically coming from the traffic part. As we can see, like these are in HOA factor profile, I am getting some of the compounds which are basically coming from traffics. We can also see from the diurnal, as there is a peak in the morning and the evening, which also shows the peak time for the traffic. And there is having the very less concentration in the afternoon, as most of the primary organics can be changed to the secondary part. Next one is the biomass burning organic aerosol 1. It is a freshly biomass burning factor. Next one is the BBOA2. It is basically oxidized in the air. And why I have taken it as the BBOA2, because I am getting the more O by C ratio, and in the factor profile I am also getting some signal of CO2 positive, which indicates the oxidation. Next, I am getting 2-factor of oxygenated organic aerosol. These both are the SOA, where SVO is the semi-volatile organic aerosol. We can see from the diurnality, there is an increase in the SVO in the early morning because of the photochemical oxidation. But after that, that is LVOA, that is low volatile oxygenated organic aerosol. It is highly oxidized in nature. And we can see there is increase after SVO in the mid-afternoon around 3 p.m., which means the SVO is changing to the LVOA, means partially oxidized is changing to the highly oxidized. One more thing I want to tell, that Delhi and Kanpur both are having the higher contribution from the SOA as compared to the primary contribution, which means primary is changing to the secondary part. I want to go to the conclusion part. One thing I want to share, like the HOA is contributing more in Delhi as compared to the Kanpur, which is only 10% in Kanpur, and in Delhi it is around 21%. So there is very important for us to take a biggest step, that is the 21% is basically coming from the traffic area. So what we can do, like we can use the clean energy, like electrical vehicles in the Delhi, so that it will decrease the HOA as well as black carbon. Whereas for the Kanpur, the biomass burning is basically coming from the low-income houses which are using wood or coal for cooking purposes. So we can provide the subsidies to the LPG cylinders to the low-income houses so that they will be able to use the LPG fuel so that the high level of organic caused by them can be reduced. And with the help of taking the proper mitigation strategies according to the sources we find, like what we need to focus on, we will be able to achieve our goals such as SDG 13, that is climate action, SDG 11, sustainable cities and communities, and SDG 3, good health and well-being, and some more also. Thank you.
Hello everyone, I'm Neha Singh. I'm joint PhD student, joint Indo-Australian PhD student between IIT Delhi and University of Queensland, Australia. I'm working with Professor Sagnik Dey from IIT Delhi and Professor Luke Nibbs from University of Sydney. So let's start with some basics. Nitrogen dioxide is a combustion-derived pollutant and found to be associated with a lot of health risks, health outcomes. So, like in India, there are less epidemiological studies, like pan-India scale epidemiological studies for NO2, and the reason behind it is lack of exposure data. So, like we only have 0.08 monitors per million population, and that is very less for any kind of epidemiological
Recording in
studies.
progress.
For if we see like satellite NO2 data, so they are like columnar densities and they cannot be directly used for surface concentrations. And second reason is they are at very lower spatial resolution, that is of 10 kilometer. So we came up with the idea to make a like high spatial scale NO2 exposure data for India so that we can use that in epidemiological studies, because that is essential. So far, NO2 exposure risk function is not included in global burden of disease because of lack of epidemiological studies, which are like NO2 is found to be associated with a lot of health risks like diabetes, cardiovascular diseases, respiratory diseases, and more recently reduced cognitive development in children and reduced birth weight, new onset of asthma, etc. So like for any pollutant, there is an environmental health risk pathway that is like source emissions, then concentration measurement, and then exposure calculation and health risk assessment. So all these four are very important for any kind of policy implementation, mitigation measures, etc. So section 2.A, please. So we came up with the idea to make the exposure data at very high resolution. For that, what we did, we used very widely used statistical model, that is satellite-based land use regression model. And for that, we took satellite OMI data, satellite NO2 data from OMI, and then CPCB monitoring data. So we have two types of monitoring stations, that is continuous ones and the manual ones. So we prepared like 2-3 models based on like only automatic, only manual, and combined both to see like to have best prediction of NO2 over the ground. So what we did, like around each monitoring station, we built 22 different sizes of buffer and calculated all other predictive variables like population density, tree cover, water cover, vegetation cover, and others mentioned there. So we created 22 buffer, calculated all the variables in all those buffers. So in total, we had 209 variables. And after that, we did regression analysis for all the 3 models. And in the end, we found like the final model, which has like both continuous and manual monitors, had the best prediction of 73% predictability. And this is like the bottom figure, having the 4 cities mentioned. That is the data we developed, and this is at very high resolution, that is 100 meters. So even we can see the city scale variation through that data, which is not possible from the satellite data. So we use this data for the health analysis, section 1, please. So section 1. So the health outcome we used was ARI, that is acute respiratory infection. It is kind of a lower or upper respiratory tract infection, and like globally, it is like health risk factor for children with 15% of death globally. So we thought to have this variable in like for health analysis, and where we got this variable, we got this from National Family Health Survey data, and these two figures, they showed like the first A figure shows the population weighted NO2 over the districts in India, and the second one is ARI prevalence over India. So we are kind of seeing the same patterns where we have the highest ARI and highest NO2 level. So we then did section 2, please, again. So then we decided to do the health analysis. For that, like, let's understand the data structure first for that cross-sectional data, NFHS. So how they collect data in each district, they have various clusters. They call it urban and rural clusters, and each cluster they have 100 to 150 households, and each household they have participants, women and men, and they collect the data from them. So for our analysis, we had two sample size of 2,59,000 kids, and out of dropping all the kids who don't have like necessary confounders and covariates, we finally had 2,12,000 kids in the final model. So that figure shows the, figure number 2.4 shows the cluster location and the NO2 values on each cluster. Section 3, please. So now, like, we perform logistic regression model, and with the following covariates and confounders, that is sex of child, place of residence, maternal smoking, and others mentioned there. So we did that, and we found that like with every 10 microgram per meter cube increase in NO2, ARI increased by 26%. That's a huge number. And after that, we also did a stratified analysis based on place of residence, and we found that like in urban areas, NO2, if we increase NO2 by 10%, there is 8% increase in ARI, while in rural areas it's very high, it's 47%. So we were trying to think like why it's high in rural areas. So first reason could be like because India is dominated by the rural areas, and all the power plants and industries, they are mostly set up in rural areas. So we need to consider rural areas as well for our policy implementations and things. So section number 4, please. After that, we thought to do some health benefit analysis. For that, like if we reduce NO2 source emission reduction by like, let's say WHO interim targets, so what will be the benefit? So what we did, like using the following equations, we calculated relative risk, attributable fraction for NO2, and finally we calculated the benefit. So like if each district, so figure number A shows like if each district will follow the nearest interim target, WHO interim target, so this much will be the benefit. Because following the like whole WHO guideline for all the district is bit stringent. So we did it like first, if all the district will follow their nearest target, so this much will be the reduction, and that is like almost, the red areas are like which will see very less reduction, and blue ones are which will see more reduction in ARI. So, and the second one, like we also did this, is all the district will follow WHO guidelines, that how much will be the reduction. So we were seeing like a straight 10% reduction in ARI if they will follow the nearest WHO guideline, interim targets. And like I want to conclude my presentation by saying that like NO2 is associated with a lot of health risk, and there are no country scale epidemiological studies for India. So we should necessarily have like policies like NCAP for NO2 source emission reductions so that we can achieve the goals. So, and I want to acknowledge IIT Delhi, University of Queensland for the software support. I want to acknowledge NASA, CPCB, CDAC for all the data. Thank you so much.
We are open for questions now. If there are any questions from the audience, we can take them.
Thank you for your excellent presentation, all the speakers and young presenter. Basically, you are the future of India. I will start with the last one. Neha, you have presented really well, but if you look at the odd ratio, so if mother is uneducated and living in a crowded place, so it shows that there will be more healthier children than if they live in a less crowded place. So what is your comment on that?
Like yours. Hello. So you are saying mothers in rural areas, they are like.
Go through your odds ratio table, you will see that, odd ratio 1 is there, means there is no impact. But if it is 0.9, like you were showing 1.1 or 1.3, so it was in a negative direction. So it means that if you live in a crowded place, ARI cases will be less. But this may not be the case. So look at that. Another thing was that if a mother is less educated, the O's were 0.9 like that again. So what is your comment on that basically?
So, like we undertaken like mother's education in our model. So that is also part of it. And I want to say like, because NO2 is highly variable and it varies a lot and it also converts to ozone and other pollutants. So in case of that crowdy place or that, so I was just thinking how it will work.
Somebody wanted to ask a question there. That lady has probably raised her hand. You had a question, right? Yes.
Yeah, this question is for Praful. Hi Praful. I just want to know where you get the data for the black carbon, because CPCB is not reporting black carbon data, and where either you have installed some instruments or how you get that black carbon data.
Yes, we are getting black carbon data. We have WIFEX site at Delhi, so and Rasagam site, which is installed in the IIMD Delhi 5th floor. So we are taking data from that. We are also taking data from AMS and also CPCB data, and CPCB data for other species. Yeah, black carbon they don't report, but for validation purpose of our instrument, we are taking data, and also we are taking data from reanalysis of CAMS, ECMWF CAMS data. So that is also helpful for our validation.
I request everyone to please ask questions so that we can evaluate the properly.
I have a quick question to Sarita. How do seasonal variation affect the concentration of trace elements in PM 2.5 and its water soluble fraction?
So seasonal variation, like we see certain elements, like we have seen seasonal variation, like for certain elements we are getting higher concentration during autumn season, but for few elements we were getting for summer season. So when we saw for summer season, the elements which were showing higher concentration, that were basically used as tracers for vehicular emissions. And we saw that during that time, there was lot of influx of vehicles in the state, like in UT, due to the religious tourism, you can say. So also the meteorological parameters, they also affect the seasonal variation of elements. Like during winter and autumn season, the planetary boundary layer is lower, and wind speed is also lower, which leads to accumulation of pollutants into the boundary layer, due to which we get a higher concentration for certain elements during these two seasons. But for summer seasons, due to opening of the environment and dispersal of the pollutants and high wind speed, we get lower concentration of the PM 2.5 concentration and elements. But in terms of mass fraction, we saw an inverse relationship. Like during summer and spring season, concentration was lower, but mass fraction was higher. which means that the source activity was enhanced during summer and spring season.
Okay.
I have a question for Akanksha.
Yes, ma'am.
You were showing the information about the SOA and the primary organic aerosols from Delhi and Kanpur.
Yes, ma'am.
And you mentioned that it was the sources that you were finding were more vehicular in Delhi, and you said it was biomass burning more in Kanpur. So I
No.
just wanted to clarify on what basis were you drawing that conclusion?
Actually, biomass burning is more in Delhi. Sorry if I have said wrong. I have shown the pie chart. It's showing the biomass burning fraction is coming more in the Delhi. Even the concentration value is also more of the biomass burning in Delhi. This is because of the stubble burning in the nearby states from the Haryana and Punjab. And we have also makes the CWT, that is concentration weighted trajectories, which is also showing these are sources coming from these nearby sites. Whereas in the Kanpur, mainly surrounded by the villages, they are using the biomass burning, which is coming only from the coal burning or those wood burning they are using for the heating and the cooking purposes.
So you're basing these results primarily on the organic carbon data that you're getting?
Yes, yes, ma'am. I have done the organic PMF.
Organic PMF?
Yes, ma'am.
Okay.
Thanks. You.
Anyone?
Akanksha. Oh, sorry. Okay. Yeah, Akanksha, just a quick question. So, your Delhi site is located where?
In IIT Delhi.
And Kanpur is at IIT Kanpur.
Yes.
So, in your opinion, how representative are these sites for the city? And the reason I'm asking, because IIT Delhi site is very close to the highway, right? So,
Yes.
are you seeing any major signal from the traffic or vehicles in your data set?
Like in IIT Delhi, it's nearby to the national highways. They have allowed it the heavy duty vehicles during night time, which also releases a lot of VOCs, which is converted to the particulate matter. But in the IIT Kanpur, it is more away from the city side, due to which it's having the less pollutant of black carbon over there as compared to the Delhi. And HOA fraction also.
I have a questions almost for all. So let's start with Shushavan. Shushavan, what do you think, how does this solar energy reduction by the solar panel gets affected by the types of aerosols? I mean, for example, some dust particles are stick to the solar panel, or the black carbon particles are stick to the solar panel. So what would be the difference, what do you think would be in the reduction in solar energy level? If the changes, I mean the chemistry changes or the type of aerosol changes. And one more thing, that ultrafine aerosols doesn't get usually deposited, okay? So what's your insight on that?
Okay. Thank you for your interest in our research, sir, and asking me the questions. So truly we have not looked into the species wise or the composition wise how this will affect, and this is really is a unresolved question for the solar renewable energy. But so far, whatever the literature exists, they are mostly located on the dust, because the solar parks which are exist till date to across the globe are mostly over the dust region, means dust dominated regions or the desert region where the less human populations are there. So coming to the compositional effect, what it could be, as the dust they may actually deposited over the solar panel. So if the dust condition is very less, then it may if the rains are there, then it may wash out from the there. But if the dust deposition is more but the rain amount is less, then there is a possibility of the muddiness over the solar panel, so the soiling loss will be more. So, and coming to composition, like black carbon, if the black carbon is like get coated, outer coated, means we call the edging. So if it is aged by any hygroscopic particles, then there is a possibility that even the black carbon, which is hydrophobic in nature, but still will be stick to the solar panel. And coming to your second question, and also I would like to mention is that, so I'm looking into the solar photovoltaic panels, which is actually looked into the total solar radiation, that is we call the global horizontal irradiance, and it has a direct and diffuse component. So once the composition will vary, what will happen, the diffuse part of the radiation will be much more affected with the composition, because the direct part is not much sensitive to the composition. And one more, or in the second part of your question, that if the ultrafine particles is more in the environment, then what will happen? Then we found that much more atmospheric attenuation effect will be dominated rather than the soiling effect. So I feel that when the policymaker in the future time will look into the solar panel deployment in different parts of our country and as a globe, they will look into all these factors.
So Shobhan, hi, this is Sachin here. Just to continue what Abhijit said, so if you look into the typical composition of PM 2.5, right? So the majorly comes from the particles which are generally higher than 1 micron. So as these particles are emitted quickly in the atmosphere, they obviously quickly settle down on that. And then you said that there are two components. One is that what is settling on your solar panel, and what is basically because of the attenuation. These two are the major competing effects on reducing the efficiency of the solar panel, right? I was just wondering, will that effect of the attenuation, it's so high. I mean, I looked into your numbers and then just quickly browsed through your papers, right? Try and convince me that the numbers which you have given, which is attributed to the particles in the atmosphere due to the attenuation, is going to be so high. I don't know if you are aware that there was, in 2006, there was a paper by Padma Kumari and Goswami where they talked about this global dimming, right? And it has really been stagnant since then. So try and convince me very briefly that, how do you come across those calculations?
Okay, sir. Thank you for your questions. So if you looked into my, as you just feel interested to look into my research work, so if you looked into all these calculations, I have been shown on a per day basis. So when you look into per day basis calculation, then we found that the attenuation is much more than the soiling. And the effect is like that per day calculation, we are assuming that in the next day, the panel is like ideal panel. So next day, whatever be the total deposition, it will attribute it to the soiling effect. And the same thing is happening for the attenuation. But the paper you mentioned and also the existing literature, they kept the panel, or they assume for, let's say, 1 week, 2 weeks, 4 months, 5 months. Then what will happen? The total accumulated soiling will be much more as compared to the...
So if I clean it every day, I have no problem?
Yes, but that is something is economically viable, not possible.
And
you mentioned that if we go up to WHO standard, then it's really highly economical. But do you think that in Indian scenario and condition, we can achieve the 5 microgram per meter cube?
Yeah. So thank you for asking questions. So that is why we actually mention that when if we want to get rid of these aerosol-induced losses, then we have the choices. Either we can successfully implement which is already existing, like Pradhan Mantri Ujjwala Yojana, National Clean Air Program. And at the same time, for the policymakers or the investor, we actually telling them then this can be a future most optimistic goal we can set for. Yeah, definitely we cannot immediately we cannot achieve the WHO AQJ, but we are hope for the best, like the way the policymakers and our governments and others are taking care of the pollutions. Then maybe at least someday we'll achieve at least everywhere the national air quality, and then slowly maybe we'll looked into.
One last query. Do you think this Sahara Desert, which fall into the ocean there, is a pollutant?
I have not looked into the Sahara Desert, but as you mentioned, like Sahara Desert will be affected by the dust itself, because it's a dust, inherently it is a dust affected region, and the solar panels which are there, they are much more sensitive to the dust. And that is a natural dust, that is not, for the terms, if you consider pollution, we actually talk about that human-induced aerosol particles in the atmosphere or any gases. So in that fact, I cannot say that it is a polluted, but yeah, as you mentioned, there are some papers also in the existing literatures that even if all the human-induced activities has been reduced or completely stopped, then also it is very difficult to achieve the WHO AQJ. So on that line, I can say that at least the only thing I can say that we have the opportunity to clean our environment, but these are the different targets we can look into.
I have one more quick question to Neha. What are the interventions or policies could help the child respiratory health burden associated with long-term NO2 exposure?
Okay, yeah. So as I mentioned, like so far there is like only NCAP that is like mainly focused on PM 2.5 and no policies for NO2. And NO2, like it converts easily, like converts very quickly to ozone and secondary particulate matters, that is nitrate. So we don't need like pollutant specific policy, but we need like a wholesome policy which target on emission reduction instead of like a specific pollutant. So my comment will be we should focus on emission reductions and those specific like sectoral emission reductions. So that will really help in that case.
Hello. So I have one question to the papers focusing on health hazards. And I actually work on vertical air quality monitoring in urban landscapes. So how do you compare your results with that kind of urban landscape which is generally transforming? Because nowadays we have only very high-rise buildings in the urban landscapes, rather we don't have a small-scale buildings, right? So how do you compare with the results? Because we have to transform our results to the local community with respect to the urban landscapes.
So like, it's a bit tricky question because we need to, like at the ground level, we need to engage citizens into that so that they can do the basic practices to reduce the basic levels. And we are looking like at the whole pan-India scale. So what we are seeing, like we are having high resolution data and we are seeing, but it's really necessary to communicate that with the citizen at like local levels. And yesterday in one talk, I just had one idea, like when they were discussing, like people are going to schools and they're discussing with students. So I was just thinking like maybe we can make it like mandate for every PhD student to have one class each month or semester. For that will help because we researchers know the more. Because I remember when I was in school or in college, so what we were reading about air pollution is completely different what we are reading here. So I think if we will initiate that practice, so that might help.
I have a question for Sarita. Sarita, which element did you choose for the reference as the reference element for determining the enrichment factor?
So iron.
Iron. So did you check that iron has any correlation with other anthropogenic elements, so that it may have some anthropogenic source other than the crustal source? Did you cross-check before selecting iron as a standard element for the crust?
No, sir, I haven't checked that because we only analyze the water soluble fraction. So we haven't done aluminium. Certain studies are taking aluminium as a reference standard. So we have only done iron, so we took it as a reference. But I will check it once. We haven't published it yet, this work. So I will cross-check it.
So do you think soil-derived iron will be water-soluble in nature?
Sorry, sir?
Soil-derived iron would be water-soluble in nature? Do you think so?
Yes, sir, I think so. It may be water-soluble.
It depends, okay. And the last question is, how did you conduct PCA and
sir.
found maybe 4 or 5 sources, right?
Yes, sir.
But you had only the 9 elements in hand.
Yes,
okay?
sir.
So does PCA allow you to conduct the source receptor analysis only with the 9 elements?
Yes, sir. I
Would that be statistically significant?
went through certain studies. When I went through the literature studies, they were using PCA like for 4 or 5 elements. So I just found 3 main sources here using PCA. I used 9 elements. So I found 3 sources, major sources, which were also available there in the vicinity of the area.
I just wanted to add to the question that Dr. Chatterjee just asked Neha. You might want to check if there are any train lines close by to your sampling site. If I remember correctly, in one of our earlier papers, we had found that the emissions from the tires or whatever on the railway lines might be acting as sources of some of the metals, and I think iron was one of the primary ones. So you just might want to check on that.
Okay.
Thank you.
I would like to inform you all that the judges for this round are Dr. Abhijit Chatterjee Bose Institute and Professor Sachin Gunte, IIT Madras. We will be announcing the result of student poster competition after the lunch. And now we come to an end to the student poster competition round, and let's give the students a big round of applause. Yeah, before we move to the next session, I would like to remind you all that in your badges, there is a QR code for feedback. Kindly scan it and do provide your feedback to us. It'll be really helpful. Moving to the next session, the topic of this session is Designing Cities for Sustainable and Clean Air, which is a presentation round. In this session, we will be exploring the role of urban planning and ways to design sustainable cities which will meet our clean air targets and address SDGs. For this session, I would like to invite on stage the session chair, Dr. Anubha Goel, Associate Professor, IIT Kanpur, and our speakers, Professor Ravindra Khaiwal, Professor at Postgraduate Institute of Medical Education and Research, Dr. Shankar Venugopal, Vice President, Mahindra & Mahindra, Mr. Amit Bhatt, Managing Director, ICCT, and Professor Sagnik Dey, Professor at IIT Delhi. The session chair, Dr. Anubha Goel, is an associate professor in the Department of Civil Engineering and adjunct faculty at Sustainable Energy Engineering at IIT Kanpur. She is associated with Chandrakanta Keshavan, Center for Energy Policy and Climate Solutions, and contributes towards the net zero targets for IIT Kanpur. She is a leading researcher in indoor and environmental quality management, leading to healthy buildings in a sustainable built environment. For her work, she received a leadership award at the ACIEQ 2019. Now I request Dr. Anupa Goel to introduce the speakers and take the session forward.
Thank you very much. I hope I'm audible to everybody in the background. And I just wanted to give you guys a sort of a little bit of a refresher from what we've heard so far since this morning, and how the stage is very well set for this particular session right now. We heard that more than 40% of India is going to be urban by the year 2047, and we also came to know that approximately 10,000, there are 10,000 urban centers in our country, which are broken roughly half and half between the so-called standard cities as well as the census cities, that is the villages being converted to towns. So that pretty much means we are in a situation where we will be having to deal with the urban sector climate issues, and primarily the health issues that have been highlighted very well by the poster presenters just before this session so far. Air quality has also been linked as one of the indicators to the health sector that is being handled more and more. So I'm honored to be acting as the mentor for this session, where we have the august presence of very experienced and very well accomplished people on the dais right now. And I'm very happy to say that it is a very good mixture of people from the different arenas of the life we have, if we can say that. We have experienced academicians, we have people from the industry, we have people from the leading organizations which are representing your transportation sector, experience in the vehicular sector, and of course, people having background or interest in working towards the health aspect of things quite primarily. So I sincerely welcome the people that we have on the dais here right now, starting with Dr. Ravindra Khaiwal, Dr. Ravindra Khaiwal, Dr. Sagnik Day, Mr. I'm sorry, just a minute, please. I don't want to be mispronouncing anybody's name. Mr. Amit Bhatt from ICCT, as well as Dr. Venu Gopal, as well from Mahindra and Mahindra. Welcome very much to our session today. And what I'll do is, I'll be introducing the speakers as their turn comes, and we are beginning with Dr. Ravindra Khaiwal. Dr. Khaiwal is currently working as a professor, associate professor in Chandigarh in PGIMER, and he is also in the Center for Atmospheric Instrumentation Research, CAIR, at the University of Hertfordshire before he joined PGMIR. He has several different awards to his credentials. His work is focused on understanding the air pollution, the sources of air pollution, and its exposure to minimize the adverse impacts and facilitate evidence-based policies. He has received several awards and scholarships in the field, and most importantly, I'm very happy to say, he was given the Environmentalist of the Year 2007 award as around the globe as part of the NISA India. Welcome very much, Dr. Khaiwal.
Thank you. Good afternoon, everyone. First of all, I would like to thank CSTEP and my fellow colleague and all of you for inviting me here. We are here to talk about sustainable cities. When I received this title, I was a bit skeptical. Why only sustainable cities? Because somewhere 35% of the population live here. Of course, we are concerned for that, but we also need to work out for our rural area. So it should be sustainable development for all, you can say, habitats. So there is a focus on this. So I will move to the next slide. I hope this will work. We have three major components basically. What we relate is this, because cities means, if you look at the mega cities or other cities, I have mentioned 7 cities with 3 million population or 300 cities with more than 1 lakh population. So cities means emission. And when you say emission means exposure, and exposure means health effect. But the key component we forget here is also economy. So it's not only health, but also the economy is being affected. And if we have to, if we want the holistic development, sustainable development, we need to focus on sustainable cities and not only those smart cities. So why we need this? It's, you know that how can we achieve? It's everyone probably knows and discuss. The government of India launched its flagship program to reduce these emissions. It was initially 30 to 40% and now 40 to 60%, 130 plus cities. Not only this, if you go through, there are various other programs, but this one is more focused on air pollution related emissions. So we need to understand that this is how the government policies are working, and they are very keen. But when we come, we see, as a scientist, I am here. Yes, somewhere industry also here. And you will also see some other stakeholder. But do we really talk to each other? Let's say in a city, you have municipal corporation. Have they ever come to any of the scientists if we review ourselves? We have industrialists sitting here, and I'm really proud, but have they ever thought about coming to us? There is a gap somewhere, major gap is coming. We all are working in our domain, and we need to come forward. And that is why I said the stakeholder connectivity is missing. And second thing, the ground level understanding. We have cities, we have urban agglomerates, and they later on become part of the cities. I came from Chandigarh, which is a planned city. But how many planned cities after 1960 we have? Only authorizing or regularizing unoccupied, you can say illegal colonies. Will that work for sustainable cities? So why we as a scientist also give a big through that no, this cannot go through if we really want a sustainable approach to the cities. Now when we talk about, you can see these municipal corporations, they are the key or the backbone of the National Clean Air Program implementer. They have given a huge chunk, it was a discussion also early in the morning, to spend about the cleaning the cities. But do they have the idea where they will spend? Probably they will buy this cleaner, they will buy a smoke tower, they will put somewhere else also, but we are not seeing that. Then, or transport also. So they are the 6th component of smart cities, which my colleague will also talk about, like renewable energy. We were having a young talk also on that aspect. We have clean transportation. We also have, you can say, green building and waste reduction. So if we focus on these and their implementation, but through municipal corporation and industry, we will be able to achieve that. Next thing is this is how we make use of green infrastructure. If you regularize illegal colonies, how will you ensure that? So there are key components there. Then walkability and cycling. How many of you feel safe when you are walking or cycling in the city? If you don't feel safe, and then how it will be there? Another thing is smart energy and resource management. So if we want to focus on this, either through gridding or through other sources, or you know that just few days back we celebrated Akshaya Urja or Renewable Energy Day, but how that bring in a common practices, that remain a challenge. Then green building and sustainable material. I'm surprised that even in cities, you will see that the housings are built up in a way that you need air conditioning. So means more emission, means you require more energy. So are we really thinking about sustainable housing? Are we really thinking about eco-friendly housing? And then enhancing public transportation. Yes, there is a focus on public transportation and it is increasing, as well as you can say the number of people are also increasing, and we are not seeing. I came from a medical hospital, PGI Chandigarh, and we see 15,000 patients a day, and you can think about people coming. And the number of vehicle we are not able to manage. So every vehicle is probably standing on next to next, basically. So we need somewhere, means how to manage those kind of things. And community participation, that is completely lacking. When we make a policy, it should be a sustainable, long-term and locally adaptable policy. And that is why I said we need to adapt these local, local adaptation of the best practices. What works in Bangalore may not work in Chandigarh. What works in Delhi may not work in Bangalore also. So how to locally adopt with their custom, culture and the population. Second thing, when you plan for Bangalore or Chandigarh or Delhi, how can you forget the rural areas? So you need to think about, because this, as you can say that the speaker was also highlighting that by 2050, most of the population will live in urban areas. If you want sustainable cities, then you need to also ensure that surrounding is also sustainable. Means your rural locations are such a way that they don't need to move here. And this is where we need to focus upon, and that will be the major change. Like here, you can see in Chandigarh, it's a planned city, was initially designed for 1 lakh population, but it's still sustainable 15 lakh population, means 15 times than the initially, because that was the planning and the vision of the Lee Corbusier. But how we do it in our sector? So here are a few steps, like we can engage community, we can make our own community model, and I wanted to show, like, we have developed few material. Just school, we want them to adopt 10-point agenda for clean cities. We have how you can minimize pollution in your backyard or inside your home. If you do so, you can achieve that. So let us also focus not only those costly and expensive solution, or a comic booklet like this. The 2D version is also coming. The means like a video, and then 3D version is we are preparing also. So similar way, basically how you engage for effective implementation. Probably that is why we wrote this and we saw this approach of life. Means lifestyle for the environment as proposed by our Prime Minister, means behavior change modification, and this behavior change modification means my city, my role, and how can I contribute to this to minimize the emission. Otherwise, when you bring those kind of solution where we, like I could see the electric mobility is increasing in my city, but somewhere in a rural area where there is a thermal power plant, the burden is there also. So let us, as the previous session was there, justice, equity, and the green and sustainable cities should prevail, and we should look in a holistic way. Thank you very much. Jay.
Thanks, Dr. Khaiwal. That was a very interesting talk, and I am glad that he has highlighted the gap, that there is a disconnect between the stakeholders and the people who can be working towards making the reality of a greener India, a more holistic approach is required, that was highlighted. And he also mentioned that the approach should be to be implementing the interventions effectively. We have lots of laws and policies, but effective intervention implementation is where we are lacking in most cases. And of course, we have to be giving equal importance to the rural as well as the urban areas. Thanks for pointing that out, sir. The next speaker is Dr. Shankar Venugopal, who is currently at the Automotive and Farm Services part of the Mahindra and Mahindra. So he is representing the automotive industry partnership in this forum. And I'm very glad to say that he has managed to bring about a collaborative effort between the industry and the academia as well. He is also the dean in the Mahindra Academy. There is a long list of awards he has. I'll just be pointing out a few of them. He was awarded the Innovator. Okay, so I think I'll save the time and say that he is the innovator with multiple awards on the innovation sector. I leave the floor to him to be taking you more further on what work is being done right now.
Thank you. Thank you. Friends, I thought I will save some time by cutting short the introduction and share something that I really want to share with you today. I'm Shankar from Mahindra & Mahindra, and I came in quite early today, I was listening to all the presentations. I realized that many of the problems that this community is trying to address is very complex, quite difficult to solve. I was feeling a little low as I was listening to many of this complexity of the problems. Then suddenly I felt happy that I am in the automotive space where things are not that bad. Because of some of the recent developments, some of the disruptive technologies and innovations that we are pursuing, suddenly this wicked complex problem of mobility actually has become a fairly kind, manageable and a tame problem, and I'm very excited to share what makes it so kind and so positive today. And in the few minutes, I'll tell you what's happening in this space, and I'm very confident that with this approach, we can make mobility sustainable even for a city like Bangalore. Because I love Bangalore a lot, but I'm unable to drive around in Bangalore. But what I'm going to present today has the potential to actually make living and driving around in Bangalore quite possible. Sure. One request, no photos, no video recordings for the next few minutes. Sure? Okay. And how do you, sure. Not mine? How do you, this one? Sure. Got it. Sorry. Friends, I'm sure you can relate to all the three challenges of urban mobility, the pollution, the safety factors, and also the traffic jams that we all have to navigate through day in and day out. And what makes me feel very confident that this is a solvable problem today is a combination of these four disruptions that you see out there: electric, connected, autonomous, and shared mobility. I'm sure all of us are using various combinations of this in some ratio or the other, but I'm going to give you a little more holistic picture how these four can come together and make urban mobility absolutely sustainable. And what I'm going to use is these disruptive technologies that you see out here. It's a combination of this that makes mobility sustainable today. And I'm sure you'll be using at least 3 or 4 of these technologies that you see here. It's all not rocket science. It's all day-to-day things that we use. But the combination can do wonders for us. This is an electric vehicle. This is a connected, autonomous vehicle. And you can make out that it's made out of lightweight composite materials. And this can actually navigate through dense city traffic in an autonomous mode, where there is absolutely no driver. It's a level 5 autonomy. The beauty of it is there is no onboard intelligence on this vehicle. It has basic cameras and sensors. This captures what is around and sends the information to IBM Watson on the cloud. So the computation is done on the cloud and the instruction is given to this vehicle, whether to turn left or right, to apply brake or accelerate, and with this it keeps moving around in dense city traffics like Bangalore. So you can see at least 6 or 7 of the technologies I had shown in the earlier chart goes into building a vehicle like this. And this is not a futuristic technology. This has been on the road for 6 long years. The version 2 of this was recently released. So this is here and now. But what makes electric mobility so exciting for all of us is the fact that there is absolutely zero tailpipe emission. Zero. Absolutely zero. The only care you need to take is when you connect this vehicle for charging, you need to ensure that the electricity comes from clean sources. Then you can absolutely be safe. What is also good is the economy, the fuel economy. We are talking about energy conversion efficiencies of 80% and above, as compared to 20 to 25% when we are working with the IC engines. Of course, the total cost of operation because of the fuel cost and the maintenance cost is ridiculously low. But today, if I ask you, are you ready to switch over to electric vehicle? I'm sure you will have some concerns in mind, the top one being the range anxiety. How far can I drive around in this electric vehicle, the limited range, the limited energy that the battery can carry. And if I have to charge, it's going to take quite a long time. I can't just, like the way we drive into a fuel station and drive out in 5-10 minutes, we can't do this with the electric vehicle. It takes finite time for charging. So we are worried about that. And also the cost, the battery being a bit expensive, the initial cost of this vehicle is expensive. So these are some of the factors that kind of make us think, are we ready to switch over to EVs? And luckily, all of this can be traced to one key component, which is the heart of the electric vehicle, the battery. If as a country, if we can crack this, then we'll be able to build sustainable mobility, not only for India, but for also many other similar parts of the globe. There's a huge business opportunity out there. There are two materials, talking from a sustainability perspective, there are two materials that goes into this battery. I'll talk about at least one of this, lithium. Lithium is a super important material if we want to really crack this problem of sustainable mobility. Lithium is a critical material. There are only few countries in the world which has lithium: Argentina, Bolivia, Chile, and Australia. That's it. That's it. Not China. Okay. China has long-term trade agreements with these countries to source lithium. They process and purify and make batteries, but they also don't have. But these are the 4 countries. And so there is a lot of concern around the availability of these critical materials when we want to actually scale up manufacturing of electric vehicles and build this sustainable electric mobility. So I started my work in this space by using the system dynamic modeling and to predict kind of future scenarios and how to match the supply versus demand. That's where I started. And this was the initial model I built 5 years back, and over the 5 years has refined pretty well, and this is able to make reasonably good, accurate predictions. But what it led to is, one is urban mining is going to become super important for us. We just cannot afford to throw away those lithium-ion batteries. We need to make sure they are designed in such a way that we can get back every single atom of lithium that goes into these batteries. Along with lithium comes nickel, manganese, a few other materials, but we have to do this very wisely and carefully. And if we can do this, we can do this not only for India, but for the rest of the globe also. This is a very, very big, important and business opportunity which is really growing. So urban mining has suddenly become really important. Of course, the other area which is really attracting a lot of funding these days is deep sea mining. Why limit ourselves to only the land when it comes to these materials? One can look at the deep sea also. Today, technology allows us to do that, and many of these materials are actually available in plenty in some parts of the sea. And if you thought that is little exotic, the next chart, okay, we are actually firming up a lot of policies around intelligent use and responsible use of ocean-based resources. This is going to play a very big role as we go forward. This is a little more exotic, actually. These are also big ventures which are well-funded, which is asteroid mining. And some of these have a lot of these critical materials in plenty. This can actually change the whole scenario if this becomes feasible. And these are being very actively explored. Now, of course, I'm sure all of you would have heard the good news that Kashmir, near Vaishno Devi, we found 5.9 million tons of lithium. So we do have lithium. It's not just Argentina, Bolivia, Chile. India also has lithium. Sure. Yeah, I'm done. So we are very close to this tipping point where the cost of electricity storage in a lithium-ion battery is going to become super economical, and it will become more economical than running a IC engine and a fossil fuel powered vehicle, because we are going to cross the $100 per kilowatt hour. We are very close to that tipping point that could happen very well before the end of this year. That's going to entirely turn around the scale. Last, the opportunities when we talk about mobility is threefold, because the automotive industry, the traditional automotive industry, is now converging with the energy and power industry and also the infrastructure. So if you are in the mobility space, your possibility of innovating and making an impact is actually threefold. And this is the best time to be in this space. So with this, I'd like to just wrap up what I said. It's very important for us to reimagine sustainable mobility, not just by looking electric or hydrogen one at a time, but really look at convergence of multiple exponential technologies that can solve some of the most difficult problems today. Second point, focus on important strategic areas like the critical materials that I talked about, lithium and cobalt, and also the rare earth materials for the magnets that goes into the electric motors. Very important for us to shift from a constraint-based thinking towards abundance-based thinking, because actually there is abundance there. The constraint is more here than outside. So we need to consciously shift when we are taking up some of these sustainability problems to work on. Last but not the least, the industries are converging. The traditional industries are now coming together to create the new mobility industry. So the opportunities to innovate and impact is much, much higher going forward. So I see it as a very, very positive move out there when it comes to creating sustainable mobility for the future. Thank you. Sure. Oh, there's a second bell, so we have 2 minutes. So would like to ask anything quick? Okay, then I will give the 2 minutes to my next speaker, please.
Thank you. Thank you very much, Dr. Venugopal. That was a very interesting talk. And we came to know lots of things that some of us might have been confused about. And I really like the fact that we have come to know firsthand the importance and the benefits of electric vehicles, but the challenges that we face in really adopting the policy in India has also been outlined very well and very effectively. And it's good to know that the industry as a whole, they are beginning to come together, and we are looking towards a more sustainable mobility system being in operation in India, hopefully pretty soon. Thank you very much, Dr. Venugopal. The next speaker we have is Mr. Anand Bhatt. He currently is the MD of the International Council on Clean Transportation, ICCT, and he's representing the organization sector in our current discussions today. He has been the executive president of WRI in India as well. And I would just, before I get him on the stage, I would just like to mention the ICCT vision that I saw online. The vision is basically to improve the environmental performance and the energy efficiency of the transportation sector. With that, I leave the stage for you, sir.
How do we move forward? Thank you. Good afternoon, everyone. So Dr. Anubhav mentioned that by 2047, we will have more, almost 40% population living in cities. But then if you look at the World Bank report of 2015, which looks at India's urbanization and concludes that India's urbanization is very different from the West. It's hidden and it is messy. And with that at the background, the World Bank concluded that in 2015 alone, India had about 55% population living in urban areas. So if you look at that methodology, we already have majority of people living in urban areas. And as we move forward, we will have even more population living in urban areas. And estimates show that by 2030, Delhi will become the largest urban agglomeration in the world, bypassing Tokyo. So the biggest problem that comes with this rapid urbanization is this whole issue of motorization. And my talk is only limited to transport, emission, and its impact on air quality. But before I get into it, it's also important to understand that transport is very, very important from the climate change perspective. And we know the G20 deliberations are going on. Something will come out very strongly, hopefully on climate change and transport. But it's also a very important energy security issue for us. Because 90% of the crude oil that we use in transport, overall crude oil we import from other countries. So while I do hear this question of, do we have enough lithium, do we have enough cobalt, do we have enough this and that, we don't have enough crude oil. We are importing 90% of the crude oil. So please understand that it's also important from the energy security. But again, this conversation is mostly about air pollution, so let me just bring down my point to air pollution. And we do hear this talk about particulate matter. But again, NOx is a very, very important aspect of air pollution. And we have seen that while direct exposure to NOx does damage cell membranes, but we know that, as someone mentioned earlier, that it converts into nitric acid and then it leads to increased particulate matter formation. So particulate matter, in addition to NOx, is very, very important from the public health perspective. And this is where I think we are slightly going wrong in terms of the impact. And I'll come to that. So we did some work earlier to understand what's the impact of transport exhaust on public health. And this is some of the data which I've been sharing from a couple of years back. And we said that India roughly loses almost 75,000 premature deaths every year, which are directly attributable to transport vehicle exhaust alone. And that is something that is a very, very large and scary number. With that in the mind, we started looking at, but where are we going wrong in terms of understanding the emission from transport sector? Because as someone said earlier, unless you understand, unless you have data, how will you solve that problem? So we looked at how do we measure emission from transport. So the type approval plan that came in from 23 onwards looks at real world driving emissions during type approval stage and some random selective checks for looking at emission. But the most important piece of control is the pollution under control certificates that vehicles have. Now, as I said earlier, the most important criteria pollutant from public health perspective is NOx and particulate matter. And if you look at this slide, you'll see that in the PUC regime, we don't measure either the NOx emission nor the particulate matter emission. So, and that's the big discrepancy. But in addition to that, what we also don't measure is these are static tests. The emission are not linked to, let's say, what's your driving habit? What's the road infrastructure like? What's the age of the vehicle? Is the vehicle overloaded? How is vehicle maintained? Those parameters have a very, very significant impact from what comes out from the tailpipe. And that is something we don't measure in the current regime. The reason why I'm just bringing this point over here is that this is a very important slide from us, from ICCT. And what we saw was, if you Google something called a Dieselgate, you will realize that almost 7-8 years back, we found that on-road emission that you see in the graph versus the lab emission that you see a green line in the US. And this is one of the largest automotive manufacturers in the world. The difference was not in some percentage point, but difference was almost an order of magnitude, almost 50 to 70 times more emission in real world than lab values. So you can Google, you can read the Dieselgate scandal. If you don't feel like reading, you can go to Netflix. Dirty Money, season 1, episode 1 is what you can see, and you will get to know more about that as well. But the point I'm trying to make is that the real world emission is very different from the lab values. And unless we understand how the vehicles are performing on real world, we'll not be able to make a substantive impact on how do we reduce this emission that comes out from tailpipe. So for example, this is some studies that we did looking at various vehicle types and various fuel types of cars in Paris almost 5 years back. And you see the lab limits, and then you see the actual limits of these vehicles when they are running on the roads. Huge difference. Then we said, how does it relate to in India, especially now that we have seen a massive shift from Euro 4 to Euro 6? And we thought, why don't we look at maybe a latest public transport a bus in India and understand how does that bus perform in the real world scenario, since we are promoting a lot of public transport. So if you see on the left side, you will see NOx emission, and the right side is the particulate number emission. What you see is a line is the prescribed lab values limits, and what you see is the actual emission that is coming out. So in case of an urban route, you can see the NOx emission through the chart. And then if you look at suburban route beyond the limit. So the point I'm trying to make is that the real world emission is definitely more than the lab value. So the question is, what do we do? So one definitely is, as the previous speaker said, that if you shift to electric, you really are not emitting anything from public health, from the tailpipe. And that's a very, very important parameter. That, yes, you are emitting when you are burning the fuel in the power stations, but that decarbonization in any ways we have to do. So we have to decarbonize our energy system, not only for transport, even for residential buildings. So, I mean, this hotel should also draw its power from the renewable sources, not only just transport, right? But the zero emission tailpipe emission, you address this issue. So one way to do is maybe look at some of the modern technologies. So we are currently doing this real world emission test in Delhi. We have captured about 110,000 vehicles through this remote sensing equipment, and which is where you see the vehicle passes through the spectrometer. The spectrometer kind of checks the vehicle. And if you can click on the slide, you will see a small video in case it works on the left image. But the idea is to capture not only hydrocarbons, particulate matter emissions, as well as NOx emission, and then get a sense of what, and then you are also capturing the license number plate. So you also have this Vahan database where you can do all kinds of analysis of real world emission. How does it impact from fuel type, vehicle type, age, all kinds of analysis can be done. And the idea is that once we have this, we can identify what are the cross-emitting vehicles in the city that requires immediate attention. We also understand that how is PUC, pollution under control certificates, performing in the real world emissions. We can also get a sense of the so-called modern technologies like BS6, how are they performing on real world emission, but also to provide evidence for some kind of action. So Delhi is saying, let's ban old vehicles, but how much of old vehicle is contributing in terms of the real world? But also to set up a new regime of understanding how can vehicles be tested for understanding what comes out from the tailpipe. So with this, I'll end my presentation, but happy to take questions later on.
Thank you, Mr. Bhatt. That was very interesting to know that although we are based 90% crude oil we are importing from outside, and definitely there is a lag between what we are measuring on the in the lab and what we are actually getting in the real world scenario. And it's very interesting to see that this real world emission test is being done. I would just like to, with all humility, I would just like to update the audience and the people on the stage that I've been working on a national carbonaceous aerosol project. And as part of that, it is the responsibility of my group to finally be publishing the emission factors that have been measured for the light duty vehicles through on-road runs. So we've been working on the data, and we can say, I'll not put the official numbers, but through the on-road vehicle test, we have been getting the values of the emission factors for certain parameters up to 50 times more than what is being used from the emission factors that are available in India right now. And I'm quoting just, I believe it's for the older vehicles only. We have done a few of the newer vehicles as well. So we are working on the publication, and hopefully something should be coming out soon. Now I take the pleasure of inviting the last speaker, Dr. Sagnik Dey from IIT Delhi. He is the Institute Chair for the Center for Atmospheric Studies, and he has a whole list of awards and fellowships to his credit. I would just take an honor of mentioning that he won the Nasi Scopus Young Scholar Award in the year 2012. And since he's asking me to stop, I leave the floor to him. Sagnik, please take over.
Okay, yeah, thank you. Good afternoon, everyone. Thanks, CSTEP, for inviting me. I've been listening to the various presentations, and it was really good discussion going on. So these are some of my thoughts, actually, how to make Indian cities cleaner, based on my own research in collaboration with many different academic and other organizations. I have basically 5 points to make. So first point is that we have been talking about this, and I will again reiterate the fact that our planning has to be on a regional scale. Any source apportionment study you pick up under NCAP or otherwise, like Dr. Sharath has done modeling-based source apportionment for more than 50 cities and all. The key message is that there is a large proportion coming from outside the city. So very clearly, we have to move from city-centric to airshed approach. Now, airsheds are defined in a way that the region that influences actually to a particular city, and based on the satellite data and the meteorological analysis, we have divided the country into major regional airsheds, and within each airshed, then you can identify which city belong to. You can also define city airsheds. So the point here is that knowing that these airsheds exist, what needs to be done is that the cities should join hands, integrate their clean air action plan. And not just the cities. What is also important, we have been listening to green commute and all within the cities, but I will also argue that intercity commute also is a very important part, because you take any city or two cities rather, and you look into what is happening between the cities. I will just give one quick example. We all know that in 2019, we have the peripheral expressway, if you are familiar with Delhi NCR region, came up. Because all the entry of the trucks or heavy-duty vehicles are banned in the city, so we have developed these peripheral expressways with the entry point to various cities in the NCR. What happened is that when we look from satellite data, we are noticing actually pollution is building up all along this peripheral expressway, because that's where the heavy-duty vehicles are plying. They are emitting, and we are thinking that we have stopped the entry of these trucks to Delhi, but we are not considering the fact that this emission is now in that region, which again, anyway is, meteorology or wind will carry the pollution to Delhi. So these plannings are very much important. The second point is that integrated and synchronized framework is required. When you look into the data, and by data I mean any kind of data you pick up, either the CAQMS or, as I said, we have the satellite-derived PM2.5 for the entire country, which we developed for CPCV. What we are noticing is that in the NCAP era from 2017 to 2022, we are seeing a kind of stabilization. If you look into the data for the last 2 decades, pollution level was quite rapidly rising, reaching a peak around 2017. And then 2018-19 onwards, it kind of started stabilizing. 2020 and 21 had a benefit from lockdown-induced effect. And 22 is almost at the par. So what has led to this stabilization is not known. Is it really meteorology? Are we really successful in reducing emissions? We do not know. And why? Because our emissions are not updated. And what we forget is that change in emission is not equivalent to change in concentrations. We are only looking into the concentration, and what we do is actually we follow this method that, okay, we'll build up emission inventory, do source apportionment, this is one-time activity, and then we'll make some policy. We really do not know what policy is working, what is not working. And Also, there is no synchronization between these emission inventories that are being developed. We are already lagging behind. We are in 2023 and we do not have a national inventory earlier than 2018. I think the latest emission inventory at national scale that we have is 2018. The Coalesce project led by IIT Bombay and also the emission inventory work led by my colleague Professor Ghazala, we are coming up with some 2019 estimates, but we are already 4 years down the line. So unless we have periodic updates of these emissions, we really cannot link to anything. If you look into the meteorology in the bottom panel, that how the ventilation coefficient Dr. Sengupta mentioned in the beginning today, how it has changed with respect to the 2017, which is a baseline year. So 2020 and 21, lot of blue means there was actually a reduction in ventilation coefficient. And as I said, despite of this, because of the lockdown and all, PM 2.5 level is quite lower, but 2022, if you see, large part of India actually was benefited by favorable meteorology. So this analysis is really needed to be done. And it is not just that annual concentration, but also what is happening season-wise. Is it the summer that is driving the annual concentration, or is it the winter? Have we really made any difference? So that's the second point. Third point is that when we come to the localized scale, it is very important to actually isolate how much the variation is due to the local sources from regional sources. And a lot of interventions are going on without really having any scientific evidence. For example, again, this is a pilot we did with CSTEP and IPAC. We wanted to see, because one of the things in all clean air action plan is actually paving of the roads. We wanted to see whether that makes any difference at localized scale. So what we did is actually those 3 places in Delhi, the green dot is where actually the road was being, paved and made. And then we had another sensor probably 400 meter away, that's the yellow one. And then the red one is kind of 800 meter away from that particular site where the road construction was happening. And once you take care of the natural seasonal change, regional change and all, what we are noticing is that after the road was constructed, there is an improvement locally of 32%. Now that improvement is not seen by the sensor, which is around 800 meter away. It means that it's a very localized impact. Similarly, we also looked into another study, another kind of thing. You will see this kind of smog guns being deployed all across the city. We tried to see whether it makes any difference or not. We see that yes, once you do this, there is this dip. And again, if you do the proper analysis, looking into natural changes, regional background and all, we are noticing because of these smog guns, there is an 8% reduction in Delhi PM 2.5 at a very localized scale. But probably the effect will be only up to 100 meter or 200 meter from that particular site. So now you do your math and see that to make an impact city-wide, how many times and how much resource you need, and really is it worth it. So those kind of linkages is very, very important to establish, and then you do the efficacy check and then you actually prioritize. Because otherwise what is happening is that we are just doing things very randomly without any this thing. The last point is that when you talk about inclusive or futuristic plan, we must bring health into the picture. This is very interesting study done by one of my students where we simply ask the question, we are talking about NCAP. So what will be the health benefit or the mortality burden based on the latest knowledge? And this is from the India GBD framework that was led by Indian Council of Medical Research. So what you are seeing is that the red is the mortality burden for 2015 for each state. Blue will be the mortality burden if every state meets the NCAP target of 40% reduction in PM 2.5 value in 2026. And then the green is actually that the next interim target if the states meet in 2030. What you are noticing is that even if you meet the NCAP target, many states like Delhi and others will not achieve any health benefit considerably, because although you will be reducing your pollution level, the population itself is growing, and that is kind of compensating the benefit. And because this kind of information clearly tells that reducing exposure alone is not enough, and you need to really look beyond NCAP, because right now also the other point is that we do not know what is the next. We are struggling even to fulfill the NCAP objectives, but we do not know what will happen after 2026, and we must start planning, because we cannot wait and then see what is happening under the NCAP. And the other important point when you talk about the cities the vulnerable group and all these things need to be individual. The last point is that community engagement, and very quickly I want to say that we did a study, and there was a session yesterday, to understand whether people can change their behavior. So what we did is in Lucknow and Delhi with COO, every morning we send them alert that today this is the air quality and some specialized message. And basically we tried to see what people are doing with this, so we undertook a survey, and this has been going on for 3 months during the peak pollution. And the main message I'm trying to say is that what we notice is that yes, if you effectively communicate with people, many people actually are willing and they have changed their daily routines. Many people said that looking into the air quality, today I abandoned my car and traveled in public transport. So we have some very good response from people saying this. So we need to actually make it more routine and much more effective and community-centric, this kind of engagement. So my last slide is, these are the takeaway message, that we are talking about, all these things, but we must prioritize sustainable and cost-effective measures. And we should also define success metrics. Because otherwise then it is very difficult to assess. And my last point, as I said, that NCAP is really a good start, but we are in 2023 and we should start planning what is beyond NCAP. Thank you.
Thank you very much, Dr. Day. And I'd say that his talk ended with a very positive note, that if you are informing the people correctly and noticing, trying to follow their behavior, so there actually is a change. And with that, we come to a presentation session. I'd just like to highlight or summarize a few things over here spoken by our 4 presenters. The first thing is that we need to bridge the gap, and we need to start talking to each other and use each other's experience and the skill set quite wisely. And we need to prioritize where we will actually be placing our efforts for effective interventions. With that, I believe there is some time for the question answer sessions left. So if the audiences have any questions, please raise your hands.
My question is to Dr. Venugopal. Sir, yes, it's absolutely right that electric vehicles is associated with almost zero emissions. But again, there are issues like number of charging stations that needs to be enhanced, and also that charging should be, the source should be some unconventional energy. So again, there are issues of the availability of land and installation of solar plant and initial cost. So don't you think that if we think of more exploration or the technology advancement for the catalytic converter that is used in the fuel rather than switching over the fuel?
Okay, sure. This is just my personal view. Having been in this space for a few years, I firmly believe that a battery-powered electric vehicle is the path forward if you are looking at sustainability. And since I have a finite time to work on problems and solve, I thought I'll just prioritize this, focus only on this rather than getting distracted by any of the other alternative technologies. They may have potential, but I am biased towards electric. Having said that, today, just because suppose you can afford a very expensive big battery pack for your vehicle and then say get a 500-600 kilometer range for your car. Actually, that may not be the most intelligent way to use this available scarce material like lithium. One should be very careful about the size of the battery pack that we go for, because our daily commute is like 50 kilometers, 60 kilometers on an average day. But even with a car with 200, 250 kilometers, we still have the range anxiety, which is not really logical. One can always get back home and do the slow overnight charging, which is also good for the battery, actually. What really addresses this in terms of using the minimum battery size being very careful about the amount of material that we use and still addressing all the anxieties so that we have a hassle-free experience is a smart and connected features that's available in the cars today. Suppose I have a car, 200 kilometer range, I want to drive from Bangalore to Mysore. Then I will exactly know what is the traffic situation, where are the charging stations located, where I should stop for a coffee break so that I can up it by another 25% and move on. All that is perfectly plannable, and without any anxiety you'll be able to reach. So that actually mitigates a lot of the risk around this range anxiety. Charging station is a critical enabler. The next 1 year, a lot of charging stations, fast charging stations have to be built in India. That will be the key enabler for the adoption of electric vehicles, which is the right move towards sustainability. Battery, we need to basically make sure that the way we design and manufacture the batteries, it's completely recyclable and reusable. Then the worry about battery is addressed. The only thing now comes to the electricity being from solar or other renewable sources, so that you are not shifting the emission to some other place when you are doing this. That is also possible.
Thanks,
Two
Dr.
things in terms of that is making sure that you are tracking the source, which is again through blockchain and many other technologies. You can actually track where the energy is coming from, how much you are consuming, your carbon footprint, everything is trackable today. So it's not very difficult to ensure that you are using clean electricity for charging your EVs, I'm sure.
Thank you very much, Dr. Venugopal. We are running a bit short on time, so we'll just take 2 more questions.
Okay, so I still have an opportunity for a question. Thank you for that.
Well, we can take rest of the questions during lunch. Okay. So we'll break up for the lunch session now. Thank you all very much for your attention. And thanks again very much to the presenters on the stage. Thanks for the information shared.
Yeah, thank you to all the speakers and Dr. Anubhav Goel for chairing this session. I will call Dr. Rishikesh to give the token of appreciation to all the speakers and the session chair.
Thank you. It's 2 o'clock. Thanks. Thanks. It's quite late. Actually, our session could have been post-lunch. That would have been easier.
Yeah, so we have a lunch break now, and I request all of you to please be back by 2:45 since we are running late in time, and I kindly request your cooperation in this matter. Please be back by 2:45. Thank you. There is a small announcement. We have kept a box towards the end of the hall. You can drop your ICAS plastic cover in that box so that we can recycle it. Thank you. Now, our next session is on technology for change, which is again a presentation round. In this session, focus will be essentially on the latest innovation in air quality management and identifying opportunities and challenges in their adoption across various institutions. So without further delay, I would like to invite on stage session chair, Ms. Amishi Tiwari, Senior Analyst, CSTEP, and our speakers for the session, Dr. Sharad Kuttikunda, Founder, urbanemissions.info, Dr. S.K. Goel, Scientist and Head of CSIR NEERI, Mr. Vivekanand, Advisor GIZ, Dr. Abhijit Chatterjee, Associate Professor at Bose Institute. Ms. Amishi Tiwari is a Senior Analyst at CSTEP. She completed her Master's in Environmental Studies and Resource Management from Terry School of Advanced Studies. Amishi, over to you. Introduce the speakers and take the session forward.
Thank you, Jigisha. Good afternoon, all. We have witnessed some very thought-provoking discussions throughout the day, And we have yet another interesting session lined up for you all, with some very eminent speakers joining us today. And I'm honored to be moderating this session. Earlier in the day, Dr. B. Sen Gupta, former member secretary of the CPCB, highlighted the importance of integrating science and technology into air pollution control programs. Undoubtedly, science and technology are essential pillars in our efforts to combat air pollution. Advancements in and strengthening measurement and monitoring, information dissemination systems, and decision-making infrastructure by incorporating emerging technologies like artificial intelligence can help us drive positive change. In this session, under the theme Technology for Change, we will be discussing on how we can leverage technology for effective air quality management and the associated challenges. Since this is a presentation-based session, let me highlight a few logistical details. Each speaker will present for 10 minutes, and to help us keep time, there will be a bell at 10 minutes, and another one at 8 minutes, and the other at 10 minutes. And in the interest of time, I would request all the audience members to please reserve your questions for the end of the session. And now that is out of our way, let us begin with our sessions. First speaker would be Dr. Sarath Guttikunda, who is the founder and director of Urban Emission Info in India, and I hand it over to you, sir.
Thank you. Oh. Sorry. Where do I go? This is the previous one. Ah, okay. Yeah, while we are waiting, I can run through the slides mentally also. So one of the things that, an article that we wrote a long time back, the 3 people that we really need for addressing air quality management. So we have feeders, those are basically people who are generating information. And we have drummers, who are people, they take that information and start talking about that information so that we have some action on top of that. And we have policymakers, basically, who will take note of all the emissions that are coming, and also they make the right decisions so that some action actually takes place on the ground. I won't talk about everything. I've been tasked to talk about what kind of technology changes that are happening and what kind of challenges are there, highlight some of the challenges we are focusing. I'm pretty much a feeder, so I'll basically focus on data only, on what kind of technology changes that are happening in the data field that we are now using, and hopefully we can even improve that over time. So I just put them in for these 4 buckets. I'll just walk through that. So traditionally, our need has always been wanting to have regulatory grade air quality monitoring stations everywhere. Not cheap. They're in our current operational buying costs are close to 2 crores, and then you have a 10% operational cost. All those things add up. Right now, there is still push for these traditional full-scale regulatory grade monitoring stations, which will cover all the criteria pollutants and the meteorological parameters. So that's the dream that every city is trying to focus on, and there is a limits on how much can actually get operated. Now the emerging thing is these low-cost sensors. I mean, we've seen a lot of this discussed in a number of the presentations, and these numbers are increasing. The use of these sensors is increasing in different forms. I think what is going to change is basically trying to meet that number, like 4,000 plus air quality monitoring stations that we really need on the ground so that we can spatially and temporally represent what is happening in Indian cities and Indian states. And that's still a long way away. These are totals from a few months ago. So we have about 883 manual stations, which measure only PM2.5, PM10, SO2, and NO2. And then we have currently we have about 480 operational continuous monitoring stations, which measure like all the criteria pollutants and also the meteorological parameters. In the morning, Dr. Sen Gupta has highlighted that we have a lot of issues, especially in the quality of the information that comes from both from the manual stations and also from the continuous stations. So there are a lot of challenges there we really need to address. Now, in terms of these three sub-buckets, calibration, maintenance, and integration of this. The integration problem is primarily in the sensor network. So right now, a lot of people are using them, doing their own calibrations, but we are having challenges in integrating that into not only in the research side, but also on the policy side. So we have some objections from the official group saying that we can't use this, even for mentioning that we are using sensors has become a bit of a challenge in some states. So we are going through some of those challenges. So we really need to work on these three things: getting good calibration system in place, we have a good maintenance system in place so that we can regularly either upgrade the deviations that we are seeing in the sensors, or even replacing them if we find them not really operating. And again, integration is for everybody, both on the science side and also on the policy side. The air quality modeling itself, traditionally we've seen a lot of models that are being used. I mean, for the longest time, the old times are the box models that we had. Then we had Plume and Gaussian, Lagrangian type models. They are all still in use, very useful for quick work. And also we have a new generation chemical transport models, which are 3D, Eilerian models. Those are also in place. But very few groups are doing at the scale we really need to support some of that science work. Now, one of the points that Vinayak Sinha mentioned yesterday is lack of that third grade Eilerian systems in place so that we can not only address the problem of how much is the pollution, but where is the pollution coming from chemically. Not just from which source is contributing how much, but chemically can we study well on how much pollution is coming from what gas, like SO2 is how much is that contributing to PM 2.5, or NO2, how much is that contributing, or SOAs, like VOCs to SOAs, how much is that happening. So that part is still a big gap is there. The emerging side is this AI, ML discussions that are happening quite a bit, but there's a big challenge on that part in trying to get access to what do we feed these models. The shift is really interesting. We can do a lot more if we make that step a lot more operational, but we need, again, a lot of information to make that second step that much more powerful. And I will still insist that our biggest challenge is still in the traditional modeling stage. We really need to improve that in many ways. And one of the biggest challenges we have today is in the personal training. It's not about computational capacity, it's not about not having access to models or not having access to data, but we really don't have enough training activities that take place to make all these things like fully operational and take it forward. So a lot of these things need to really improve. I think all of this will change if we focus a bit more on the training aspect of it. That's the biggest challenge in this bucket. Next is the data access itself. Traditionally, we still rely on PDFs and a lot of paper that gets. So for example, as simple as AQI. I want AQI information. If I go to CPCB's website, I can only download a PDF. Okay, I can't get a digital CSV file that I can immediately use without actually having to scrape the PDFs and tabulate it, adjust it, and all that stuff. Okay, but we're still in this stage. Now we really need to move to a place where things are really online, things are updated, and really fast access so that we can do a lot of these things we are talking about. Now we want to do a lot of emissions modeling. We want to talk about a lot of impact assessments. All of these things to happen when we really need to push the needle towards that. I actually wanted to put my own website because we actually put everything in CSVs so that people use, but I didn't want to do that. But For example, this site, this is Robbie Andrew, I think I'm sure he knows it very well. A lot of data is actually posted here. We actually use it. Everything is immediately accessible. Everything is like CSVs. If you want power data or fuel sales data on a daily basis, a lot of information is loaded there. Very few people actually know that it exists and use it. It's beautiful. The thing is, I'm putting this as an example so that eventually everything we need, whether it's data from CPCB's website or data from any of the surveys that's being done to feed any of these models, if we can find a way that is accessible and usable by as many groups as possible, that will change some of the work that we are doing, both in terms of speed and both in terms of the size of work that we can do. The last one is the mitigation bucket. Both sides I put in same fuels on both sides because this shift is going to take some time. Okay? But the data aspect of this picture is number crunching from emissions, number crunching of impact, sorry. So this is one of the last points that Sagnik Day has mentioned in his slides. So we really need to, if we are able to translate the impacts of various interventions in a way that everybody understands, then we will definitely see the shift from whatever is traditionally understood to what is the new emerging thinking that's happening and what kind of benefits does it have. If it doesn't have any benefits, then we should show that it doesn't have benefits. The only thing is it is only going to cost us more. Okay? So we need to make that shift. Okay? So it doesn't mean that I'm not saying that, oh, shut down coal or stop using petrol or anything else. But if we can show that if we put more buses on the streets, there will be a benefit. They can still be running on petrol or diesel, but there will be a benefit. But we have to show that through numbers so that the people, the policy makers at the end who are going to take that decision will be able to understand that. Okay? So last slide, every stage of this, there are new and new technologies are coming in to understand what kind of emissions are there, how is that getting translated into concentrations, that's the modeling part, and impacts evaluation, whether it's directly looking at tons of emissions getting reduced, or are we going to decarbonize, or health part. Again, this is one of the points that Sagnik Day also mentioned. We don't emphasize on the health impacts evaluation as much as we should. I mean, a lot of discussion pretty much stops at we decarbonized, we reduced SO2, we reduced CO2. But we need to make that jump. A lot of information is getting available, and a lot of tools are being made accessible also. So, I mean, there's a lot of new technologies are in place that we can definitely use for better change and also for a better understanding. Yeah, thank you.
Thank you, Dr. Sarath, for highlighting the existing challenges and also possible solutions. I would now like to invite Dr. S.K. Goyal, who is presently Chief Scientist and Head of CSIR Zonal Center at New Delhi. Over to you, sir.
Yeah, thank you very much. Very good afternoon to everyone. First, I would like to thank the organizers, Dr. Pratima Singh especially, for inviting me and giving this opportunity to share my thoughts. My team from EDF, Swagata ji and Mr. Basu and others. Since we are talking in air pollution summit, so our focus is more on the air related aspects, but again it's a wide spectrum. And I think when we talk of the environment, it has to be dealt in totality. This is just one component, air is one component of the entire ecosystem. And this is what I feel is the need that the mission is given. A rethinking has been given to the country or to the mankind life, mission life. How do we understand, interpret, and implement in our various perspectives? From government's perspective, individual perspective, huge variability is there, but still that needs to be, at the end, that should help in whatever the envisaged climate change impacts are there to minimize those impacts. And Probably the COVID period has taught us that lesson. Yes, life is the need for this, for the entire world, not for the country, but for the entire world. So since most of the aspects of air pollution are already well known, I have no doubt the country has very good wealth of knowledge in terms of monitoring, 4,000 plus monitoring stations, monitoring, huge databases are available now. Sharad ji has very good website available, almost every city inventory is available now. How we can make use of that and convert and see that it is happening on the ground. Now here the challenge comes now. I look it from the administration point of view. At the end, what is the effectiveness of so many prescriptions? Whether the patient has recovered from this following this treatment or not. What we look forward at the end. Patient has gone to the hospital, treated with certain prescriptions, and at the end the patient should come happily out of the hospital, isn't it? At the end, have we able to reduce the air quality in the area? That area could be your local area, could be a regional area, could be a district area. Any dimension, you can give it to it. So that is why I've kept my table addressing air pollution problem tile by tile. Yet this tile could be your local area, could be your district, could be urban city. Anything that the domain where one is working. So it is open. But we have to see, like we are compromising, we are focusing only on air, but what about the other aspects? For a very simple example, I'll give you. Yesterday when I entered in my room, the temperature was 16 degrees centigrade. Even it was difficult to keep your without shoes to move on the floor. It was such a, appearing like it is something hill station, I mean at the hill station. Is it the lifestyle? In the morning, I may not be going through my presentation mostly because the things are well known. There will be repetition of that. I'll just show 1 or 2 slides, but most of the things are known. But I want to highlight the point which needs introspection. What does it mean? And how it affects us and how we can make impact on the others. So that is very important aspect. Does it really require to be kept at such a low temperature? Even you can wash your hands. The temperature was so down. First thing I did was, I made it 25 degrees centigrade to let me be comfortable with this temperature. Second thing, entire night I used 25 degrees centigrade. I switched off in the morning. I found that the temperature even at that time was 17 degrees centigrade, and it took considerable time to become 22, 23 degree room temperature at that time. It gets converted into emissions, into the problem that we are facing today. How much energy is used in that to make it to that level? We have to think in totality. We have to focus on the lifestyle changes. In the morning, Dr. Bhavarani Madam has said that what the children of our age, our children were doing, or as a children we were doing, considerable change has taken place. Why it has happened so? We are blaming the environment. Have we analyzed ourselves? Have we done the introspection? What changes have taken place? Why that situation has come? Have we thought it from the environment point of view or the nature's point of view, that what we have done and what is the stage? Nature is not responsible. We are responsible for the actions. It is the time, can we take some corrective measures or not? So my first slide would be, next. Okay. So this is a very small initiative that we said, the local area management plan. Many things, this is the starting point of our addressing the air pollution issues in the country. And just few points I wanted to highlight here. These are very important points that we need to understand at the beginning to derive the air quality action plans. Cities, number 1, cities covered NAMP. I'm starting from the last slide of Dr. Sagnik Day. And the last sentence of that, it is a good start, but long way to go. And this is the right time to at least start, initiate before it is too late. But at the same time, in order to ensure that we are on the right track, right path, what we have to understand is understand the uncertainties involved in our thought process. We are going ahead with this. Cities covered under a National Air Quality Monitoring Program. The last point is with the QA/QC aspects, calibration, which Dr. Sengupta also highlighted, and the representativeness of a air quality monitoring sites. How much area it represents? Entire city, 10 kilometer, 5 kilometer, 100 meters, isn't it? Next. Okay, next, I have to do next. So now, huge variation exists among the cities, within the cities, in different pockets, localities. And that the specific plans have to be prepared according to the situation. I think sources are well known, lot of has been discussed. Now the most important point again I would like to highlight. Even within 5 kilometer area, 3 monitoring stations are there. You'll find the highest polluted and the lowest polluted area is there, as per the air quality data. Now, what kind of approach will be applicable? Airshed approach, local approach, what kind of management strategies need to be applied? You will find this kind of picture in daily newspapers in Delhi during October, November. Then it should be focused on the local activities. The approach has to be macro level to micro level. Again, see that how it is to be integrated. Some policies would be based on the macro level, some would be on the micro level. For day-to-day, I think monitoring of the local activities is very important aspect. So we have to see the environment in totality, what is happening in the given area. What are the major sources and how these sources are to be controlled first. Tile by tile approach, I am saying. So we did chosen a very nearby area of Siri Fort CAQMS in the surrounding area, and how the air quality, different sources of localized air pollution are there. We tried to fix some fixed monitors and also mobile monitoring. Through mobile monitoring, what are the different profile in the, even within this small area of say 2 by 2 kilometer. You can see here, huge variation even within the 2 kilometer by 2 kilometer, you will find substantial variation in the PM 2.5 and NOx values. Again, depending upon the type of activity sources existing in the area. And this is the mobile monitoring fixed on the, because of the time paucity, I am cautious about the time now. Substantial variance 40 to 110 microgram per meter cube, even within 2 kilometer by 2 kilometer area. So such kind of variability exists even within such a small area. What does it mean? If our body is showing different temperature profile, even the body, then how to take care of that? So respecting the bell, I think I'll come to the last slide. Lot of challenges are there. It requires all integrated efforts. And we have to continuously work on integrating the different aspects, but focus on, let us see, can there be a scientific brand team for the city air quality improvement? For example, Bangalore, such a wonderful institutes are there. Can the scientific community or whosoever is concerned, can there be a pool of that team that is working for the betterment of the air quality of Bangalore city? They need not to go to anywhere. First, improve the quality of this city. Can they take up this challenge? Work on that mode. Here lies the key. Like I have seen, so many cities have been done very good, that very good database is available. But has it really translated the impact that is needed? I think this is what is needed in the entire country, and we need to come out with that And I'm just leaving Fit India for Atmanirbhar Bharat. And this is the need for the country for 140 crore people of the country. That industry we can blame automobile, we can blame so many things. But for whom? For 140 crore people of the country. And if we extend it to the Vasudha Kutumbakam, then it becomes 8 billion people of the world. And what is the flexibility or what is the approach that we need to follow is the fit. I am just leaving this fit, further improve T. And T is a variable. T is a technology, T is a technique, T is a tool, T is a tile. Anything, whosoever is working in any domain, just focus on T, how this T is to be further improved for making the country Atmanirbhar Bharat, adopting mission life now. And how do we integrate in our own functioning, in our own profession, in personal life as well as professional life. Thank you very much.
Thank you so much, sir, for also highlighting the need for adopting holistic approaches, and essentially all our problems related to the environment are connected, and that they have origins in anthropogenic activities, and we need to really take ownership now. Now our next speaker is Mr. Vivekanand, who is an urban mobility expert, currently working as a transport and infrastructure advisor at GIZ. Over to you, sir.
This was next slide. Hello, hi, good afternoon, Vivekanand. I'm part of GIZ, and what we've set up here is something called an Urban Mobility Living Lab. When I meet people and I tell them that I work for transport, it's still okay, but then when I say I'm working for transport in Bangalore, they look at me suspiciously, because there's much desired, but then no outcomes. So, yeah, so Bangalore's transport, I could show you pictures of how bad the congested roads are, but then this is what the current situation is. And I think I've not credited the source. So the people here in this room definitely have published this. So this is from the CSTEP study last year February, sorry. And 50%, transportation is blamed for 50% of the issue here, PM10. Even worse, 63% is from transport here, PM2.5. So there is need for a lot of work to be done in this space. So I've explained to you what the problem is. Here comes the solution. We've set up a living lab here in Bangalore. We believe that these kind of wicked problems need a lot of, a different way of solving these. These are long-term approaches. There's a lot of behavioral aspect that needs to be looked at. So a living lab methodology is what's being looked at. As a living lab, we create a platform here where any kind of innovation can be tested. It can be showcased to the city authorities, to the citizens, even at pilot scale. But then the whole idea is to scale it up and ensure that these kind of solutions are built in a consultative manner, where citizens are giving in their inputs from day one. Unlike as typical users, they receive the solution at the end once it's fully ready. No, but in this case, we involve the citizens and the community from day one. And we are focused on a lot of topics here, largely largely transportation, but then air quality is one of the primary indicators for us also. What we've gone about is set up a test bed. This particular test bed is in Malleshwaram. It's kind of the northern part of Bangalore, not too far from here. This is about 1.5 square kilometer area. We've gone ahead and instrumented this test bed with air quality sensors. So there are 10 sensors located here in this particular test bed. They're fairly close. They're not too far from each other, about max a kilometer away from each other. In this particular test bed, we also have good relationships with the residents' welfare associations. The kind of issues that they are facing with respect to transport is something that we have looked and understood. And then a lot of solutions have emerged out of that. You can see some of these topics that we are looking to cover here. So there is
one topic that I'm going to talk about today is, of course, the signal timing optimization and coordination. So I'm looking at that to tackle air quality real time. And then there are certain long-term measures also. The citizens wanted something called a loop service. There's definitely want for a better connectivity, better last mile connectivity. And so loop service is one thing that we believe that could be tried out. There is junction improvement. There are a lot of these intersections in Bangalore which are very chaotic, not too safe for the pedestrians. There's a lot of stop and go traffic also because of the movement of people. And that leads to a lot of other emissions, a lot of inconvenience to people as well. There are certain other initiatives that we've also taken up along with the stakeholders there. In this instance, it's the schools. So it's called the Safe Routes to Schools. Trying to bring in these habits of, when we used to cycle during our childhood to school. So that kind of a habit is no longer there. Parents are very worried about sending their kids even on foot or even by cycle to school. So that needs to change. A lot of initiative has to be taken in that direction. A lot of confidence has to be built. So schools need to be basically, the focal points for spreading this kind of awareness. There's a lot of experiences that people really need to exchange with each other, whether they are taking public transport to reach school or to their place of work, or whether they are using cycle or walk. Then another initiative is called Slow Streets, of course, again, from a safety point of view. But then all of this is aimed at overall looking at what the community needs in this particular area of Malleshwaram. So we work with the civic authorities there, we work with the traffic police, we work with the people there, and then we have our partners also at the Living Lab. For each of these, what's common is the technology elements that we use. There's a lot of use of technology in trying to understand the problem at the very basic level and then see how we can address it. Use of technology also helps us in baselining the before and then also showcasing the impact that is after. This is a particular corridor that we've taken up, and this particular corridor also has air quality sensors. There are 3 air quality sensors along this, wind speed, wind direction also. We have cameras, and these locations that are numbered here from up till 23, so 19 onwards till 23, there are cameras that we have installed. What we're doing, and some of these are signalized intersections. What we are doing is we are collecting a lot of this information. There's a lot of AI/ML algorithms to detect the vehicle classes, so we detect them by vehicle type. We've also tried to pull out how many electric vehicles are plying on this corridor. This is a high-density corridor, and we believe that synchronizing the signals along this particular corridor and being able to reduce the queue lengths reduces the idling of the vehicles at these intersections, and that can lead to improvement in air quality. Now, since we have the sensors deployed here, we have our partners, Bosch, as part of the Living Lab. So they will be focused on developing a heat map for the space. There's a lot of information. So I spoke to you about the fleet data. So we are calculating the number of vehicles that are passing by on that corridor at every intersection. There is also other information that is required. So they need a lot of meteorological data. We have our own wind speed and wind direction sensors at 3 locations. And then we have access to the other instruments that are deployed across Bangalore. The building topologies, again, a lot of this data is extremely difficult to get. But then you reach out to the municipal corporation, you get some kind of information, a little dated, but then you try correcting for it by understanding the land use, which is recent. And then, of course, the air quality data from our sensors to finally come up with our heat maps. This is one particular intersection, Yashwantpur Circle. And what we observed is only during the peak hours, 6 hours, that is 3 hours in the morning and 3 hours in the evening, there are about 1 lakh or 100,000 vehicles passing by. Now, this is a huge number. So we do believe, and this is a typical thing that you would have seen in Bangalore. There's a flyover, there's a signal underneath the flyover, there's a service road next to the flyover, which basically is experiencing the signal. So there's a huge queue, and then holding everybody ransom, nobody's able to get onto the flyover. It could be for an underpass also. This exact problem leads to a lot of vehicles being held up, a lot of queuing happening, a lot of emissions. But then, yeah, some of it can be managed. We can tackle it. There will be better algorithms coming if we're trying to solve it. And other kind of information that we're also extracting. These are not from Bangalore, but then yeah, basically to tell you that we look at heat maps of where pedestrians are. So a lot of algorithms are used. In that one, you see all the gray shows where the people are moving. So this basically helps us understand where the zebra crossing should be, or can we actually segregate the pedestrian movement from the vehicular movement so that the vehicular throughput is improved. Yeah. So the overall approach for us is that we've taken up this entire testbed area, we prepare a traffic simulation model, we calibrate the model with the real life observations, we calculate the emissions from the simulated trajectories, and then we move on with our improved signal phasing, and then see the improvements there. So we will see improvements because we are looking to solve this problem, and in greater detail that we start looking at it, we will be able to solve it. But then, what's actually needed is that all these are supply-side technology, supply-side interventions. What is largely needed in Bangalore is the demand side. And that's precisely where all of us come in. If we need to change our behavior, how we basically travel, I believe that a lot of you must be traveling to the airport today after this. So if you can, if I may ask you, you could probably use the registration desk, provide your details, then pull a cab to the airport. If you get stuck in congestion, don't blame Bangalore's traffic. Blame the rest of the vehicles that were caused because you chose to take one single vehicle to the airport. That's it from my side. Thank you so much.
Thank you, Mr. Vivekanand, for showing us some technology in action in managing the problem of congestion and making spaces more walkable. Now, our next speaker is Professor Abhijit Chatterjee, who's an associate professor in Bose Institute under the Department of Science and Technology, Government of India. Over to you, sir.
Hello, everyone. Good afternoon. So I'm not going to talk about any new technology or technology innovations. Rather, I would be focused on the right applications of the existing scientific concept and the technology for making some good policies and the right policies for controlling air pollution in India. So let me start with the National Clean Air Program and its gap areas. Okay, so as we all know that NCAP under this mission, so what happens there are about 131 cities across the country, and for each of the cities, what we put the samplers over 5 or 6 stations, but the problem is they may or may not represent the entire city, right? That's the issue. Secondly, we have to identify the ventilation corridor. So I will come and will discuss in detail that how the meteorology play a pivotal role in controlling air pollution, rather understanding air pollution. Okay, and we are all talking about the composite aerosols, PM 2.5 or PM 10 as a whole, but we usually forget to talk about the size segregated aerosols, which is most important for the better source apportionment and finding out the sources. Fourthly, I will talk about what are the potential markers that needs to be used for the better source apportionment studies, and there should be some kind of link or bridge between the emission inventory and the source apportionment studies, because always these two are standing alone studies and there is no connections and no links between them. And of course, fighting false solutions. So let me quick cover one by one. This is a very well-known picture to all of you. So many speakers, previous speakers have been talking on this mobile monitoring and mobile van. It's nothing but this should be equipped with some low-cost sensors for monitoring state-of-the-art pollutants like PM or oxides of nitrogen or CO or black carbon. And there will be some GPS antennas for obviously for the tracking. And the cloud servers, all the data would be, information would be stored in the cloud server. That should be web-based, that should have some web-based user interface. Data visualization that should interact with the cloud service. everything, and the decision support system that should allow to create a spatial and temporal high resolution air quality map. That's very important. So well, so these are the features for this kind of mobile monitoring for high resolutions in both the temporal and the spatial scales for different type of pollutants. So what are the outputs, what we get from there? So we get the loading of the pollutants or the pollutant scenario as the function of how they change with the change in the traffic density. That's very important. Speed of the vehicles, the types and surface of the road, and the demographical features. What kind of places are there? Is it industrial or residential or commercial? And what are the type of the emissions? Okay, so these would be the factors, independent variables over which the pollutants are depending on. So finally, we would be able to resolve some issues like would be better understand and identify the hotspots and quantify the source strength, and if there are any localized peak of the pollutants, or if there are any non-local contributions, regional or long distance, and accordingly we will take the actions. So I am giving an example. This is a very good image of such an air quality hot map, and the study was conducted a long time ago, around 5 years ago in 2017 in San Francisco, and you can see that how this air quality map is showing you the high resolution both in the temporal and the spatial scale. And the most important thing is that what we forget and we do not mention, that this kind of mobile monitoring, high resolution in both in temporal and spatial scales, what it gives us is the distant decade relationships of the pollutants. For example, you can see here that how the pollutant concentration after normalization, of course, that is varying with the spatial lag to the nearest highway. As you go interior from the high traffic conditions, how the pollutants are behaving. You can see that some of the pollutants, like for example, NO2, they do not show a sharp fall as we go away from the main traffic junctions. But some other components like BC or NO, they show a sharp fall and they follow a very gradual decrease. So the main thing is that what you are getting is the flow of the pollutants, how the pollutants are flowing from one place to another. This surface dynamics is very much important. So placing some monitors or placing some samplers, state-of-the-art samplers, reference samplers over 6 or 7 stations in a city, that may not represent the entire city scenario. Okay? And this would be facilitated if we go for the in-depth analysis of the meteorological study, because we know that meteorology is such a parameter or such a factor that actually favors the accumulations or the dispersions. Okay, so I'm skipping all these things, how meteorology plays a role in different scale, like micro scale to local to the meso scale area. But what we need to do, or what we can do, actually I have done as an independent researcher in quite a few places in Kolkata. We should build up a large network of automated weather stations across a city. But how do we do that? We can engage some local schools per world for some installation of automated weather stations, so that we can build up a large network, a large array of weather stations. And we also installed the weather stations at different heights of a building, okay, to get the potential temperature. And that will give you the idea of the mixing layer depth. Dr. Sengupta this morning rightly pointed out that we do not consider or forget to mention about the ventilation coefficient, which is extremely important for mapping an air quality or air pollutions over a city. So that is how we can in turn identify the hot spot of a city. The misconception is wherever you get the higher emissions, you consider the place as a hotspot. That's not true. You have to consider the dispersion too. It may happen that there are emissions, higher emissions, but the higher dispersions too. So these are not the hotspots. Hotspots are those places where emissions are high along with the dispersion is very low. Okay, so we have to find out that for any given city,
where is the ventilation corridor? And we have to keep a close eyes on that particular ventilation corridor so that the pollutants, whatever is generated within the city, they can flow freely. So we have to identify the ventilation corridor. And I would say that other than the local schools, some research institutions or the regional IMD centers, that could also get involved in providing these mixing layer depth or ventilation data. Well, next one is, I was talking about the size segregators. I'm giving an example for Kolkata. We all know about the winter crisis. Suddenly, the pollutants loading gets enormously high during winter when we jump from the post-monsoon to the winter. But you can see, this is for the PM 2.5 in winter and it's the monsoon, post-monsoon. And these are the size segregated concentrations of PM 2.5. So less than 100 nanometer to 1 micron, and 1 micron to 2.5 micron. So as you can see that these two regions show more or less equal contributions from winter and post-monsoon. Only these particular size fractions between 100 nanometer and 1 micrometer, this size is actually responsible, which is in turn affecting the entire composite PM 2.5. So we went for the source apportionment, and we found out that solid fuel or biomass burning and the solid waste burning, these were the major culprits for that particular high emissions of this particular size range, that actually in turn enhancing the entire PM 2.5 load. So if you want to mitigate the PM 2.5 pollution in winter over Kolkata, you have to go for this solid waste or this particular two source, rather than you are jumping for all controlling for all the sources. That will not work. Okay, so I'm skipping all these things. So these are the things that how the size segregated PM 2.5 is important. Each of the size have the different source. So you have to be focused on that. And the most important thing that we do not mention, we forget to mention, that none of the cities are conducting studies what is the air pollution scenario over the slum areas, and what is the difference between the slum areas and the non-slum areas. So these are some campaign studies that I conducted in Kolkata, and we found that a huge percentage, I mean, huge contribution of PM 2.5 of fine particulate matter over there in Kolkata, and that's because of mainly due to the solid fuel and the biomass and solid waste burning. So what we need to go for the good database generation for the slum areas, proper and robust air quality monitoring, and whether these slum areas are the sources of air pollution or they are the sink, acting as a sink of the aerosols, that we need to understand. Well, I always take part in a debate that what kind of model you should choose for source apportionment studies, because I have the evidence that the different models are giving the different amount of percentage contribution of the sources. So you have to be careful when you are choosing the right model, whether it's PCA or PMF or the chemical mass balance. Yeah, just one or two slides. And we also forget about these inclusion of these volatile organic compounds and the black carbon. These two are very important parameters for the carbonaceous aerosols loading. So what I was talking about, that these are the two pie charts, for one for emission inventory, other for source apportionment over a city in UP in the recent times. But you can see that these are now. What we will do, you will focus on which one, I mean emission inventory or the source apportionment, and what you are going to control. So there has to be some bridge through some dispersion models so that these two could be entangled. And of course, we should just forget about these things, is absolutely useless, meaningless things like anti-smog tower. So this is another topic of discussions. So government of West Bengal was thinking of installing such an anti-smog tower in Kolkata. However, as an expert member, I advised them not to do that, and they scrapped the idea. So this is a success story. There are some pros and cons of using this mist cannon, because it sometimes enhances the concentrations of gaseous sulfuric acid and nitric acid in the air through some aqueous phase oxidation. However, this could be used only in some construction and demolition sites where dust Latin region to control the dust. So finally, what I want to say is that we should go for the right applications of science and technology. And the second most important thing is the proper management of manpower. And we should not forget about the economy of our country. So we cannot go for whatever we want or spend money. So these are the three pillars by which we can build up a sustainable model for air pollution mitigations. And I think the best technology is that if we can kill the pollutants at the source. So all the technology, old and new, should be focused on that. So thank you very much. Thank you.
Thank you, Professor Abhijit. You have discussed a wide range of topics, beginning from need for high-resolution air quality mapping and moving on to the need to bridging between the top-down and bottom-up source apportionment methodologies, and then moving to taking up science-backed solutions to solving the air pollution crisis. But what also stood out for me is the need to actually look at the underprivileged sections of the society and also seeing the divide between the slum and the non-slum areas. So thank you for that. And with that, we come to an end of the presentations. Now I will open up the floor for a Q&A from the audience. I believe we have time for 2 questions. So please raise your hand, identify yourself, and the speaker that you want to address your question to. And please keep your questions.
Hello, sir.
Thank you.
Sir, and you are speaking about the ventilation corridors for the urban conditions. If you look into the present urban condition, as I was speaking in the last session also, so we have high-rise buildings on the streets, so which becomes, the streets becomes the more hotspots. And now again, the urban development authorities are bringing the flyovers into the streets as well. So that again increases the hotspot levels, right? So this means that they are not aware about these kind of scenarios when they go for the urban development.
Yeah, that was my point. I was not only talking about the ventilation coefficient, but also I was talking about to identify the ventilation corridor. There may be 1 or maybe 2 or whatever. So you have to identify the ventilation corridor and you have to keep the close eyes and continuously monitor if something not happening along that corridor. That should be free of flow. Whatever the pollutants you are generating within a city, interior of the city, that should freely flow to that particular, along that particular corridor. So you have to identify the ventilation corridor. If there is none, then nothing to do, but you have to start, you have to think in this mind that the ventilation or the dispersion aspect of the air pollution. Thank you.
Hello. So I have a question for Professor Chatterjee. So as I discussed, I have that, we developed that exposure data set. So what I've seen, like out of, we calculated the top 10 most polluted cities in terms of NO2. So what I've seen, like out of 10, 4 are in West Bengal. So as you have like worked closely in West Bengal. So I was just thinking the explanation for that, like how is it? So these 4 cities are Kolkata, Durgapur, Asansol, and Howrah. So I was just thinking like out of 10, 4 are in West Bengal. So if you have any comments for that.
Yeah, thanks for raising the issue. But I can't comment on other state or other cities. But as far as West Bengal is concerned, I know that the major issue is that the 15 years old vehicle, okay, that is, those are still plying on the road. And unauthorized or illegal, accumulations of the brick kilns. So, and brick kilns is such an industry, as you know, that these are very hard to control. You do not have access to go over there and to go for any kind of regular monitoring. So I think these 2 are the main reasons for high emissions of NO2 as of now. Mostly these old vehicles, I think so.
Thank you so much.
Okay, so with that, I think now we will close this session. I thank all the speakers for sharing their ideas and their work with us and for being here today. Thank you.
Thank you to all the speakers, and thank you, Amishi. I request Pratyush to give token of appreciation to all the speakers and Amishi. Moving to the next session, we have another presentation session by ICAS on current understanding of air quality measurement and control approaches. This session will be highlighting existing issue in air quality measurement methodologies and harmonization of air quality measurements performed by different techniques. For the session, I would like to invite on stage Session Chair Ms. Sobia Rafiq, Co-founder Sensing Local, and a panelist, Professor Sachin Gunte, Professor at IIT Madras, Dr. Manish Joshi, Scientist at BARC, Professor Shubha Verma, Professor at IIT Kharagpur, and Dr. B. Padma Kumari, Senior Scientist, IITM Pune. The session chair, Sobia Rafiq, is an urban development professional with over 10 years of working in the environmental and planning space. She co-founded Sensing Local in 2016, a Bangalore-based urban living lab that applies an evidence-based system approach to urban planning through participatory planning and design. Over to you, Sobia.
Good afternoon, everyone. Everyone's post-lunch sessions, of course, they're always slow to go, but this is a very exciting session looking at the understanding of air quality measurement and control in different approaches by ISTA. I'd like to welcome the panelists and the speakers, and we'll start off, so the way we'll do it is we'll do the introduction of each of the speakers, and we'll keep the Q&A towards the end, so keeping it as 10 minutes for that and 10 minutes for the presentations. So I'd like to welcome Dr. Sachin Gunte. Dr. Sachin Gunte is a professor and former head of Max Planck Partner Group on bioaerosol research at IIT Madras. He's involved in teaching diverse courses in the field of environment, engineering, and earth system sciences and climate change at undergraduate and graduate levels. His research mainly focuses on aerosol biosphere climate interaction with special emphasis on impact of biological aerosols on climate and human health. Cloud condensation, nuclei properties of atmospheric aerosols, and impact on cloud formation and precipitation in the context of the Indian summer monsoon. Welcome.
Thank you. I did not cut her giving this introduction because very seldom I hear it nowadays. So I thought that I'll let it continue to hear that. So I just wait for my slides, and then thank you for the organizers for having me here, and special thanks for changing my schedule at least 5 times, and then a big round of applause from myself because I changed my schedule at least 5 times before I coming here, and then also not keeping me immediately after the lunch because it's very difficult to keep you awake with this presentation. What I'm going to do is that going to spend maybe next 3 minutes or next 10 minutes or so. I'm a fundamental scientist, so what I'm going to do is that how I'm going to use how I've used this technology to bring out the good science, which probably the policymakers have left somewhere in between, and try to see how we basically do that, right? I'll just dedicate this slide in a minute to Professor Paul Crutzen, who came up with this term called Anthropocene, which primarily means that the earth nowadays is no more governed by the natural activities, but we as a human have perturbed it a lot, and then we are shaping it, and then probably if we are going to shape it, let's try to shape it in a better way so that the future generation will probably thank us for it. We'll not go into this, but then unlike the gas molecules, we have the problem with the aerosol, because here we have to deal with the 5 order of magnitude size range at the first place. This is what Abhijit just mentioned it, and then you have a very problematic composition in between. And then when you talk about their sources, you have primary, and then you have secondary, and then you have transformation and aging, cloud processing. They are removed by dry deposition, wet deposition. And then the most importantly, they also have an impact on atmosphere and climate, and then also on the human health. As my title suggested, what I'm going to do is that I'm going to try to bridge this gap, that what is that more important has to be given as far as aerosols are concerned, whether it is the climate or whether it is the air pollution. Now, I basically work on the climate thing, and then this is a figure which is very familiar to all of us. These are the constituents which basically warm the Earth's surface, and what IPCC says is that the confidence level that they are warming the Earth's surface is very high, so I don't really care about it, and then it is very evident from the error bar, which is associated with the estimate itself is very small. But the moment I come to the aerosol cloud interaction, they say that the confidence is medium or even low, and then the estimate itself is even bigger, the error bar itself is bigger than the estimate. So what it does is that when you are talking about the net radiative forcing, the aerosol cloud interaction represents the largest uncertainty in the current and future understanding of the climate change. So how do I do that? Well, I mean, this is the good thing about the climate science, that it is very multidisciplinary. My group alone or my department or my institute alone cannot really do it. So what you basically do is that you really do the laboratory experiments, field measurement campaigns, representative laboratory experiments, then particularly with the Indian context, do it in the contrasting location, upscale it to the different model, process model, regional model, and then eventually get into the global climate model so that you can reduce the uncertainty. Now, there are two ways of doing into it. Is that one is that you sit behind the computers, get the terabytes of data and keep it churning. And that's what we as a group doesn't excite us. So what we do is that take the bunch of the instruments, load them in the truck, and then go on to various places to do the measurements. And this is not possible without the group which you are saying it. There are many thanks to this group at the Center for Atmospheric and Climate Sciences at IIT Madras. So when we talk about the aerosol properties, particularly related with the climate change or pollution, there are two important things, that the physical properties and chemical properties. Biological properties are not really important, but more for the health. So I'm skipping up today, but anybody is interested, there is this girl called Emil Verghese. She works on that, and try to talk to her if you need more information. What I'm going to do is that I'm going to present the two case studies about a very interesting example of the climate and air pollution related with the aerosols, and then how it really implicates or indicates us that how do we need to have the science-backed policy. So this is the study which we published in 2021. What you see here is that we have done this very specific measurement, which everybody had shown this graph about how much is organics, how much is sulfate, and how much is nitrate, and so on and so forth. What we interestingly found is that Delhi is very unique, that you get a very high concentration of chloride. Now we put an hypothesis saying that this chloride probably comes from the plastic burning, and then it was not sufficient. So what we did, since we already had only one instrument, we did these measurements sometimes in February 2018, but waited for around 11 months and then brought that back instrument to Chennai, because we know that during the Bhogi festival, there is this ritual that you burn the waste which is there. So we operated the same instrument in Chennai in January 2019, and what we found is that during rest of the time except Bhogi, the site is like any global site, but on the day of Bhogi, it was more like a Delhi, meaning that the very high chloride concentration. Now, of course, as you know that everybody talks about like, kam ho jata hai, flight delay ho jata hai, ye hota hai. But what is the fundamental science basically comes out of it is what our paper tried to kind of pull it into it. So let's try to have a global picture, that these are the very classic slide from the Giant et al. 2007. Everywhere you see that the organic dominates and a very little chloride. But the moment you come to Delhi, that you find around like 10% of chloride. Now, where does this chloride come from? What we hypothesized, obviously, that you have the metal pickling industries in Delhi, like, so they use the HCl for the prickling. And then the most important thing, that this plastic burning releases a lot of HCl in the atmosphere. and then the Indo-Gangetic plain being the very fertile, you obviously have an excess ammonia there. It combines and then gives you the aerosol bug as an ammonium chloride. Now the problem with the ammonium chloride, what happens is that it has an extremely high water uptake capability, meaning that as compared to any other aerosol, that if you have the ammonium chloride in the atmosphere, the water uptake capability is almost 10 times more than any other hygroscopic aerosol which you would see. So you can see that, like, this is the aerosol liquid water content and aqueous gas phase chloride. The moment your liquid water content really goes up, you see that it is exponentially increasing with the almost geometric increase in the chloride concentration. I just changed this in the meanwhile when Dr. Sengupta was talking about the power plant emissions today. So what we did is that everybody saw that during the COVID, like the pollution decreased, Himalaya dikh raha tha, sab kuch ho gaya tha. So there were at least 300 papers trying about reduction in pollution during COVID. But we used that opportunity to kind of find out something very interesting. What we found is that this is a very clear picture that this is during the lockdown, and this is during non-lockdown, and then you see the difference in the AOD, which everybody knows. But what we interestingly noticed is that when you had this dark black line is the black carbon, this is the mass from the SMPS conversion, this is from ACSM, and this is from the US Embassy. What we saw on 1st of May, that there is a huge increase in the PM 2.5 mass concentration. Now where does it come from? Because if you have a lockdown. Now what happened particularly on that day essentially is that you have a power plant which is located here at the Neyveli power plant, which was of course operational even it was a lockdown, because your vehicular traffic and the industry, they were almost at maybe lowest possible ever, at least I would say in my lifetime. And then what we saw essentially is that on that particular day, we saw that the new particle formation event where you saw like a typical banana shape. But interestingly, what we found is that it was generally not observed that when you have a new particle formation, you have almost like 52% of the sulfate, which was not really unheard, which was really unheard of. We digged into it, and then what we basically found is that this Neyveli power plant, which emits the SO2 due to the further oxidation, the H2SO4 is there, and then during the normal circumstances, when you already have these aerosol particles from the traffic and industries, it basically condenses on that. But when you don't have this surface area for this H2SO4 to condense, they go on to kind of form their own particle, and that creates the problem. And then just to kind of quickly mention into that, so what happens is because of that, the policies regarding the reducing the PM 2.5 mass burden needs rethinking. Because if I go on to aggressively reduce the PM 2.5 concentration in Chennai, saying that from industry and traffic, it could be very counterproductive as far as this particular graph is concerned. So that's what I say is that one need to have a very strong science-backed policies as far as the reduction in PM 2.5 concentration is concerned. Well, just to summarize this, I will leave it with this slide. But just, I think today afternoon somebody was talking about that we need to reduce the greenhouse gases or NOx. But that's really a bad idea, because when you want to reduce the greenhouse gases or the NOx without reducing or without kind of like, giving an attention to PM 2.5, it's going to be bad. Because if you really aggressively control the PM 2.5 or the aerosol emissions, please understand and not to forget that the PM 2.5 or the aerosol emissions are the one which are negating the greenhouse effect. Now, if you try to control the aerosol concentration very aggressively and say that I go on to increase and then I don't really control my greenhouse gases, that's not going to be good. However, having said that, the aerosol emissions do have a very large implication for the health aspect, obviously, particularly for a country like India. So having said this, we need to probably strike this balance, and that's the reason policymakers always needs to understand a very basic science, which is kind of needs to be considered as far as the aerosol emissions or the air pollution due to the PM 2.5 and climate change is concerned. With this, I would like to thank you for your attention.
Thank you, Professor Gante. Next, I'd like to invite Dr. Manish Joshi. Dr. Manish Joshi works as an aerosol scientist at Radiological Physics and Advisory Division of Bhabha Atomic Center. He is Secretary of Indian Aerosol Science and Technology Association at present. He has expertise in aerosol instrumentation, aerosol characterization, and aerosol CFD integration. His work on quick laboratory methodologies for testing face masks and usage of alternative materials as filters has helped develop low-cost N95 masks during the corona pandemic.
Thank you, Sophia. First of all, I thank CSTEP to hold this important event and to invite, to give me an opportunity to present some of my work related to this theme. We are already discussing this air quality management, which is having several components and, sorry. Okay, so each of these components has its own framework which requires different scientific solutions. I will be presenting a small part of this control approach where different technologies are used, and I will be specifically talking about some of the technologies, some of the limitations which require immediate solution, and some of the future direction in the same direction. We all know that there are different technologies to mitigate aerosols in indoor and outdoor air. Each source or each method has its own disadvantages and advantages. And exactly as we know that a single instrument of aerosol cannot measure the aerosol characteristics in its entire size range, similar that a single aerosol purifier or single technology cannot be used to mitigate all sources. So what I mean that hybrid aerosol purifier technology may be the need of the future. Now coming to the first case study which I am highlighting here is, we are doing some research in the direction of developing or strengthening the ionic purifiers which we call as ionizers. So there are two problems which are associated with the conventional ionizers which are available in the market. One specifically is the production of ozone, and the other is its small range. So both of these we tried to investigate what are the reasons. We all know that ozone is generated due to this energy imparted to the oxygen molecule which breaks it and forms oxygen radical, which then attaches to the oxygen molecule and forms ozone. However, because there is an electric field attached to the needle of the ionizer, we just reverse the polarity, and in that case oxygen molecules are attracted to the needles and nitrogen molecules are then used for, or the positive ion which are formed from ionizer needles are attached to the nitrogen molecule, then they charge aerosols, and in that case ozone is considerably reduced. So we made our own bipolar ionizer which is having a fan as well to increase its range. So it is having high ion generation rate. Its efficiency is similar for both negative and positive mode, and it is similar to commercial purifiers as well. In the second direction, what we did is we performed some new studies with ionizers where we measured not aerosol effectiveness or aerosol efficiency, but we measured the aerosol current, which is basically how much current is generated in the aerosol form, and ion generation rate with ion concentration meters. So what we observed that these parameters can be tuned. It depends on the room environment as well, and you can tune it as per the requirement, and then considerably you can increase the effectiveness of the ionizer. Both these things are important because even you say that ionizers cannot be used as the equivalent to HEPA filters, but they can be definitely used as the stages for the pre-filter stage of many aerosol purifiers. And for many applications I know where ionizer usage is definitely more economical than using a full-fledged ventilation system. Coming to the another technology where IIT Bombay and BARC is working is the generation or the development of the aerosol purifier on the basis of electro-hydrodynamic atomization. This EHDA is something which is used to generate highly charged aerosol droplet, which you are seeing here in the downward picture. So our group in collaboration with IIT Bombay is working to develop this EHDA based air purifier, which is similar to electrostatic precipitator but having a very high considerable efficiency, which you can see on the graph which is shown on the right hand side, which is I requested from Dr. Rochis Thavkar group at IIT Bombay. Very encouraging results are seen, and we are hopeful that this can be again used as a pre-filter stage or a separate air purifier in future. Now Abhijit has just blasted this slide, but I thought that because unless we go to emission inventory, we have this outdoor air purifier already installed at Delhi. So I will just provide you some inputs related to this. Again, this slide I obtained from IIT Bombay group. So this, there are 2 units which are installed at Delhi at Anand Vihar and Connaught Place, and the design performance at 100% fan capacity and 85 to 95% filtration efficiency is tuned to generate clean air up to the distance of 500 meter. And the clean air delivery rate is very, very high, 860 meter cube per second, you can see here. And some of the results which I have already seen on the basis of their measurement is showing very encouraging results as of now. And I believe that unless we talk about or unless we control the emission inventory, this unit or these kind of units may be required, at least for some of the cities where emission cannot be controlled in very near future. Now coming to some of the applications which we routinely did in our day-to-day applications as well, and which we studied during Corona operation. One of the study which we performed in our group is using this CFD to visualize the propagation of aerosols during the Corona times. So you can see in the above graph, not only the air exchange rate, but the air profile. How this air is moving in the room defines that how the aerosols will be propagated from the emitter to the responder. So as can clearly be seen that if the inflow and outflow is different, then the aerosols with the same ejection rate may not be reaching to the receiver. Similar kind of application we used for a facility and deciding where the monitor should be placed in that facility, and the red bar graph shows that the placement parameter which defines that where it should be placed depends on the location of that monitor as well. So similar kind of applications will be definitely required for the future of optimization of the space or optimization of the location for the air purifier. So not only just the position or just you are buying an air purifier, and if you are keeping it in a room having a particular ventilation rate, so in future the location optimization studies will hold a key as well. Now coming to the same one more study which we performed during Corona is related to the face mask assessment, and that time it was just done just after 5 days of the lockdown. So we went to our lab and we devised some of the quick methodologies which can be used to assess the filtration efficiency of filters and masks. And during that time we made an interesting study. We just picked some of the masks from the market, and those masks were picked on the basis of their popularity. And I am just showing a table which was not published, but here it is not as per the defined testing criteria, but the results have been definitely validated with respect to the setup which is validated as per the testing criteria. So you can see that if we are talking about the standard brands, even if we are buying this was the old study, so if we are buying those face masks which are claiming the efficiency about 0.3 micrometer in the range of greater than 80, which is called as N90 and 80 mask, and greater than 95, which is N95, many times this mask which are bought from some sites or market may be giving you the wrong information. Particularly to the C, you are seeing that the efficiency was obtained at approximately 80%. Interestingly, for the mask which were not from the foreign brands, which we are mostly some of the brands which we have just picked up in that Corona times, only one mask out of the 7-8 masks could be qualified as per the tested, or they all were claiming that their efficiency is greater than 95%. However, only one mask was having the efficiency greater than 95%. You must be knowing that, or in fact, it is a matter to know that generally there was a trick where they were just saying that their mask is KN95, CN95 or some other word as 95. Just they were testing it at some other particle size. They were obtaining the efficiency of mask at 95% for that particular size, and then they were misleadingly quoting the same testing efficiency at 0.3 micrometer, which was definitely wrong. Same will be happening to the aerosol purifier, which will be either available in the market or which will be coming into the market. So we should be very, very careful, aerosol labs and the organizations, what they are specifying, what is their testing criteria, and what aerosol labs should do to then bridge the gap between these industry and public. So ISTA, as a secretary of ISTA is conducting several events, and I am just want to inform you that we are also initiating some activity. Many people, many esteemed speakers highlighted that we need a platform to educate school children, to educate public about these air quality and aerosol issues. So we will be very soon launching a program which will be called as Learn with ISTA, And we also hope that we will be serving as a platform to educate public and highlight the issues which I already marked in my slides. And finally, I hope that we will again be meeting during this Indian ICAS National Conference 2023 in Mumbai, where we will be discussing the progress which we made from this summit to that conference. So this is my team, and I thank CSTEP again, I thank ICAS, I thank my team members, and I hope that you will come to ICAS conference as well. Thank you very much.
Thank you, Dr. Manish Joshi. Next up, we have Professor Shubha Verma. Professor Shubha Verma is a faculty in the Environment, Engineering and Management section of Civil Engineering Department at the IIT Kharagpur from 2007 onwards. The primary focus of her research work is on aerosol chemistry, transport modeling and simulations to examine the issues related to aerosol, air pollution, climate health interactions. Professor Shubha holds membership of advisory and evaluation boards of various government bodies on issues of environment management. She is the Institute of Repute to provide technical partnership and assistance for the National Clean Air Program by the MOEFCC to tackle air pollution across the country. Professor Shubha also has significant international recognition for her credit, including multiple research fellowship awards from the Embassy of France, Kavli Fellow, National Academy of Sciences, and START Fellowship, to name a few.
So good afternoon, everyone. So I have kept the topic of my talk as prioritizing clean air over India, strategic air quality and atmospheric pollutants assessment and control for sustainable development, based upon the session area what was assigned to me. So how does it go?
What do you want?
Okay, fine. Yes, okay, sorry. Okay, so overview of my talk will consist of presenting the newly developed one tool called as PCAT, which is Prioritized Clean Air Assessment Tool at IIT Kharagpur, describing the ongoing air quality assessment and my viewpoints over it, answering if the combustion-derived particulate matter in comparison to bulk PM mass or undifferentiated PM mass better helps the policymakers towards sustainable mitigation of emissions and providing the health benefits. Discussing the strategic control plans from the perspective of, I call also emission shed mapping and also the air shed approaches. Okay, so as we all know that the National Air Quality Index is based upon the maximum operator function, which is, we know that we calculate the maximum value of the sub-index, and based on this we define the air quality index. It is one of the very simplistic tools, and it is very easy to communicate to the mass, and so it is, in terms of mass sensitization, it is one of the very useful tools. However, recently, from the perspective of developing our tool, we characterized, or we started to analyze the air quality parameters over 24 chosen stations across India, from the locations were chosen from perspective of urban or city or the rural locations. They were all combined, and we found that among all the locations, the PM2.5 and PM10, they are mostly above the prescribed permissible limits, whereas none of the locations show the SO2 or the NO2 which are reaching the permissible limits. So what does this tell about? So in this case, taking into account that the NAQI doesn't take into account the effects of the other criteria pollutants, and it is mainly based upon the undifferentiated PM mass which governs the air quality index. Taking into account this research gap, we developed the prioritized clean air assessment tool, which is actually based upon the fuzzy-based algorithm, takes into account the cumulative effect of all the criteria pollutants and taking into account the health implications of each of these pollutants. And this tool was applied to assess again all the 24 locations which were used in the study, and then based on this tool, so I think the tool is also in the animation form, but it is not displayed. Maybe you can see later on with me if required. So with this tool, we identified that out of the selected stations, we had the 7 prioritized locations which needed the prioritized cleaning of the air for improving the air quality for health benefits. Okay, yes. So this tool is identifying the prioritized locations for cleaning the air and improving the air quality. It is user-friendly and it overcomes the complexity of calculations while implementing the fuzzy algorithm. It includes the cumulative effect of all the pollutants, incorporating their health effects. It is easy to handle and it gives a quick assessment of multiple locations, whatever you give in the tool. So based on this tool, we found that we could come out with the prioritized locations, for example, the Delhi and the Varanasi among all the chosen stations, which were showing above the, which were showing a high value of air quality index. We prioritized that Delhi and Varanasi are the ones we need the prioritized cleaning actions, and then using the National Ambient Air Quality Standards, and then we also applied the WHO standards, and we came with specific cities which need the prioritized cleaning actions. So going forward, when we also use the available information with the CPCB and where they had analyzed the 371 locations, we found that because it is taken from their analysis itself, we found that more than 70% of the entire analysis they present is all based upon the PM mass only. And none of the cities showed, and all the cities had low values of SO2 or NO2 concentration. Hence, what do we get from there? The NAQI values over the locations are driven by the undifferentiated PM mass concentration rather than other criteria pollutants, which are also having a lot of health impact or health implications. So is the ongoing method of calculating AQI be modified, accounting for the cumulative effect of all pollutants, unlike based on the maximum subindex, which is mostly governed by the PM10? Then, further taking strength of the aerosol species modeling, which is the main task which my group is involved in. So when we see the aerosol species modeling, yes, indeed, the model results show that the PM concentration to be higher than the permissible limits over India. But what is the PM composed of? We see that both the natural, the wind-blown dust and the combustion-derived components, they are prevalent over India, with the wind-blown dust which is widespread and which is particularly contributing to a large fraction of the PM concentration. So in that perspective, do we need to look for the defined National Air Quality Index? Further, we had the learnings. Did we learn what happened during the pandemic lockdown? So with the pandemic lockdown, again, we had the simulations done with the usual scenario and also with the lockdown scenario, and indeed we could see that there was a reduction of 25 to 30% of the PM during the lockdown scenario. So this itself answers that what strategies we have to apply there. So in that case, should the air quality parameters used for describing AQI be revised? Is AQI able to guide us in taking adequate regulatory measures? Means what to control and how to control? Can a better control be planned through assessing targeted combustion-derived PM components? Yes, we can look for the PM, but can we focus on specifically combustion-derived PM components to decide on the strategic regional-based control plan and the sources? So with that perspective, one of the representative of this combustion-derived PM is the black carbon aerosols over India, and this represents the modeled BC distribution over the Indian region, and this is again from model and with the well-validated model distribution, which showed that the population exposure, when we have more than 85% of the population over the IGP, they are exposed to BC concentration which is above the prescribed theoretical threshold limit in the work. Then we had study done for the different area types, including rural or the semi-urban or the megacities, which further described that how even the rural population, we had 43% of the population which are exposed to the BC concentration, which is above the TTL or the theoretical described limit. And then we had done the health impact functions due to BC, which indicated, and the relative risk factor due to BC is particularly large over the entire IGP, and when it was compared to the PM 2.5, we see that it is many folds higher than the PM 2.5. Moreover, the PM 2.5 was not, we could not see the PM 2.5 was not able to segregate specifically the locations which need the strategic control. Why? Because the PM 2.5 is also having a lot of the dust in it. So and then when we studied the health functions, it was mainly because of the cardiovascular disease and mortality in the present study. We found that it was many times higher for the BC than that of the PM 2.5. Then coming back to the sources of the combustion-derived PM, we found that particularly while the residential biofuel combustion dominates as the main source of BC over the entire IGP. However, the megacities had a different source. There we had mainly the fossil fuel emissions, which were highly contributing to the black carbon aerosols. And then we had to decide on the sources which should be mitigated specifically and which was studied in this work. So further, from the climate perspectives also, the regional controls are required because this graph shows the radiative forcing because of dust and the anthropogenic aerosols, which shows very distinct features over the Indian region. And hence, this is based upon my thought that should be based upon both the emission shed mapping and the air shed mapping. So can you please click on the movie there? So this is based upon the city-based mapping where I am tackling the pollution level with Haldia. So you can see that how the pollutants, hotspots change within the city. So can this guide us towards applying the control measures? So the municipality there with whom I interact, they play a role on tackling the control of the pollutants going to the specific locations. Further, again, when we look at the BC emissions over entire India, we see the regional and the seasonal variation. Maybe I can skip this slide. Yes, I will skip. Okay, so now coming to the airshed, can I give one last slide? So the airshed mapping, so this is, please click on the first slide, please. This will tell you how the inter-regional transport takes place and helps us to decide the airshed mapping thing. The first one, yeah. Okay. So this, because as we know, emissions doesn't tell about, they can help us in source-based mitigation approach, whereas airshed will be helpful to apply or discuss among the locations that from where the pollution of a particular location is coming. This particular movie helped to solve or helped to identify particularly the Bihar pollution pool. Maybe I can explain later on how the pollutants were getting pooled over Bihar because of the combined meteorology, the transport, and the topographical features, which was recently presented at Bihar Pollution Control Board. With that, I leave open the questions. Thank you very much.
Thank you, Professor Verma, for that extremely graphic and engaging presentation. I'd like to welcome Dr. B. Padma Kumari, which is our last presentation. Senior Scientist and Project Director at Indian Institute of Tropical Meteorology, Ministry of Earth Sciences, Pune. And Dr. Padma has participated in several field campaigns. Her research works on observational evidence of solar dimming in India received global publicity. She also led several research studies on aerosol vertical and spatial distributions, effect of polluted layers on cloud processes, variability in cloud microphysical properties, and so on. She's received the IITM Silver Jubilee Award for the Best Research Paper and Best Poster Awards Gold Medal.
Thank you, Sophia. A very good afternoon to all, and I thank the organizers for all the arrangements. So I'll just quickly recap, like air pollution, which is everywhere and all around us, and now we started living with air pollution. And as we all know, air quality refers to the standard to which the air is suitable or clean enough for humans or the environment. And air quality is a worrying reality of present and future generations. That is why we gathered here today. And air pollution, and coming to climate, air pollution and climate change are well connected. And if it continues in the same scenario, then it is going to lead a critical health as well as environmental issues in the coming decades. And I see there are many students here. I'll just say there are various types of aerosols sources, and they can be classified as mobile sources, stationary, and we can see in the picture, and aerial sources and natural sources. And here, if you see, as compared to the natural sources, the emissions from the man-made activities or the anthropogenic emissions are more eminent, and they're going on increasing. That is a major concern. And it is also important to note that these emissions that are, the pollutants which are emitted at the surface are being transported horizontally as well as vertically. And here, it is not a problem related to a single country or so. So across the globe, air quality continues to deteriorate due to increasing emissions, threatening human health and contributing to climate change and biodiversity loss. And it is also known that these numbers and statistics are well known regarding the pollution deaths due to premature deaths due to air pollution and all. And fine particulate matter, that is PM 2.5, poses the greatest health threat and is often used as a metric in air quality standards. And to address this air pollution crisis, it is necessary to strengthen air quality regulation, including monitoring capacity to track their trends. And I would like to highlight this point, like air quality monitoring with innovative technology and access to data is critical, as it helps to understand, identify the hotspots and take targeted action to protect and improve the human and environment, and which will help us to plan towards the control approaches. And of course, weather, which has a major influence on the dispersal and ambient concentrations of air pollutants, and there's a lot to talk about weather and its. And now, I just want to give a glimpse of IITM under Ministry of Earth Sciences, the efforts towards atmospheric observations. Like here we have high altitude cloud physics laboratories is situated in the Western Ghats to understand the impact of aerosols or pollutants on the orographic precipitation. And we also have a winter fog campaign called WIFEX being conducted at IGI Airport, New Delhi from 2015 onwards. This campaign focuses on the impact of pollution on fog evolution and thereby for fog forecasting models. And we also do a lot of field campaigns using instrumented research aircrafts, instrumented with aerosol as well as cloud instrumentation. And these efforts were made to understand impact of aerosols or pollutants on monsoon clouds and thereby the rainfall processes. And another recent, our ministry is coming up with the atmospheric research test bed, which is being established at central India, which is at a remote location close to Bhopal, in 100 acres of land. Over 100 acres of land, and for continuous long-term observations to undertake various process studies and model developments, and also to validate the models. And this test bed is going to evolve as a national facility, and we invite many students, universities, institutions, and other organizations to for using the data sets and also for calibration and intercomparisons. And this facility will be equipped with very sophisticated and state-of-art instrumentation starting from aerosols, aerosol speciation, greenhouse gases, chemistry, clouds, precipitation with all microwave radiometers, ceilometers, and also a 72-meter tower is being set up at this site, and a C-band radar also. And then, I just want to touch upon the networks that are under IMD, under environmental monitoring and service, and they have a lot of networks for like aerosol monitoring, precipitation and particulate matter chemistry, aerosol monitoring and black carbon monitoring, and system for air quality forecast and research called SUFFER, and also AWS centers and for surface meteorology. And they're also rigorously expanding their networks across the country. And under ISRO, there is also another network called ARFINET, that is a network of aerosol observations for aerosol radiative forcing in India. And they also are expanding their network. I think right now they have nearly 41 centers for aerosol as well as for black carbon measurements. And of course, the Central Pollution Control Board, and then which also has a big network. And then we have an AeroNet for aerosol physical and optical properties. And I think there are many more networks or many more observatories being maintained by individuals or organizations or universities. And what I want to stress here is about the existing networks, there is some lack of awareness. So we need to, bring this into a common platform where we can have more research collaborators and which can help in the growth of technology. And then some examples, just to say, during COVID lockdown periods, like there were many studies from using surface as well as satellite measurements, reporting reductions in air pollutants due to restricted, especially due to transport mobility and industrial activity. And these are some examples in terms of PM 2.5 during lockdown and as compared to the last year's this thing. And also another very good example is in terms of black carbon observations using that ARFINET this thing. So we can clearly see here that before lockdown period, the concentrations, and during the phase 1, phase 2, and during lockdown 1, and during lockdown 1, 2, 3, and so on, we can see a systematic reduction in black carbon concentrations. And in terms of percentage, there is nearly 30 to 50% reduction in this reduction in the black carbon emission. And also, of course, various satellites images, they showed many cities throughout the globe witnessed a significant drop in the particulate matter owing to countrywide lockdowns. And this is one very good example which shows before and during the lockdown period. And this, of course, it is like unplanned air quality experiment, which had enlightened us and realized about the existing pollution concentrations. And the lockdown period provided a unique opportunity to study the ambient environment and assess the effects of the reduction of various emission sources to evaluate introduction of quality standards and regulatory policies. And this is another example regarding annual variability in aerosol optical depths from surface observations. And here we could see the trends, long-term trends in aerosol optical depths. And what I want to highlight here is the routine observations are very useful in assessing the trends and their variability. So these, in the absence of these observations, we will not know where we are today. So maintaining the networks for long-term observations is very much essential. And these increasing aerosol trends, of course, lead to solar dimming and other effects. And another example I would like to bring here is the fine mode aerosols and the spatial distribution using airborne observations. And here we could see that with our aircraft, we flew from Pune towards the South Mumbai and along the west coast. We could see this flume, when we flew through a Mumbai pollution flume, very high concentrations picked up, crossing around 3,000 particles per cc. And here another point which I would like to bring to your notice is not only the surface concentrations, but these concentrations have been observed up to the boundary layer, which we could see them, which we could see the higher concentrations at higher levels also. And this is high aerosol concentrations in the atmospheric boundary layer, where we could see during pre-monsoon high concentrations at the in the boundary layer, as well as at high concentrations are observed even above the boundary layer, and which are called as elevated pollution layers. And surprisingly, we could also see high concentrations during monsoon. And here, if you see, this is pointer, right? Yes. This is pointer.
Pointer, it just works as more of like you just point it and then do like this.
Actually, I have to press it. Yeah, here during monsoon also we see high concentrations extending from the surface to up to a boundary layer. And here one good example, this aircraft experiment was conducted at Bareilly during August peak monsoon time. And here we could see that during, we have high concentrations crossing about 1,000 particles per cc, and immediately on one day, the concentration have fallen below 1,000 particles per cc, and this is due to reversal in wind direction. And here another example to show that here, this is from, this is from Moody's fire counts, and this is from Calypso, which shows the very high concentrations in terms of extinction coefficient. And here we had an aircraft campaign, and we could see very high elevated concentrations here. And what happens if the clouds form above these elevated pollution layers? So there it's a very good example to understand aerosol cloud interactions. And since our aircraft is also equipped with cloud instrumentation, so we could see the drop size spectra, aerosol concentration, increase in aerosol concentration, and of course reduction in the size and drop size distribution. And in brief, to say that when the clouds are formed over a pristine environment, the clouds grow quickly and it precipitates within a few minutes. Whereas when the clouds form over a polluted environment, so the number concentration increases, but the drop size decreases. That means they will not reach the thresholds to rain out. Hence, this will fall under non-precipitating cloud. So this is to bring out that the impact of this pollution that indirectly influences the hydrological cycle, which is very important for us. And then air quality measurements have, of course, advanced significantly, enabling a comprehensive grasp of air pollution. And satellite data also contribute to global air quality assessment. And it is observed from 2000 onwards, algorithms and new applications have become more popular. And then what we need now is real-time monitoring networks and having improved sensor technology with high frequency data and well-calibrated and well intercompared measurements are necessary at this stage, and the source apportionment, of course, and the air quality modeling forecasts for pollution dispersion. And any models, they need a lot of data for a precise forecast. And health impact assessments combined with air quality data with health studies, aiding in setting respective standards. And for an effective air quality control approaches, I feel we need a lot of collaborations and knowledge exchange and knowledge sharing. And we have got expertise across the country, from laboratories to field campaigns to policymakers to public. Everybody should come together, and we should have a strong collaborations. And then by working together and sharing data and insights, we can develop evidence-based policies and strategies to improve air quality and protect public health and the environment. And of course, engaging communities in all stages of air quality management may work out. Thank you.
Thank you, Dr. Padma Kumari. I'll open the floor to 2 questions. Please introduce yourself and keep the questions short, and who you're directing the questions towards. looks like everybody's clear on what's there. But I would definitely like to take this opportunity to say that we are urban planners. We always look for leads where data is there, where it can lead to solutions, and especially hyperlocal solutions. And I think that really resonated with me across all the presentations, that how can you firstly increase the amount of data that reads the Indian context and gives you the diversity in terms of even causality of these issues, and then leading to these hyperlocal solutions, whether it is ward level or trying to move into looking at various solutions within the city and this one size fits all, which actually is not working. And we realize that every day as urban planners in this space. So thank you so much, and lovely presentations. Oh, great.
Sorry.
Yes.
Sorry. So just one comment. I was really fascinated by all of your talks, and I was thinking, Professor Verma, is it possible for the type of data that Professor Gunte collects with the ACSM to be used to validate your calculations of aerosol chemistry?
Regarding the, may I just get some clearness? Like, you want to know the validation of?
Would it be possible to put your talks together?
Yeah, well, I mean,
you have aerosol chemistry modeling.
Yes, so whatever modeling work I presented, that is all validated. In like the validation part was could not present those. So modeling work needs strong validation with respect to the measurements, and whatever I presented in terms of the PM, aerosol species distribution, or the black carbon, they are all intensively validated with all kind of area types, rural or megacity or the urban locations over India. And they are, the estimates are well representing the observed data within normalized mean error of 15%. Yeah, the papers are already published, so maybe I missed to put the paper, so I can give you them.
Do we have any other?
I'll just take a small. So I'm a teacher, right? So when I teach and then I ask students that if there is any question, right? There are two possibilities: that you don't have any question, meaning that they understood everything, which I don't believe, at least with my talk, or they didn't understand anything, which is anyway bad for me. But then thank you, and it was a privilege to have here. Thank you.
Thank you. Thank you so much.
Thank you all the speakers, and thank you Ms. Sobia. I invite Anita to offer token of appreciation to all. Meanwhile, I have a quick question for all of you. Do we need a tea break? Okay, so I am continuing with the next session now. So, thank you so much everyone for your understanding and cooperation. Our last panel discussion session is on air pollution, what scientists communicate, and what public perceives. For this session, I would like to invite on stage Session Chair Ms. Divya Narayanan, Campaign Director Jhatka, and our panelists, Professor Abhijit Mukherjee, Professor at IIT Kharagpur, and Dr. Maheshwar Rupakheti, Research Group Leader, RIFS. Ms. Divya Narayan currently serves as the Campaigns Director at jhatka.org. She has a background in public health and human rights. She has worked in the grassroots and digital space for environmental and public health issues for over 10 years. Professor S.N. Tripathi won't be able to join us for the session. Over to you, Divya. Partha Bozo, sir will be joining us for the session now. Thank you.
Hello, good evening.
I acknowledge that it's the last session of the last day, so but we will try to keep it not only short and sweet, but also engaging as possible, because we have with us three very distinguished panelists. I would like to quickly introduce them. So I have next to me Professor Abhijit Mukherjee. He's currently a professor at the Department of Geology and Geophysics and the School of Environmental Science and Engineering at IIT Kharagpur. He also serves on the Council of Geological Society of America and also happens to be the first South Asian to do so. And he served as a physical hydrogeologist at the Alberta Geological Survey in Canada. For his work in groundwater, among several accolades, I want to mention one of the main awards among many awards I have here in my hand, is the Shanti Swarup Bhatnagar Prize in 2020, which is regarded as India's highest science award. Welcome, sir. We also have Dr. Maheshwar Rupakheti. He's a research group leader at the Research Institute for Sustainability at Helmholtz Center, Potsdam in Germany. He has 26 years of experience in atmospheric climate science research, notably in characterization of atmospheric aerosols and aerosol climate interactions. He was nominated recently as a candidate for election of the IPCC WGI vice chair position by the government of Nepal. Welcome, sir. And finally, we also have Partha Bosu. He's the lead India advisor for Environmental Defense Fund. He's also working as the principal of domain and functional advisory at LLP, a reputable consulting firm. He holds 20 years of experience of vehicular emissions expertise. He began at the Indian Automobile Manufacturers, Society of Indian Automobile Manufacturers, contributing to India's vehicle emission system. He progressed to the UN Clean Air Asia, leading efforts against air pollution. He also influenced Indian air quality agendas, pioneering walkability surveys, formed the Green Logistics Working Group, and launched Ind Air Repository. Presently, like I said, he's the lead advisory of EDF and directs USAID's Clean Air Catalyst, focusing on indoors air quality and hyperlocal hotspots protocol development in India. Welcome. So I want to start off by getting some opening statements from our panelists. So as you can see, our topic is what scientists communicate and what the public perceives. So scientific information currently on air pollution is, I would say, inaccessible to a large extent to the general public. It sounds so complicated a lot of times that they refrain from even approaching it. So what does the scientific community put out or release, and how is it interpreted currently? What is the current way the public is taking in this information or using this information, or maybe they're not? So what is the current situation? Let's start off with that. Do you want to go, Pat?
Actually, I will say that air pollution information or air pollution data is accessible. It's not necessarily comprehensible to everyone in every form. So in fact, there was those who work in the air quality data segment, they would know that there is something called OpenAQ. And OpenAQ in its previous avatar, when it used to get country data, actually India's data used to be one of the first data they used to get from the APIs. Unfortunately, for an website which is providing data for different countries, they had to stick to one AQI in order to convert those data. And in that case, they chose the Chinese AQI, and that led to Indian government pulling back the data and saying not doing that. But that was then. But now we have, and this is pre-AQI days. 2014, India got AQI. We started having AQI in India. My mother was very confused when this PM 2.5 data used to come. AQI is slightly better. I could at least tell her anything below 100, be happy. If it is Delhi, anything below 200, be happy. But then also it is complicated. In my previous role in Clean Air Asia, in Shanghai, we used a happy and crying baby face to communicate to the larger audience. we have to understand, although numbers are easy to understand, but it is very difficult depending on how many slabs do you have. There are few countries where there are 4 slabs. Many countries use 4 slabs. India uses something 6 to 7 slabs. Now that becomes too much. You have shades of purple. It's beyond the DMRC color code that we have in Delhi. You have pink line, violet line, purple line. So it's like that. So I think sometimes human faces, it also humanizes the data. It makes people understand it better. And it also connects and conveys what you are trying to say. You are trying to say, why did you develop the AQI first of all? You developed it because you want to tell your citizens that, hey, the air quality is great, go out and have fun. Or the air quality is not good, stay inside. So that communication, if the data is tough, I think sometimes a smiley face is good enough. I'll just pause here and, yeah.
Thank you so much, sir.
Yeah, thank you, Divya. Thank you, CSTEP, for inviting me here. I'll take this into 2 parts. In terms of data, not easily available for many countries. It's getting better. OpenAQ and others are making availability of the data better, but still in many countries, especially in the developing countries, the data are kept secret. And also some of the data's qualities are questionable. Even with the data available at the AQI, if you look at the disclaimer at the end, it always says that data are drawn from the different websites and the quality control of the data is not of the responsibility, their responsibilities. So it's getting better in terms of data, availability, accessibility, but there is a lot needs to be done, especially for the developing countries. And in terms of making those data into information that public can understand, I think there's a lot to do, especially we as a scientist, how we communicate our scientific findings that translates all the way to the form that people can understand. Parth said about imageries, some sort of spatial imaging or happy face or, other type of facial expressions, etc. Some sort of metaphor. People like to hear about what they care, right? So we need to make our information narratives in such a way that they feel immediate and belonging to those information. So that is a challenge, not only for scientists, for all people involved in making those sort of information available for the public.
Thank you, Divya, for inviting me here. First, a word of disclaimer. So I'm not an air person. I work in water. Okay, so my knowledge on air is, as much as anybody on the street, I suppose. But I suppose the bigger question lies the same: what scientists communicate and what public perceives. So, air and water both are natural systems. And when we work with natural systems, we natural scientists or managers or policymakers, we would, we'll basically talk about things which are reasonably high-end science, or we'll talk about policies that possibly only high-end managers would only understand. And many of the times, these discussions are kind of limited in journal articles, research reports, or in an air-conditioned room like this, right? The problem lies in the fact that how do you communicate that science, that understanding, that knowledge to the public? Because at the end of the day, they are the stakeholder. For example, I suppose the whole world now is talking about climate change. And you ask anybody on the street, climate change is happening and it is doing this and that and so on. But I honestly doubt, including myself, if we understand what climate change is and what causes climate change. It's a matter of fact that, climate change is happening, possibly happening, and there are effects that are influencing our daily life to a certain extent. However, not everything that is happening is climate change, and not necessarily that climate change is just a human-caused phenomena. Being an earth scientist, I can attest you, that climate change is a natural phenomena. It's more of an astronomical phenomena that happens every 10,000 to 20,000 years. So there are cycles, there are astronomical cycles, and we are literally moving from a glacial to an interglacial where we are supposed to warm up. No question asked. What we are doing as a human being are kind of accelerating it, triggering it for a higher gradient. And that leading to a climate condition that possibly would take 200 years to be reached in 30 years. That's exactly what we're doing. Now, how do we communicate that to the person on the field? A person, a layman who's possibly having a smallhold farmer on the ground. How do we communicate that to him? If I go and tell him that, don't do this and don't do that so that climate change does not happen, he would come back and ask me, do I get 2 rupees extra, just using that information? And possibly I would say no. But then you will have a year like this, like, the 2023, when we had this, stupendous heat wave that went through. And now we have a very, unlikely monsoon that at least I have witnessed, where the eastern part of India is almost dry and the western part is getting battled by, torrential rainfall. Now you go that and you tell the people that this is what climate change might be bringing. Now 1 year data possibly is not sufficient to prove that. But over years, if you show that, even a farmer, that, if you don't do that in your field, even in a small field, as a mohalla, as a gram, you don't practice these best practices, eventually this is what's going to happen. I suppose we have to explain, we have to communicate by experience, giving live examples to the ground, so that you can relate your daily activities, livelihoods, to those scientific outcomes.
Great, thank you so much. And you're absolutely right. Now that we've moved on to the section about talking about what we must do and what we have to do to get that information out there, I was in fact having a conversation earlier today during tea break that a lot of times when scientists maybe publish a report or put out any kind of data, people in the media often just directly copy-paste the press release. So they themselves probably don't understand what's written there, right? So that is not useful. So is there a need to sensitize not just the public, but media? Is there a need to even collaborate with, say, communication professionals? Like, how do you see this playing out? Because we don't expect, as scientists, this is your work and this is your job, and you are the ones who are the subject matter experts getting us the data. We don't expect scientists to come up with communication strategies. So what is the way forward then? Who should we be working with? What kind of maybe workshops should we be working with? Who are the different communities who need to be sensitized? Do they need to be sensitized in the first place? How do we choose these communities? Sorry, lots of questions here, but you can answer it as you see fit. Especially with using some of the examples from your own field would be useful.
So I have said this in many forums that when it comes to on paper, we as a country have everything. How it performs, how it boils down to activities and execution, that's a different thing. So the government of India did think about this at some point of time. Therefore, there is a body called NISPR under the CSIR lab. So CSIR, the Council of Scientific and Industrial Research, has 21 labs. One of the labs is dedicated for scientific communications. It's called NISPR. NISPR does what it is supposed to do. That is communicating the scientific work, the papers, the journals that's published, but they communicate it to the scientific community only. So the jargons remain as it is. They are not de-jargonized. There are writers who will write it and they actually publish them, republish it for people's understanding, but they are still scientific. They're still, in many, many respects, limited to that audience. So, yes, there is a very big need to have science decluttered, de-jargonized, made it simpler or simplest form and present it to the people, because air quality cannot be limited to this room. And I know for sure, and the communication professionals in the room, DST has a fund specifically on air quality communications. It is on science communications, but we can tweak it to air quality communications. It's a good start, so please apply.
Yeah, I think there is a great need for teaming up, and traditionally, I'm a physical scientist. Traditionally, what we do, we write a paper, and at the end of the paper, we put up some recommendations, and we think that someone else should pick it up and use it, right? So we should go beyond that kind of approach. So in my own project in Nepal back in 2012, we started off with going beyond science, right? Just doing science, especially with the air pollution related issue, which is such a multidimensional issue, multidisciplinary issue. It's not just about science and technology. It's about finance. It's about the culture. It's about the behavior. It's about the laws and regulations. So all sort of people should be involved in this kind of initiatives or issues. So typically we release a press release when you have a paper published or you have a blog written somewhere, and like you said, the media people just pick up a few lines from the press release and publish it, or we have social media or TV or other platforms. And we just try to convey okay, what we have published, what are our findings, right? I'm an aerosol scientist. When the IPCC AR6 came out, it just happened at the same time that we were sent an email with 100 words that we were suggested not to use when you are talking to policymakers and the press and other general public, and it was ordered in alphabetically, and the first word was aerosol, right? I'm an aerosol scientist. I spend whole my life, talking about aerosol, and that is the word I should not be using while I talk to public, right? Or the media or the policymakers. So when you say aerosol, general public will understand it as, the spray cans, right? The aerosol spray cans, right? In one of the, presentations today, we saw aerosol optical depth going up. There is a positive trend. As a scientist, I will understand what that means, right? But general public will understand that as something positive is happening, right? The negative trend, right? Something, bad happening. But that's how we should be aware of what we are telling, what we are talking about, right? So, if you Google now, let's say scientist and society interaction, you'll come up with a couple of images that will show that, a big, circle that is labeled as society, and there's a small circle out somewhere, and it's a scientist, right? So we are part of the society, right? So society and the scientists, both of us should realize that we are part of the one big society. I think that's the first thing we need to understand. The second thing is the storytelling, right? Storytelling, when you say aerosol optical depth has a positive trend, that doesn't make any sense to the general public, right? So you need to be a good storyteller. What are the specific approaches for the targeted audience that we could use different narratives to translate that into the language they understand, right? So second part is the storytelling. That's based on my own experience of doing this air pollution related project in Nepal. We teamed up with comedians in Nepal, and we made a movie, telefilm, and then we look into different aspects, cultural aspects and other aspects, and translated all this scientific understanding into the language that people understand, and those guys, the comedians, are very good at making that kind of narratives, right? So we need to team up with experts, and then all the stakeholders, I would say, we are all part of this issue, right? We should all work together to design these specific approaches and the narratives, including imageries and others that the general public would understand. That's the second part. The third part, maybe before I go to the third part, I'll give you an example. What we did before the movie was televised, and after the movie was televised, we wanted to conduct a survey to know, what people understand, or is there any change in their level of understanding about air pollution before the telefilm and after the telefilm was screened. So we wanted to, put a set of questions, and first few physical scientists like me, we put a set of questions, and then, we thought, okay, that's nice, right? And we gave those set of questions to environmental psychologists. And I was really surprised. All 10 questions were completely rewritten without losing the essence of those questions, right? That's where the meaning of teaming up comes in, right? So that one. And we found a really interesting change in the awareness, level of awareness the public would have before and after. So that is my third point, which is evaluation of the effectiveness of those communications. I think that should be also part of the whole, the game we have. So being a scientist, teaming up with the others, and then also evaluating the effectiveness of the, communication. That those three should be a part of the exercise. Thank you.
Well, sorry. I'll just highlight another aspect of what my esteemed panelists just said. Well, from my experience of working both in North America for a while as well as in India, so science journalism in India is in its prenatal stage. Okay, I suppose any journalist, again, not putting any aspersion on anybody, they can write something on science with an expectation that that would communicate some kind of scientific outcome to the public. Now, what happens on the way is that the message is lost in translation, right? So, what do you do? Well, I can just tell you some examples from my end. So, some of the studies that we do and which would get published, which does not just have a scientific outcome, but also do have a societal impact, we make sure that we give out a press release in a language that any common person, a class 10 graduate can even, read through it and understand. And then we will pass it on to our press team. Our institute do have a press team. And they would then take it up to the journalist with a disclaimer that before you publish, contact the author, so that, what they write and what we have been intending to communicate, there is a bridge. And so doing so, and in the last 10 years or so, we have published several of our research articles translated into the newspapers and in the electronic media. And there has been huge response, both in the public level as well as the administration level. Huge response, including some of the government policies kind of got influenced by that. So I believe the journalists do have a huge role in translating the science that we as a scientist, natural scientist, art scientist would do and how the public reads it. Now what we did back in just the pre-COVID time, like 2019 or early 2020, so in IIT Kharagpur, being one of the largest institutes in this country in terms of science and technology, we organized what we called a science journalist conclave. And in that conclave, what we did is, well, our press team did, so they invited both electronic and paper media or print media across the country, okay? And then they invited, some of the people who would be kind of publishing their outcomes in newspapers as presenters to that, forum. So what happened at the end of this, interaction is that at least for those studies and the journalist, there is a common bridge, and we know each other by face. So, of course, the COVID came and, a lot of things didn't happen which was supposed to happen. But I think 4 years down the road, I have a better connectivity with the journalist. I can give them a call and say, hey, you want to publish this? But this is what it means. So I can translate them like what exactly it means, possibly his or her native language, and so is mine. And doing so, I think the right message gets translated and propagated. And that is extremely important.
Great. Yes, go ahead.
When Dr. Rupaketi was talking about this film idea, actually two things came to my mind, and I Googled also one of the name. One movie was Sanjay Mishra starer Kadvi Hawa, which was just, I think, 2 years old. Just 2 years back it came out. And another was Hawa Badle Hasu, acted by Chandan Roy Sanyal in 2015. Both are post 2015, and both are on air quality and climate change. How many of us actually watched it, right? So, I mean, we as a community also have to, I mean, we hopefully when we'll go for a film, we won't go alone. We will take somebody who's not from the fraternity, and somebody will get to learn. So I guess that's also something, a role that we individually have to play. Just one.
Can I just add one point? You say something? Yeah, go ahead.
Yeah, just to add on to that movie thing, the movie we produced with the comedians in Nepal is called Dhua, Smoke, and then it's on YouTube. Many people have watched, probably hundreds of thousands have already watched it. So it does focus on air pollution in Nepal, but also has a regional context of air pollution. So please feel free to watch it. You'll enjoy it.
Well, on the contrary, I just mentioned that, not air, but water pollution. There are Hollywood movies, Oscar-winning Hollywood movies, that have been on water pollution. That includes Erin Brockovich, Dark Waters, A Civil Action, name any, And people have watched it, possibly not kind of getting connected that it is about water pollution on our backyard. All these movies are based on facts. Facts, some of it, like I personally have worked on, okay? But people never saw that as a factual event it's happening. So what do? As a teacher, I go in my class in groundwater management, and I give those movies as homework. I use this as homework schedules and ask my students to watch them and come back and tell what they kind of narrated.
Great, that's great. Thank you so much. Thank you for that. So we had a few great points come out here. One is that human faces humanize data, absolutely. Another one is to make it as relatable as possible, because while a lot of these movies, like you were saying, may seem like fiction, they are actually something that's happening in the real world somewhere. Because I personally work in communications. I work at jhatka.org. We work with experts and scientists to try and see how we can demystify air quality data in a way that gets people more involved in campaigns to ask for the right kind of policies for their communities. So this was really useful. Another one was, of course, how do we figure out ways to take all of this out of this room, right? And that's the whole point of this panel as well. And of course, evaluation of the effectiveness of the kind of information that we're putting out there. And how do we not lose the message in the process? That was a very important point as well. Thank you so much. I also want to now open the floor out for questions from the audience.
Thank you. Thank you very much, Sig Klimon from IASA. It's a question and a comment. I'm commenting on the movies, for example, because often they are one-off events. And I think one of the things that maybe you have not addressed in your comments were sustainability. So we need these messages being sustained to really leave an impact. And some of these movies are also a little bit of a blame game. And because they focus on a business that was bad, or they focus on the government that was bad. And I think that both climate change and air pollution is actually a distributed responsibility if we think seriously about solving it. It affects, I have to do something, and you have to do something, and the government and every business have to do something. And I think most of us are pointing to the others, that they should start. And that's quite a fundamental problem that is slowing down action significantly. And I think science has a role, and I don't have a recipe, but I think eventually we have to, and this was addressed in a couple of comments during this meeting, and thank you very much, CSTEP, for the meeting. It was really excellent, lots of excellent exchange. That education and reaching really to the youngest. they will be facing the problems even more severe than we are facing, as it seems. And they are the hope, and we have to probably put a little bit more effort as scientists to communicate with schools, teachers on a regular basis, so that the next generation is growing up really with this conscious understanding, not only what pollution is, but what needs to be done to solve it on all different fronts, because it is down to action eventually to change it.
I have to leave to catch a flight. Anubha, while the mic reaches you, I just wanted to say that Divya, in the spirit of that whatever is discussed in this room needs to go out, I just want to say that we don't have an event of this kind, of this magnitude, of this ingredients. We have everything here. We have all kind of stakeholders who are working in air pollution and climate change in this room, right? So I think this has a lot of merit. So we need to recognize this, and an event like this was very much required in India, and I think we should make sure that we participate and make it grow even bigger and farther. So I will just leave, and we should give a big hand of applause to the CSTEP team for that.
Thank you so much.
Can I?
Yeah, I totally agree with what Jiga said. That's where we need to team up with experts who are good at communicating the right message in a language that public can understand. So one of that includes, trying to, in a way, avoid, transferring the responsibility to the others, right? When you write something, when people read at it and said, okay, this is not part of government's job, and put everything to the behavior change. So when you talk about behavior change, it comes all the way down to the individuals, right? So we should always avoid transferring that, responsibility to someone else, right? It's not my job. It's someone else's job to control air quality. We should definitely avoid that. And also, that is also part of the messaging, right? You often see both negative messaging about air pollution and positive messaging about air pollution. And for example, if you say, I just take that as an example from Nepal. If you say that bad air quality kills 42,000 people every year. In other words, if you say that if we act now, we can save 42,000 lives, right? Saying the same thing. So like. Air is a common good, right? If you say, if you maintain some sort of activities, so that will clean the air, and clean air is good. So that kind of let's work together for a cleaner air. So that's kind of positive messaging. At least there was a survey in Europe. I have that they develop a toolkit on communicating air quality issues to the public, and that's part of the positive messaging versus negative messaging, and what sort of messaging has a better impact in terms of getting the message through the public and also leading to the behavior change. So that's where the team's team's composition and then the expertise has a lot role to play. So.
I had a question, and I just wanted to share some research work that we have done, and that actually is is adding to what was said by the speaker before regarding reaching out to the school children. We've done a study in Kanpur, in one of the schools, and we did a questionnaire survey, and the objective was to see how well aware the students are with the concept of climate change and sustainability. And we did it from class 6 to class 12. And we had roughly 750 respondents from a very good school, which is located within IIT Kanpur, where I'm from. And we found some very, very interesting results. And the most interesting thing I'll just share with you guys is that the students across the school, across the grades, they are confused between the concept of what causes climate change and what are the outcomes of climate change. So they think that climate change is the cause, And they think that one of the causes is actually the outcome of the climate change. And we've done an evaluation, a little bit of work also on looking at what is being taught to the students in the school in terms of the environmental education aspect of things. Some work has been done by some people from IIT Madras. We quoted them as well. So there is a lot of scope of work that needs to be done to be educating the younger people in our country regarding the concept of the causes and impacts and basically the concept of climate change and sustainability. A lot can be done on that front. So that's a small spiel on my side. I just wanted to share that because one person had just mentioned that reaching out to the school children is important. And the basic question I had was from Ms. Divya regarding your organization called jhatka.org. I was just looking it up online. I just wanted to know that if we want to be reaching out to some specific section and getting some information from them or educating them about some of the environmental issues we feel that they have in their locality, which we probably have investigated through several measures, would your organization be able to or willing to do that across the country? Or I guess I'm just asking a little bit of the scope of work from your organization. I hope that question is not too out of line from the discussion in this group. Thank you.
No, that's fine. Thank you. I appreciate the question. So one of the things that we do at Jhatka is also a lot of message testing. So we test out what kind of messaging is resonating with the audience. So this is also statistically sound. We find statistically significant results of the winner, and then that's then optimized for a larger audience. So that's definitely something we can do, is to see even within air quality, what are certain aspects of air quality that people find relatable? Is it health? Is it individual health? Is it child health? Is it maybe the inability to do regular work outside or play outside? So there are a lot of ways that we can figure out hooks and imagery that we can test with different audiences to see what works with them. So that's definitely something we can do. So do reach out. Happy to know more. Thank you. Thanks. Any other questions for our panel?
Yeah. It's both question, observation, and also coming from the experience that we work in, right? So I'm giving the example of the India Clean Air Connect platform that recently we've launched, and we did this as an ecosystem study to say, okay, who are these air quality actors working in this space? Of course, you have your traditional, we've got the scientists, everything. But why are people working in waste not associating themselves to air quality actors, being air quality actors? And I think a huge component of this was that there is no awareness to be able to start using these as indicators to fight for air quality via pushing for better waste management in a city. And I mean, this has been in the black spot map, the fire map, and all of that we also work towards. So I think that has been something to say that when we are talking about even decision making, it's different kinds, right? It's even organizations who may have technical knowledge but are still not picking up on it. And that's a problem because the ecosystem of doers also needs to increase. Yes, we have citizens at individual decision making, but can we fix at least the larger level of organizations working in this space itself? So that's probably capacity building more than just communications. And like when you look at media. Another interesting thing that we come across is, of course, the Clean Air Action Plans. Literally, government officials have just taken their normal roadwork budget and said, we'll put it in the air quality budget. Normal, waste management budget and put it into that. Without even understanding what is the correlation to air pollution, right? To the extent where they're saying, as a part of, just because I'm doing waste mapping, as a part of linking it in that air pollution data, I will also map DG sets. Like it's as mundane as that without really thinking through. So I just would like to understand, just going a little higher up on the people working on the solution side of it and what can be done to fix that, relationship between practitioners and scientists on ground, not necessarily only working on air quality, but the larger solutions linked to it.
Thank you. I'll start off with an example. In one of the sectors in Nepal, it's one of the major polluters, and then we wanted to bring them on board, because we like I said earlier, we wanted to go beyond science and involving all the stakeholders because this is such a multidisciplinary issue. And then, like I said earlier, you need to talk about the things that people care about, not necessarily people want to hear about, right? When you are talking about industries, economy, profit, that's the thing they want to hear about, right? And if you say the air pollution, emission, etc., they're always kind of reluctant to communicate with you, talk to you, because they think of, okay, this might be going to affect my business, right? So that's why you need to focus on what they care about. Right? And then that is, like I said, it's so immediate and engaging with them. So what we did is we wanted to talk with the association of that particular industry, and then for almost like 2 or 3 rounds, they didn't want to come and talk with us at all, right? So then we figured out, okay, you need to clearly talk about the goals. Okay, what are the things that you will also achieve if you also become part of this exercise? Talking about clearly articulating the goal. Is, what we said is, later or sooner, government has these regulations that they are going to come to you anyway, right? So if you have the data, scientific data available, then you have your strong position to talk to the government that, okay, these are our emissions level, this is where we stand, and then you can negotiate with the government, right? So once you clearly talk about the goals, these actors become a bit more relaxed, and then they would like to become the part of the exercise. And interestingly, what we found is we wanted to survey those sort of industries, and earlier some surveyors, they wanted to survey and they went to the factories, and they were not allowed to get into their premises at all. Sometimes even police were called and they were just taken away. So fortunately, after several rounds of discussion, we were able to survey, all those industries, all the environmental and social and societal, social aspects of their industries with their own leadership. We've only provided the technical support, they led the survey, right? So that tells me that clearly talking about the goals, objectives, and how they can also benefit and be part of the exercise, I think that's absolutely necessary.
Sorry. Maheshwar has already talked about the downstream side. Let me touch upon a little bit on the upstream side. So you talked about the ecosystem, or the ecosystem approach, right? So let me share an example, like I was talking about, on a recent study that we did, where me as a water person, collaborated with Professor Tripathi, who is a renowned air expert. So, we are aware of this Delhi smog every winter. And by now, everyone knows that the smog is mostly originating from the northwestern part of India, mostly Haryana and Punjab area. And potentially, it's kind of linked with the stubble burning, the wide-scale stubble burning. And it's a air pollution issue, it's a health issue, a lot of people are talking about mitigating it, solving it, manage it, and so on. But there are very few people who really ask for the reason for it. Now, when I was a child, I've traveled Delhi so many times, I can't recall such a smog, possibly before 2010 or 2008 or so on. So what happened? What really changed? That was a question that was kind of intriguing me. And then I started digging around, and this is not new, but it was kind of hidden under, a lot of published papers. See, the air pollution problem in Delhi and the surrounding region and downstream toward the eastern India is actually caused in a large way by groundwater management in the Punjab Haryana region. And you would say, like, how the hell is groundwater linked with air pollution in Delhi? Well, what happened is, groundwater, like another resource, is depleting very rapidly. And back in 2009, there was a couple of papers that came out from NASA, or the NASA scientists, which talked about large-scale groundwater depletion in the Punjab Haryana region. Okay, it was a great satellite mission data. And those data showed that out of the whole world, those are the hotspots, like that's where maximum depletion is going on. So what happened subsequently is the government went in and possibly through a knee-jerk reaction, they implemented a couple of steps on a very good will. I'm not saying that there was any bad intention. So what they did, they shifted the harvesting season by a couple of weeks. Good thing. So you get the rain-fed irrigation and, but what happened as a consequence is that the follow-up season for the harvesting, it kind of clashed with that. So the farmers who don't have a lot of technological interventions doesn't have a way to, clean up their, stubbles. So they're burning it out. So when you're looking at the ecosystem, and this is where I think science communication has a huge role to play, that it's when you talk about air pollution, may not be just an air pollution problem. It may be a problem with water, food, and air. So a nexus approach. And possibly that is what is required to solve a future, natural science problem.
Do we have time for more questions? We do.
I don't have any questions. Rather, I have some thought to share with all the panelists. Can you think of, of launching a kind of network, for example, India Clean Air Network, so where, all the experts, those who are sitting in this room, and our journals and articles are being published in the papers and the articles are being published in the journals, so that we can write or translate into some plain language summary and can reach out to the public periodically from our own endeavors. So is that possible, kind of India Clean Air Network or something like that? So that can be thought of. I don't know. That may not make sense.
I totally agree on that. I think that's the sort of platform is missing in many countries. There are some cities, for example, London has that sort of website where you will see some papers relevant to the air quality issues. That the results, scientific results, are translated into plain language that public can understand. And not only that, there are spaces where public can also provide the feedback on air quality issues, and where any ideas about their potential contributions to reducing air quality problems, etc. So some cities have practiced that, mostly in my notice, mostly cities from Europe. That is absolutely necessary. Not only translating these scientific findings to the plain language, but also providing different, what they call the toolkit, where people could see. There was a very interesting findings that having a greater coverage in the mass media doesn't necessarily lead to the behavior change. That's a result of the scientific study. On the other side, providing the information through the smartphones have led to the behavioral change, right? So we need to work on many different, like I said earlier, specific approaches. And some of these approaches could be inbuilt in that sort of websites. Thank you.
We have time for one last question.
Hi, I'm from Council on Energy, Environment and Water. So based on this discussion, we have already started an initiative in our organization. We have started a poetry thing, which is called Love in the Times of Climate Change, where we collaborate with a lot of poets and who will just express their feelings about love in this climate change, what they see there in childhood and what they found right now, and it outreached a lot of people. But what we found during that exercise, that most of the papers written in air specifically air pollution related, that is in English, that is not in a vernacular language. We are not reaching out the vernacular newspapers also. So we have to include vernacular language experts. We have to include influencers, because they can reach out more public than we can. And they are, that's why we need a platform where not only the researchers, NGOs, academicians, policymakers are there, also some of the influencers should be there, because they can influence public more than us. That's my point of view. Thank you.
Anything? No.
Definitely, I agree. You need to have the message in the vernacular language. Sometimes other side of me, I also, like to write poems, and I write on environmental issues as well, and also the romance and other issues too. And that's where I bring in my knowledge on Nepali to write something in a Nepali language, talking about air pollution or the crowd in the Kathmandu Valley or anywhere else. So that's an absolutely effective tool to communicate. Thank you.
Thank you so much. Thank you for the questions, and thank you for the audience for being so engaged in the last session of the last day. Really appreciate it. Thank you so much to the panelists for such an engaging discussion, and we really hope that the group that's sitting here today works together a lot more often moving forward. Thank you.
Thank you to the panelists and thank you to Ms. Divya. Now I would invite Siddharth to offer a token of appreciation to panelists and Ms. Divya. Moving forward, now we have come to the last session of the day, which is sponsors introduction. And so we have come to the last session of the day, which is sponsors and introduction. In this session, we will be inviting our silver sponsors, Aaron and Vasti, to talk about their products and organization. And they'll be getting 5 minutes to do so. Please come on the stage. After this session, we'll be announcing the results of student poster competition and also the result of photography competition. So please be with us. Please be with us.
Good evening, everyone. I hope you all are enjoying this. I hope you all are enjoying this event, getting engaged with different kind of discussion and the interaction. So first of all, I would like to thank CSTEP for organizing this event and providing us the opportunity to be the part of the sponsors team. My name is Vikas, and I'm from the Aaron Systems. At Aaron Systems, we are catering to the following sustainable goals, that is sustainable goal 2, 6, 7, 9, 11, 13, and the 14. So before I basically get into the offers that we have, like the air quality monitors and all, I'll give the brief introduction of the products that we make and the work that we do. We are basically an Pune-based aerospace company that specializes in the inertial systems and the Internet of Things. In inertial navigation systems, we basically provide the solution to navigate, control, and stabilize platform for aerospace, defense, and the automotive sector. And in the Internet of Things, we are the manufacturers of the data loggers that basically helps in designing the air quality monitoring systems, water quality monitoring systems, weather, flood, and everything. So this is, you can see the state of the global air, especially for the 2.5 concentration, and we can see the major concentration that we can find are mainly in the low or the middle income groups, which is mainly in, above the 35 microgram per meter cube. And the same in the same countries or the locations, the number of death is also very high. You can see that it's the percentage is like 11.6% of the death globally, and these are mainly concentrated in low to middle income countries. And if we look at by the number of deaths in India, you can see that air pollution is the major contributor to the number of deaths. Similarly, if we get more into details of the air pollution deaths related to India, we can see that although the number of deaths are decreasing, but there is a increase in the outdoor particulate matter that is leading to the number of deaths. But has been incredibly good work in the improved air quality, due to which the number of deaths are decreasing. Still, the number of deaths are there. So I would like to know, tell you like why do we actually care about it? We know that Einstein said everything is relative, and Darwin said everyone is relative. So that becomes our duty, like we should be taking care of our relatives. We all are connected with each other. We are breathing the same air. So if it is affecting me, it is affecting the other person also. Secondly, since every kind of pollution is relative with each other, every pollution is like whether there is a water pollution, it is linked to the air pollution. Whether it's related to the waste management, it is also related to the air pollution. So this is just the brief representation of how the evolution is going on in the terms of pollution. Initially, we know that when the industrialization started, the solution that we provided was the bottling of the water bottles. That time it cost around 20 rupees. Recently, there are some companies that are providing the bottled air so that we can breathe in those polluted areas. Now, last picture is quite familiar with everyone. We actually get to see in every pollution season that we can say from the October to November, February, where the visibility reduces up to such a level that even sunshine can't penetrate it. So are we really getting into the direction where we need to bottle the sunshine? That is the question. So in order to cater all these problems, so we started working in developing solutions in the air, for air quality, for the water quality, for solar and wind, along with the weather, agriculture, and the flood. So these are our different products for the air quality. First is for the indoor air quality monitoring. Second part is for the dust quality. And third is for the ambient air quality monitoring for the outdoor systems. Here we can measure all the parameters that you can see. It includes the particulate matters along with the gaseous parameters also. The devices, we always make sure that the data that we are providing is of high quality. These systems are highly customized solution where you can have any number of sensors that you want. These are enabled with the GPS system, and the communication can be done either through the wire or the wirelessly. This is the system architecture of the laminar, our air quality product. Here is the main, the heart of the entire device is the data logger that we make, and through this data logger you can connect different kind of sensors, whether it's related to air quality or the water quality. Second part comes the communication part. It is whether the wired communication or the wireless communication. So besides the device, we also have a cloud facility that in this you have the facilities for the dashboard where you can have listed all the devices wherever it is located. On the widget, you can always see the live values along with the AQI and everything. You can also visualize whether the system is working or not. All those visualization you can have the geolocation and the graphical view of. Secondly, the analytics part. Here you can have a multi-time analysis You can have a at different time periods, intervals. And thirdly, you can set up your own threshold limit. Third is the configuration part. You can always configure your device as per your requirement. Whether it's related to the dashboard management, you can identify the location and give a special name to it. We can also provide the alerts and notification, and accordingly you can get the reports generated. Now comes the sensor technology that we are basically using. For the gaseous pollutants, we have different technologies like electrochemical principle for the toxic gases, NDIR principle for the CO2 and methane, and thirdly, the PID technology for the volatile organic compounds. In the particulate matter, we are basically using the light or laser-based scattering principles. All these, we are always making sure all the sensors are with temperature and humidity compensation. Now comes when we talk about the accuracy and the reliability of the sensors. So these are the challenges we mainly face, like the cross sensitivity, drift, temperature and humidity effect, sensor variability, limited accuracy, the lifespan of the sensor, along with the linearity of the sensor. That is the most important thing. So in order to address these issues, we have decided to design a air calibration lab where we perform the zero gas calibration and the multi-point gas calibration. Here, what we do is we take the highly purified, high concentration cylinders and reduce the concentration of those cylinders to the ppb levels. After that, we have a setup designed where we actually put the sensors into the specially designed gassing hood where the air is moved linearly. And finally, in the analytics part, we actually identify the correct electronic signals so that it can provide the correct data or to identify the linearity of that. Through this lab, we are able to address the following issues, like issues related to the cross sensitivity, where after a certain time there is always some drift. To address that drift also, temperature and humidity compensation. It also helps in the data comparability between different devices, quality assurance. It also helps in the interpretation of the data with the confidence and better trend analysis to have a better mitigation strategies. Besides the air quality, we also provide solutions for the water quality. That includes 3 different kind of variants. First is the inline, basically for the WTP and STPs. Second is the submerged, where you will be using such devices in the processing tanks or the ponds. And third one is the floating for the open channel like rivers. Another product that we have is the weather monitoring system, where you can have different parameters like the radiation, albedo, air temperature, wind speed, wind direction. These are connected with the data logger that we have, where you can have a Wi-Fi connectivity and the wired communication. Overall, until now, we have actually covered around 20 to 25 gigawatt globally. These are certain pictures where we have our installation for the weather monitoring systems. This is our global distribution. We are getting our clients globally. This is our production and testing facilities, where we have a climatic chamber, rate table, and along with the calibration lab that I have already shown. This is our entire team working in different fields. So that's all the products that we have. And for more details, I welcome you to visit our booth, although the show is about to end. But okay, thanks.
Yeah, so now the results of student poster competition is here. We had received more than 60 abstracts for this event, and we shortlisted 15 abstracts and requested them to present their poster. So from the first round, we shortlisted 5 posters for the final round, and today we had 3 poster presentation. We will be announcing the 3 winners from the 5 posters presentations today. So for the prize distribution, I would like to call upon stage Dr. Abhijit Chatterjee, who will be distributing the prize money and certificate to the students. Yeah. So the third prize goes to Sarita from Central University of Himachal Pradesh. Second prize goes to Akanksha from IIT Kanpur. Do we have any guesses for the first winner? No guesses? Okay. So the first prize goes to Neha Singh from IIT Delhi. Thank you, Dr. Abhijit Chatterjee, for judging the posters. Participation certificate will be provided to others, and you can collect it from Vignesh Prabhu, who will be at the registration desk. Apart from the student poster competition, we had also organized photography competition, and the winner of the photography competition is Mr. Sumit from Chandigarh. His photo is displayed on the screen. Can we have it on screen? Yeah. So he will be awarded with the 2,000 rupees prize money. And with that, I would like to call upon stage Mr. Sameer to summarize the event today.
A very good evening, ladies and gentlemen. Today, the third day of the event started with the insightful remarks from the Honorable Minister Shri Ishwar Khandeji, who focused on more livable areas and the merits of the transition to carbon neutral economy and the importance of the life initiatives. Dr. Sen Gupta stressed towards the right technology solution for the cleaner cities and the better lives. The importance of the collaborative approach among the citizen, government and judiciary in providing clean air for all was highlighted. This was taken ahead by emphasizing the integration of the green spaces, efficient transportation system, advanced infrastructure to combat air pollution, with the fostering urban growth coupled with the rural semi-urban air quality management systems. An effective way to ensure we meet our clean air for all target is to have all the department convergence. Among numerous abstracts submitted today, we selected total of the 15 studies for the ICAS, of which we got the 3 winners who spoke about the advanced techniques in it, quantifying the toxic elements present in PM 2.5, real-time identification of air pollution sources, and estimating the health burden associated with the air pollution exposures. Panels saw presence of urban planners, architects, environmentalists, academicians, and the think tanks gathered to explore approaches to prioritize sustainability and the clean air, integration of the green spaces, efficient transportation systems, and advanced infrastructure to combat the air pollution. Furthermore, both representatives for both academics, industries, sponsors, sectors underscored the progress made in renewable technologies aimed at reducing emissions, digital innovations. These advancements hold the capacity to instigate the favorable transformation worldwide, influencing a diverse range of individuals. A comprehensive overview of the latest advancements in the air quality measurement and control strategies were also highlighted in the sessions. At the last, I'd just like to phrase one line here. कौन कहता है वायु साफ नहीं की जा सकती? This is a Khushwant Singh's poem which I have changed at the last moment. कौन कहता है वायु साफ नहीं की जा सकती? अरे ज़रा एक कदम तबीयत से तो उठा लो यारो, अरे ज़रा एक कदम तबीयत से तो उठा लो यारो. धन्यवाद.
Thank you, Sameer. Now I would request Dr. Pratima Singh to give a thank you note.
Jigisha is already excited with the end of the day and she's jumping off the stage now. It's end of 2.5 days, terrific 2.5 days, and I would want to take your time and thank a lot of people who were involved in curating this conference and making it successful. First of all, we would like to express our gratitude to all the speakers and participants who have been part on the online system and in person here to make ICAS 2023 a great success. A round of applause for everyone. Moving further, I would like to extend my gratitude and thank you to our funders, Bloomberg Philanthropies, Open Philanthropy, and Clean Air Fund, who have been supporting us, supporting our initiatives and studies in a very extensive manner. Thank you to them. I'm sure we have received some feedback on our QR code that is provided on the card. However, the feedbacks that I have received in person during the last 2 days were really, really brilliant, and I'm really thankful that people came and expressed their feedback. I'm just sharing one feedback. So yesterday, one gentleman came and he said, you know, the knowledge was just flowing. I felt like a boy in a candy shop. I have never heard such kind of feedback, and he was so excited that he said that I'm going to go back and tell my community, tell my friends that there is such kind of an event that happens, which is not only technical, but engages with the policy, engages with citizen group, engages on media aspects, so we should definitely attend it next year. I would like to show my gratitude to ISTA for partnering with ICAS and bringing in the aspect of technological understanding and communicating this to the policymakers. We also like to thank Swaniti and PGCA as our collaborators for ICAS 2023. A special thanks to our silver sponsors, Apollo Hospital, ESI, Assure, ESI, Vasti, and Aeron. Thank you for generously supporting us and being part of this event. I would like to thank our other sponsors, TSI, Airvoice, Envia, and Airveda. We would like to thank our event management partner, MTL, Lakshmi Patiji and Ishwarji. Thank you so much for all the support you have provided. And I would like to thank iBentos for handling the online platform. A big thank you to ASA team here, who has been continuously involved in curating the news, press articles, working day and night. This was brilliant. I can just rely on you guys anytime. Thank you so much. We are really happy that we could provide a platform to young researchers for presenting their research work, and really happy that they could come and join us here. Congratulations to our winner, Neha, Akanksha, and Sarita. A big thank you to our judges, Dr. Shweta Yadav, Dr. Prakash, Dr. Sachin, and Dr. Abhijit Chatterjee. I'd like to thank our speakers who found time from their busy schedule to fly down to Bangalore. Nationally and internationally, I would like to thank Clement, Professor Faye, and Rupa Keti sir. Thank you so much for finding time and coming here to be part of us. I'd like to thank Redison Blue for providing this space and making sure that everything is smooth and functional. I'd like to thank Irfan, the manager, Rajiv Jhaji for handling the IT system, and Sunny and his team for managing the entire hall. Thank you so much. We thank CSTEP's finance, admin, HR teams, IT team, Ram and Shrinu, and our travel manager, who have been working with us since last 3 months to ensure everything goes smooth. I especially want to thank Ms. Lalita, who single-handedly managed the logistics for this event. A round of applause for her, please. We thank CSTEP's communication team for their efforts and all the creative work for ICAS. You could all see on the banners standees, outside posters, whatever we have. I'd like to thank Preston, Sean, Alok, Bhavna, Pooja, Raghu, Shantini, Merlin, and Sri Rekha. We thank the executive team, Rajshri, Munish, Subbu, and Jay for their constant support and motivation. I'd like to thank Jay for his unconditional support and faith in me to organize this event. Last but not the least, I thank my incredible CAPS team who have gone through all the stress over the last 3 months and have also been bearing with me. They ensure that all the tasks are completed and we were able to organize this event. We all learn from each other and from the outside world. Every year we strive to improve ICAS in every way. We try to bring in an element of sustainability, and we will keep doing that and learning in this process. We will try to improve ourselves going forward. We believe that ICAS has initiated a shift towards improved collaboration. We hope to maintain this momentum and further the conversations with various stakeholders with innovative ideas, suggestions at this event. To facilitate the sharing of knowledge, we will be putting up videos of the event on our YouTube channel. Please do follow us on Twitter, Facebook for our future updates. We look forward to your feedback. Please scan this QR code and provide your feedback. That would really help us to improve in various ways. I would just like to quote David Attenborough, "No one will protect what they don't care about, and no one will care about what they have never experienced." We have experienced what good environment is, and we have experienced what bad environment is. So let us try to conserve whatever we can in whatever ways we can. Thank you so much for making ICAS 2023 a great success. Thank you so much.
Can you please gather near the dais? May I please request you to all of you to please come near the dais. We'll have a one group photo of ICAS. We'll request everyone's presence. Dr. Srikanth, you can come.